طيب, I think we'll start. بسم الله الرحمن الرحيم والصلاة والسلام على أشرف الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. Colleagues, ladies and gentlemen, Assalamu alaikum wa rahmatullahi wa barakatuh. I would like to welcome you all to this it's the 10th annual SSBMT conference. And again, this is sort of the 10th anniversary for these conferences that the SSBMT is organizing on an annual basis. And this annual meeting is held now for the past 7 years in collaboration with the EBMT, presenting highlights from the EBMT annual meeting. And it's in conjunction with the annual, or the 8th annual Saudi Hematology Oncology Nursing meeting or conference that will be held in conjunction with this meeting tomorrow. This year, the conference, and last year is being held during an unprecedented era or historical era of the pandemic, COVID-19 pandemic, which actually taught us a lot in terms of adopting and holding these virtual conferences, not hindering the learning process and updates and progress in research in general. What I would like to give you overview of these 2 days, and then a few remarks on the SSBMT achievements so far. And then we'll have Professor Nicholas Kruger, the president of the EBMT, giving his opening remarks. And then we'll have a short video about the SSBMT again, overview achievement, and then we'll proceed with our program. Our program today will cover various topics in the cell therapy, hematology, malignant hematology, stem cell transplantation, all updates and highlights of the updates presented in the latest EBMT and major conferences during the year. As you are aware, SSBMT has been established in 2008. However, this is the 10th annual meeting or conference, and it's the SSBMT was established with a mission to promote and enhance science, research, and proper practice in the field of specialization, which is the hematology, stem cell transplantation, and cell therapy. The members of the SSBMT has exceeded so far 2,500 from various countries, not only Saudi Arabia, mostly Saudi Arabia, however, the Gulf states and other Arab states in the region. Since establishment, the SSBMT tried to enhance the patient care and the care provided to our patients through various domains. One of them is the professional education, this is part of it. And the other is the clinical research and collaborative programs and public awareness in general. In the field of professional education, the SSBMT holds 6 conferences a year, in addition to various courses and workshops. So far, there has been more than 120 academic activities held over the last 10 years, more than 60 international conferences, and we had participation or contribution from more than 500 speakers at the local and international level, and we have more than 10,000 attendees attended these events. In the last year, since the pandemic started, actually, we have had more than 50 webinars, and that's attended by more than 7,000 attendees. And in addition to this, the webinars continues throughout the year, this year as well. And in terms of clinical research, the SSBMT, created a culture and enhanced the culture and the ecosystem in terms of research, encouraging paper presentation at local and international level, and have established the Saudi bone marrow transplantation registry, the SBMTR, and other blood cancer registries that's open as electronic database throughout the country. In addition, have established the Hematology Research Award, which will be presented actually during this meeting to winners who contributed in the last 1 year with a winning paper or research that has been shared or presented at international level. In addition, we have the collaborative programs, and one of the landmark collaborative program is the one that's held with the Saudi Stem Cell Donor Registry, and that's have helped having various programs and more than 80,000 donors registered, and more than 50 stem cell transplant helped by the SCDR at the local and international level. We have various collaborative programs with various entities, pharma industry, various societies. One of them is this meeting. This meeting is a result of one of the meetings, one of the collaboration that's held with the EBMT over the past 7 years, as I mentioned earlier. In addition, we have various activities in the public awareness, and we recognize all the contributions at the national and impactful contribution at the national and international level. So without overdue, I would like to invite Dr. or Professor Nicholas Kruger, the president of EBMT, to give his remarks, and then we'll show you a video afterwards. Please, Nicholas.
Thank you very much. Can you hear me?
Yes, please.
Thanks very much. So, dear Professor Ahmed Alaska, President of the Saudi Society for Bone Marrow Transplantation, and dear colleagues and friends of the SSBMT. So we are very delighted, so EBMT is very delighted to be part of this 10th annual conference of the SSBMT. So for many years, we have created this, let's say, friendly cooperative program to give highlights about the last EBMT meeting, but also about the new developments in the field, which has been presented also at other meetings. So my name is Nicholas Kröger. I'm currently presenting the EBMT as a president, but this is a warm welcome from all EBMT members and all EBMT leadership, which is a great honor and pleasure to be here also this year. I have prepared some slides as a short introduction. So I will give you just a brief, I hope you can see the slides and see me, yeah?
Yes, we do.
Okay, so the annual meeting 2021 from EBMT, the highlights. So unfortunately, like your meeting, which is unfortunately only virtual, also the EBMT meeting was only a completely virtual meeting this year. However, it was still a very successful meeting because we have more than 5,000 registration for more than 83 different countries. And even the Patient Family Donor Day, we had more than 130 registrations. And for the first time, we did a so-called personal qualification for stem cell transplantation and stem cell transplantation, which is the EBMT exam, which attended 76 members and also physicians. And I can assure the majority passed this exam with success. So you can see here many countries participate in the EBMT meeting, either as attendings, but also with presentation. And you can see even Saudi Arabia was quite active this year at the meeting. So the program was pretty interesting. So we had more than 178 sessions, 112 live sessions. The majority, however, was an on-demand session. So 67 were on-demand sessions, which fortunately can be also looked after the meeting for many days. And now it can be looked again on our e-learning platform, at least for EBMT members. We had some industry sessions. So the total presentation was more than 600, and the numbers of EBMT speakers was also nearly 500. So the abstracts was not as high as we have usually on an on-site meeting. So it was about 500. The total presentation was more than 200, and the e-posters was also more than 230. We have also a so-called e-poster area with more than 12,000 visitors, and the average per poster was about 20 per each poster. So we launched last year the so-called e-learning platform for EBMT, which was quite successful, especially because with the COVID-19 pandemic, traveling is not allowed. And most of the meetings took place in a virtual format, or the conference and video calls as well. So within this e-learning platform, we have a strategy to advance our online educations. So maybe you have attended one of these webinars, especially with COVID-19. And for all EBMT members have now access to this on free for webinars, e-courses. We have e-courses for pediatric, e-courses for infectious diseases in preparation for CAR T cells. We have a forum, and we have also preparation for the EBMT exam. And also most of the lectures from EBMT, and now you will hear in this meeting also some highlights presented from EBMT meeting. This can be again looked as EBMT members on this e-learning platform. Just to make you aware, you are invited to participate in what we call Go-Kart Coalition. This is something we created last year together with EHA to develop a strategic partnership as a global leader in cellular therapy for hematological disease. So this is mainly focused on CAR T cells, and we both societies joined the forces to bring collected resources in the newly found Go-Kart Coalition. And all stakeholders are welcome to attend, and you can see in our registry, this is by the end of the year. Now we have more than 1,600 CAR T cells procedures already registered in our registry. And here we can do in the next years and months valuable registry studies about real-world data in CAR T cell field. So I want also encourage the young members here and the young physicians or trainees who are looking to this meeting here, to this interesting meetings. So EBMT is now focusing on the next generation of transplanters and cellular therapists. So we create a so-called trainee committee, and this is very active meanwhile. So it's chaired by Claire Horrigan and Nico Gagelmann. And this was created last year. So they have already a high number of members. And if you want to contact, especially if you are young and you want to develop something in stem cell transplantation cellular therapy, you are really welcome to attend these meetings and to join them. Here is the email or Twitter. And just to give you an overview how active they are already. So they launched, and they have you can launch them on the social media. They create a so-called podcast with interesting lectures, and they will try to make a complete e-learning platform for trainees. So this is just to encourage the young and next generation, also here in Saudi Arabia, and the guests to participate in this endeavor. Just a brief what we do next, and which might be interesting also for you, is we have an EBMT COVID-19 summit only focusing on the corona pandemic, on the biology of the virus, how to treat the virus, how to prevent virus, about vaccination strategy. So if you're interested, join us on this virtual meeting, which is organized by the Infectious Disease Working Party in collaboration with other working parties. And then just a brief announcement for the next meeting, which is in Prague in March 2022. And I hope we can see then in person and to meet again. But for the time, this is all I want to tell you. I wish you now a very nice 10th annual conference on this SSBMT EBMT 21 highlight. I thank you for your attention, and I wish you a fruitful discussion. Thank you very much, and good luck.
Thank you, Professor Kruger, for sharing these actually highlights on the meeting, on the EBMT, and opportunities actually that could be definitely utilized by our members and to enhance training, collaboration, science in general. So this is definitely a distinctive collaboration that we have with the EBMT, and it's been wonderful and fruitful throughout the years, and we hope this will continue and continue to grow further. Thank you again. And again, back to our program, we have a video that we wanted to show over the next 4 minutes before we take you to start the program. Please present the video.
تأسست الجمعية السعودية لزراعة خلايا الدم الجذعية في شهر مارس من العام 2008 للميلاد كجمعية علمية مهنية غير ربحية. منذ ذلك الحين ولد اسم نما وتميز على المستوى المحلي والدولي في تخصص أمراض وسرطان الدم وزراعة الخلايا الجذعية، وبرؤية تتمركز حول بناء كيان مرجعي للممارسين الصحيين والمرضى والمجتمع بشكل عام في مجال تخصص الجمعية. تجاوز عدد أعضاء الجمعية 2500 عضو. تهدف الجمعية إلى تعزيز الرعاية المقدمة للمريض من خلال 4 محاور استراتيجية. المحور الأول في مجال التعليم المهني. تعقد الجمعية 6 مؤتمرات دورية سنوية والعديد من الدورات وورش العمل. تغطي كافة تخصصات أمراض وسرطان الدم ومهن أخرى تنتسب إلى مجالات الجمعية كالتمريض والطب التشخيصي في أمراض الدم. تهدف إلى عرض ومناقشة المستجدات المطروحة في المؤتمرات العالمية خلال السنة. تعتبر منصات لعرض الأبحاث المحلية والعالمية ولتعزيز التواصل بين منسوبي الجمعية وتأسيس العلاقات مع الجمعيات والهيئات العلمية العالمية والخبراء في مجال تخصص الجمعية. وتم عقد أكثر من 120 نشاطاً أكاديمياً، منها أكثر من 60 مؤتمراً دولي شارك فيها أكثر من 500 متحدث محلي وعالمي وأكثر من 10,000 مشارك. المحور الثاني في مجال الأبحاث السريرية. تسعى الجمعية لتعزيز بيئة الأبحاث عبر تحفيز التعاون البحثي بين المراكز الصحية في المملكة، المشاركات المحلية في مؤتمرات الجمعية والمؤتمرات العالمية، تخصيص مؤتمر سنوي خاص بالأبحاث، وجوائز تحفيزية للأبحاث الفائزة. أسست سجلات بحثية لسرطانات الدم المختلفة والسجل السعودي لعمليات زرع الخلايا الجذعية بهدف بناء قاعدة بيانات بحثية. المحور الثالث في مجال البرامج التعاونية. تبنت الجمعية العديد من البرامج. المشروع التعاوني المشترك بين الجمعية والسجل السعودي للمتبرعين بالخلايا الجذعية، حيث ساهمت الجمعية في تأسيس السجل وإنشاء فروع له في أكثر من 12 منطقة ومدينة في المملكة، مع دعم حملات السجل التوعوية واستقطاب المسجلين. وفي عام 2017 أسست الجمعية برنامج التعاون المشترك بين الجمعية والعديد من مستشفيات المملكة، حيث يتم إرسال استشاريين من أعضائها لزيارة المستشفيات في مختلف مناطق المملكة بهدف إعطاء المحاضرات ومناقشة وإبداء الرأي التخصصي في الحالات المرضية وتسهيل عملية التواصل والتحويل مع الاستشاريين في المستشفيات التخصصية. لدى الجمعية العديد من المشاريع التعاونية مع شركات الأدوية والجمعيات العلمية والمستشفيات المحلية. تم توقيع مذكرات تفاهم بين الجمعية وبعض الجمعيات والمؤسسات العالمية، حيث نتج عن هذا التعاون عقد المؤتمرات العلمية المشتركة محلياً، بالإضافة إلى تواجد الجمعية في اللقاءات العلمية العالمية لتمثيل المملكة. المحور الرابع في مجال التوعية المجتمعية. أولت الجمعية اهتماماً بإنشاء قنوات التواصل المتعددة مع المتخصصين ومع المجتمع. اهتمت الجمعية بطباعة الكتيبات والمنشورات التوعوية وخصصت مجلة تواصل الدورية. حرصت على إضافة المعلومات وإجابات الأسئلة الشائعة التي تهم المجتمع في موقع الجمعية الإلكتروني ومن خلال وسائل التواصل الاجتماعي والحملات التوعوية. بالإضافة إلى هذه المحاور الأربعة، أولت الجمعية اهتماماً بتحفيز المشاركات العلمية المتميزة، فأسست الجمعية 5 جوائز سنوية للبحث العلمي، وجائزة الإنجاز المهني في تخصص أمراض الدم تمنح للمتميزين الذين تركت إنجازاتهم أثراً على العلم أو المجتمع، تقديراً لجهودهم وتحفيزاً للمشاركات الوطنية في إثراء العلم على المستوى المحلي والعالمي. وتستمر جهود المخلصين من أبناء هذا الوطن ومساعيهم الحثيثة لتحقيق أهداف الجمعية، بما ينعكس إيجاباً على الوطن وعلى الرعاية المقدمة للمرضى.
Thank you. Ladies and gentlemen, again, we're happy to be back and happy to share with you that we have more than close to 1,500 registered. We have now close to 700 in attendance. Again, Professor Kruger, thank you for being here and thank you for the collaboration with the EBMT, and wish you all a fruitful meeting and enjoy the program. And I would like to invite our chairs for the next session, or for the first session actually, on cell therapy, Dr. Badr Al-Ahmari, consultant adult hematology and stem cell transplantation at King Abdulaziz Medical City of the National Guard Health Affairs in Riyadh, and Dr. Abdul Wahab Al-Babtain, consultant hematology and stem cell transplantation and cell therapy at King Khalid University Hospital, Riyadh. Please, you can start the meeting. Thank you again.
Thank you, Dr. Askar. Good to see you all again. Ahlan from the heart of Riyadh. Welcome to the first session of the 10th Saudi Society of BMT, with highlights, focused highlights on the 2021 EBMT. I'm Dr. Al-Babtain from King Saud University. I'll be moderating this session along with my colleague, Dr. Al-Ahmari from National Guard Hospital. It's a very interesting session and a hot topic in oncology, cellular therapy. Everybody is currently looking forward for more advancement in this field. We have 3 lecture presentations by renowned speakers today. Each lecture is going to be half an hour long, 25 minutes for the speaker, and the last 5 minutes basically is going to be dedicated for Q&A. So please don't forget to post your comments and questions in the Q&A section down in the corner. We'll be going through these after each lecture presentation. Our first presenter for today, Professor Alvaro Urbano Espazua, Needless to say, he's the head of the research unit of cell therapy and stem cell transplantation in Hospital Clinic of Barcelona. In 2007, he moved briefly to Sevilla to lead the Department of Hematology at the Hospital Virgen del Rosso. Currently, he's the director of the Institute of Hematology and Oncology at the Hospital of Clinic of Barcelona. Professor Alvaro has a prolific scholar activity record with more than 170 published articles in world-renowned journals in our field, with an impressive citation record, not to mention his leading role in major regulatory bodies and committees in Europe. Without any further ado, Professor Alvaro is going to be speaking to us about the Spanish experience in CAR T cell therapy. Welcome. Professor Alvaro.
Yeah, if I may initiate the video.
Yes, go ahead.
Well, okay, I will try it. No, it seems that I can't initiate the video, but I can share the slides. Not that I guess that it will be much interest for the people than my face.
Okay.
Okay. Do you hear me and do you see the slide?
Yes.
Okay.
We see the slides and we hear you clearly.
Okay. Thank you. Okay, so thank you very much for your kind introduction, and thank you very much for this to the Saudi Society of Blood and Marrow Transplantation for inviting me to present the experience in Spain in initiating an academic CAR program. And let me start with the motivation to initiate this academic CAR in Spain, and more in concrete in the Hospital Clinic of Barcelona. The first reason was that we were aware about the high efficacy of the CAR for patients with relapsed refractory ALL or non-Hodgkin lymphoma, and later in multiple myeloma. So at that time, CARs were not available in Spain. For that reason, we wanted to prepare our own CARs for our patients. Second is to maintain the academic freedom that we have enjoyed in cell therapy in general, bone marrow transplant in particular, meaning that we may incorporate the innovation, improvements with flexibility, quickly, when we consider that is for the benefit of the patients, with the only restriction of the regulatory rules. And third is the affordability. As you know, the cost of a commercial CAR is very high. In Europe, is around 330,000 euros per case. So that may put in difficulties to the health system, especially if the CARs are going ahead with in other indications and in other diseases. So we did consider that an academic CAR would have a lower cost and then more affordable for our system and for the patient. So we focused our attention in those CARs that are very effective in the clinical trials, mainly in B lymphoid malignancies, either in major ALL or major lymphoid malignancies, non-Hodgkin lymphoma, CLL, and also in multiple myeloma. So we focus our attention in preparing CARs targeting CD19 and targeting BCMA. So for administering, for preparing and administering a CAR to the patient, this is the procedure, starting with leukapheresis and selecting T cells by, for instance, immune selection, activating these T cells with anti-CD3, anti-CD28, incubating these activated cells with a vector, in general a lentivirus, incorporating a genetic construct that will be in the nucleus of the T cell, codifying for the expression of this chimeric antigen receptor, And after that is to expand these CARs to obtain enough number for obtaining a clinical benefit, a clinical efficacy in the patient. So for preparing our own CAR, we needed to prepare 3 elements. One is the vector, the lentivirus, with the genetic construct in its interior. Second is to have a bioreactor to expand these CARs. And third is to demonstrate the safety and efficacy of the CAR that we have prepared in-house. So to receive the approval of in our case, the Spanish Agency of Medicine for starting the first use in human of our own CAR. So this is the genetic construct that we prepared. First is for the CAR-19. We use the single chain variable fragment of a monoclonal antibody, A3B1, that we prepared 20 years ago in our immunology department. And for the CAR-BCMA, we use a G22.9 monoclonal antibody. We modified this monoclonal antibody and we humanized this single chain variable fragment of the monoclonal antibody. This fragment of the monoclonal antibody, either A3B1 or G22, was linked to a 4-1BB co-stimulatory molecule and a CD3 zeta, and this genetic construct was incorporated to a third-generation lentiviral vector. This lentiviral vector was incubated with T cells to incorporate the genetic construct to the nucleus. And so we tested whether this the genetically modified T cell was effective against the target. So this is an example of the CAR-BCMA in vitro. You may see how against multiple myeloma cell line, ARP1, the incubation with the CARs gives the death, the cytotoxicity in 24 hours, in 48 hours. And it is specific, it doesn't attack cells not having BCMA on the surface. So this is in vitro. So we did the experiments in vivo with mice. On the left, you may see how the mice inoculated with the multiple myeloma cell line developed a tumor that obliged to sacrifice the mice 1 month after the inoculation of the multiple myeloma cell line. In contrast, those mice that were inoculated not only with the cell line but also with the CAR-BCMA didn't present progression of the tumor, showing the efficacy of our CAR. This is the way of having the lentiviral vector is incorporating the genetic construct of the CAR, in this case the BCMA, with other plasmids to build up the lentivirus in a packaging cell, a HEC cell. For doing in a human scale, we needed to prepare a huge amount of these lentiviral particles. This clinical scale, human scale, is prepared in a GMP facility at the School of Medicine, the same building that in our hospital. Is a process that takes 14 days. And after these 14 days, we obtain enough number of particles for 18 or 20 patients. So we have the genetic construct, we have the enough lentiviral particles. What about the bioreactor? We started with wave system, a manual system, but we were aware about the Prodigy machine, closed system, semi-automatic. So we decided to go with this machine because it was more convenient for our purposes, and because all the procedures that I have mentioned, the T cell selection, activation, incubation with the virus, expansion, all these steps are performed within the machine in quite homogeneous and robust way. So you may see here how we started with 100 million of T cells from the patient, and how these T cells expand in number, and this is more in concrete about the numbers of CARs, how these numbers are apparent 7 days after incubation, and growing is increasing 8-9 days of incubation. So normally we stop the process here 8 days after initiating the process. So we had already the preclinical done. We had the system for expanding the CARs. So the third step is to go to the Spanish Agency of Medicine for approval of the clinical trials with these 2 CARs that we have prepared in our lab. This took longer than we expected. That was 1 year per clinical trial, so they were very picky in preclinical issues and in clinical issues. But finally, we obtained the authorization. The resources for the clinical trial is also very important. So we obtained the grants from the Ministry of Health and from the civil society, and these are the 2 trials that we have initiated for the CAR-19 for ALL and non-Hodgkin lymphoma, a phase 1 for pediatric and adults. ALL that we included 50 patients, is already closed, and we have very recently initiated a phase 2 clinical trial for adult ALL with modifications that we have or taking advantage of lessons that we have learned from the phase 1. We have also the clinical trial with RE2 for the CAR BCMA. The plan was to include 30 patients. They are already included, and we have also closed this clinical trial. So this is for the clinical trial phase 1. This is a quite standard method. It's just to administer the lymphodepletion with the fludarabine and cyclophosphamide. And the difference with respect to other clinical trials is that we fractionate the dose. So for ALL, we administer 1 time 10 to the 6 per kilogram, but 10% first dose, 30% of this 1 million second dose, 60% third dose to avoid the toxicity associated with a single shot, and 5 times to the 10 to the 6 per kilogram for non-Hodgkin lymphoma. One question is whether was enough the number of CARs obtained with the Prodigy. We analyzed that after 27 cases. You may see that the mean number after these 27 cases, the mean absolute number of CARs is 1,300 million of CARs per procedure. So just doing the calculation for an adult patient of 70 kilograms, that would mean 20 times 10 to the 6 per kilogram, or in a hypothetical children is close to 70 times 10 to the 6 per kilogram. So you may see that the numbers of CARs that we obtain after the expansion is much higher than we actually need for the clinical trial. This is the subpopulation of the CARs. Is 44% of the CARs obtained after expansion had a phenotype associated with long persistence, either naive, stem cell memory, or central memory CARs. Clinical results of this phase 1 clinical trial, most of the patients were adults, and 90% of these in relapse after allogenic stem cell transplantation. So you may see that in pediatric population, just 11 cases, but with a progression-free survival of 82% at 1 year. So similar or even higher, but the number is small than has been published by other groups. And in adult patients, and also as published by other groups, results are poorer, 34%, but not bad considering, as I have mentioned, that 90% of these patients were in relapse after allogenic stem cell transplantation. So in this very difficult situation with administering the CAR. 1/3 were alive and disease-free 1 year after the CAR administration. So once we finalized the clinical and we closed the clinical, we closed the clinical trial, we had several requests from other hospitals asking for administering the CAR. So we asked to the Spanish Agency of Medicine the approval for using as compassionate use. They accepted, and we have administered to several patients in this compassionate use program, paid by the Ministry of Health each case. Especially, so we have used this compassionate use for ALL and non-Hodgkin lymphoma not covered for indications that are not covered by the commercial CARs. So for instance, this is a female, 18 years old of age with isolated extramedullary relapse, bone marrow free, bone marrow negative, so no indication of Kymriah. And 1 month after RE1, the patient is in complete remission that she maintains 10 months after the administration. So with the clinical trial phase 1 and the compassionate use, we have treated 53 ALL patients, most of them adults. You may see that with RE1 in these 53 ALL cases, the toxicity is very low, is 11%, and ICANS, that is important, is just 2%. And this CRS was associated with high tumor burden and also a single dose. When we started to administer in 3 doses, the CRS was much lower. The 2-year progression-free survival is 1/3 of the patients were alive and disease-free, and this progression-free survival was the prognosis. The 2 prognosis factors more important were the tumor burden, to have 5% or more lymphoblasts in the bone marrow, and also to lose the B-cell aplasia. This is in the univariate analysis, and here you have the multivariate analysis. Here is for patients having less than 5% of lymphoblast. This is the disease-free survival, and as I mentioned, most of them are adults, and here for patients with more than 5% of blast in bone marrow. So we have initiated a phase 2 clinical trials. The main modification with respect to the phase 1 clinical trial is to add a second dose of 2 × 10⁶ per kilogram. So this is like the first clinical trial, 1 × 10⁶ per kilogram in 3 fractions, but trying to increase the persistence of the CAR and the efficacy of the CAR 7 days later. If the patient didn't develop CRS grade 3 or higher, we administer 2 × 10⁶ per kilogram. So this is, we have also administered for CLL cases, and here is a case that the patient came for a bone marrow transplant. Finally, she decided to go with a CAR instead of allogeneic bone marrow transplant. So she entered into complete remission 1 month after the CAR administration, and she is still alive and disease-free 3 years and 2 months after the CAR administration. For Richter, we have 4 cases that have with Richter syndrome that have received the CAR. All cases obtained the complete remission in the CLL component, and 2 of them in the lymphoma, in the diffuse large B-cell lymphoma. So the Richter component, 2 of the 4 obtained the complete remission, and 2 progressed, relapse. But of note, the relapse was CD19 negative. So I think that emphasizing the efficacy of RE1 also for CLL and Richter syndrome. And the second CAR that we have used in the academic setting is a CAR BCMA for multiple myeloma. Here we have centralized the production. It's a different strategy. We have the lentivirus is centralized in 1 center, but this lentiviral vector is distributed to 2 point-of-care centers producing the CAR, and we once the cells are produced in these 2 point-of-cares are distributed to these 5 hospital. So trying to decentralize the production of the car and the administration of the car. So the plan was to include 30 cases. We have already included them, and we have produced the cars in 2 centers and administered the cars in 5 centers as planned. Here, the protocol in this car BCMA is a bit different. What we do is to administer a higher dose, also fractionated, but this higher dose is followed 3 to 6 months after this first dose is followed by a second dose of 3 times 10 to the 6 per kilogram, trying to avoid the relapse rate that all groups have observed in multiple myeloma after CAR administration. This is just let me illustrate that the preparation of the CAR was identical in the 2 point of care centers. Here we split the leukapheresis of a healthy donor in 2 parts, and the proportion of CARs was identical with the first leukapheresis and the same with the second leukapheresis. So quite robust method, independently of doing in one or the other center. So we will present the data probably at ASH meeting, but just to illustrate the efficacy, this is a patient with after 5 lines of chemotherapy, refractory to the treatment, and just 1 month after the CAR administration, she obtained a stringent complete remission, and this response is maintained 1 year after CAR administration. Also is effective against plasmacytomas. Here is one man, 55 years old man with a plasmacytoma involving the eye, and here is after 1 month of CAR BCMA-AD2 administration, so the plasmacytoma disappeared. So what we have now, we have obtained now the hospital exemption from the Spanish Agency of Medicine to use RE1 as, let's say, commercial CAR for adult patients, for adult ALL patients, and we plan to go to the EMA, but it's a quite complex procedure and pricey. So we are thinking carefully how to do it. So just finalizing, just to acknowledge the multidisciplinary team, starting from the people involved in the preclinical part, immunology department for preparing the CARs, and intensive care unit, and other groups, and hematology, of course. So these are the institutions that have supported us with resources and also motivating us to go ahead with the project. And so thank you very much for your attention, and I will be delighted to answer any question. Thank you very much.
Thank you very much, Professor Alvaro. Let me put it simply, very interesting experience that you guys have, in many ways, actually. We'll start, asking questions as they start coming up. I can start with the first question. I can fulfill all of the questions for the audience from your talk. There are many, many interesting points. The fractionation, the idea of fractionation, or step up introduction of the CAR T cells, it's not something that we've seen before. Is this step was thought about because you mentioned to reduce the toxicity? I see, giving 2 doses to prevent relapse, but fractionation stepping up, is it to prevent the toxicity?
Yeah, you are right. So we started with just a single shot, just 1 times 10 to the 6 per kilogram, 1 shot. But the patient number 17, 18, and 19 with an acute lymphoblastic leukemia, high tumor burden, died. 3 consecutive patients died due to CRS. So we stopped the clinical trial. We had a meeting with the safety board of the clinical trial. So we decided to go with to administer just a small dose of CARs, because the quantity of CARs is associated with CRS. So we, for Specifically was for patients with a high tumor burden. We decided to start just with 100,000 CARs. If the patient does not develop a CRS, we administer the second dose. If the patient does not develop CRS with this second dose, we administer the third dose. So it's just to adapt the quantity of CARs to the reaction of that particular patient. But initially it was planned for high tumor burden, as I said, but finally we decide to go with all patients. So now we use this fractionated system procedure method for all patients, independently of having or not a high tumor burden, independently of being ALL or non-Hodgkin lymphoma, because CRS has decreased enormously, and this is very important not only for toxicity but also for the patient in terms of days in the hospital, not going to the intensive care unit. So now the person in charge of the intensive care unit has not seen in the last months any patient with RE1, so which is good for the patients. So I think that is something that we will do.
Grade 3 toxicity or more, less for CRS, less, around 11%, and ICANS is 1.9. Is the least to say is it's impressive.
Yeah.
It's a very nice experience. I mean, step up approach, whatever you guys are gonna call it later, is I think the rest of the industry is probably gonna adopt. I mean, it's a very smart way of doing things. Maybe you guys were unfortunate losing 2 patients in the beginning, but honestly, it's with these CRS and ICANS rates, and yet we need to see the clinical outcome when you guys go to phase 3 and make sure that it doesn't influence the outcome. But is there any reason why you guys picked up the 5 million dose initially? As you know, the commercially available CAR-Ts are in the range of 2 million, for lymphoma. So any comments on that?
Yeah, we started that dose based on previous experience of other groups. So for that reason, we fix 1 × 10⁶ per kilogram in ALL and 5 × 10⁶ per kilogram in non-Hodgkin lymphoma. That's the reason. So and having the patients, we think that the decision was fine, and we have keep that doses in our patients.
Excellent. Thank you very much. Any other questions, Badr?
Yeah, I do have a question. Excellent, Dr. Alvaro. Thank you so much for this nice presentation. My question is, I remember in the initial phase, you use like a semi-manual production of the CAR-T cell using the bioreactors and so on. So what makes you shifting into fully automated systems, knowing that it's probably more costly than the usual one? So if you can shed a light over shifting from the manual production into a fully automated system.
Yeah, thank you for the question. Yeah, it's cheaper to do it manually, but at the same time is more difficult to share with other hospitals the same method and the same results. So our idea from the very beginning was to have a method that could be, let's say, exported to other hospitals in Spain, and that could be done identical in the different parts. So, and without with no need of having a complex GMP facility, a team dedicated to cell processing, and with big experience, with a long experience in cell therapy. So so the Prodigy machine is, or the Prodigy or Lonza, Cocoon, or I think that Teramus also. So there are several methods to do it, and I think that this automatic is much simpler, is much more reproducible for other groups, and we have now 4 Prodigies, and so we use every week 3 of them. The 4th is just the backup. So doing manually, it would take much more people involved, and with and much more for assistance for treating patients. He is much, I wouldn't say relaxed, but I think that there are lower probability of some incidentals or some problems.
Excellent. Thank you very much. I think here in Saudi Arabia, we're in the process of initiating all of these, and I know Dr. Al-Ahmari and National Guard Hospital is working on that. That's your experience in Spain is going to help us greatly. Indeed, we'll be looking forward to follow your work and your group's work in the literature. Thank you very much, Professor Alvaro. We're going to move with our program to the second session, to the second presentation.
Okay.
Thank you very much. We have close to 800 attendees. That's excellent, right on time, because the next presentation is about the very exciting idea of CAR-NK that is possibly going to be off the shelf. We'll be hearing from Professor Eureka Kohl. She's a full professor of immune oncology at the University of Leipzig in Germany. She's also the director of Fraunhofer Institute for Cell Therapy and Immunology since 2017. She's also the director of the Institute of Cellular Therapeutic of Hannover Medical School since 2012. She has worked previously in MD Anderson. She's the international leading expert in cell and gene therapies, responsible for the first NK cell trial in Europe. She is currently heading the Saxo-Cell Cluster for Cell and Gene Therapy, funded by the German federal government. A very rich CV, and the go-to person for NK T-cell. Professor Kohl, thank you for joining us. Please shed some light on this very, very interesting topic that we're all waiting for. Thank you.
I will try my best. Thank you for the kind invitation. First, to start with the screen. Can you see the screen or not?
Yes, if you can just maximize the screen and put a presentation mode.
It's now maximized?
Not yet. Let's just give it a second. Maybe there is some lag. Can we get some help from our technical team, please? Okay. Help is on the way, Professor.
What I can try to...
if you can close it and open it.
You can press the presentation or just press F5.
Is it now working?
You
Not.
share your screen again.
Okay. Because we had that in the past, it was a problem if there are 3 screens. Is it now working?
Not yet.
Not yet.
Share your screen again, Doctor.
Yeah, I try it.
Doctor, go back to the Zoom and then share your desktop again.
Okay. You see it now?
Yes, Doctor, but press F5 or just go to the, click the presentation mode. The same, yeah, down, the same button.
Down in the corner.
Yeah, I know, but there is something on the screen, so I can't really touch it.
Okay.
About F5, is it?
Yeah. But it's always coming. Okay, now it should work.
Yes, yep. I think we're good to go.
I'm sorry for the delay. It's a problem for the future. It's a problem with 3 screens. We had that in the past. And what I did now to put away the laptop, that it's only 1 screen now. Okay, thanks again. Thanks for the kind invitation. And I will show you a little bit the journey to CAR NK cells, which is for sure behind the CAR T cell story. This is my disclosure. We are in the area of the fascinating advanced therapy medicinal products. You all are aware over the last 15 years, several of these cell and gene therapy products really reached marketing authorization. And we have been a little bit a small puzzle in that whole story. On one side, at my Fraunhofer Institute, we are running centralized manufacturing as an example in a very nice cooperation together with Novartis, where we have done now more than 500 CAR T cell products. But we also have experience on my university side with decentralized manufacturing, what we have already heard very nicely from Alvaro, where we're also running a small phase 1 trial for patients with melanoma with CAR T cells in a good cooperation with Miltenyi Biotech. But we are looking also forward to reach non-viral transduction for CAR T cells in a cooperation with Michael Rudicek, or try hard to bring CAR NK cells also to our patients. And this is what I want to show you today, a little bit the clinical benefit and limitations in NK cell trials. Start first. National killer cells compromise to 2 to 80% of lymphocytes in the peripheral blood. They have 2 subpopulations, the immunoregulatory and the cytotoxic NK cells play a major role in killing of tumor cells, especially against MSC negative targets. And they have important receptors on the surface. Here in green, the so-called national cytotoxicity receptors and the receptor NKG2D, which directly binds to MIG-A. And if you activate an NK cell with cytokines like IL-2 or others, these NCRs are upregulated, also NKG2D, and this directly binds to MIG-A on the leukemic or the tumor side and start killing of the leukemic target. Very long time ago, we and others had very good experience using allogeneic NK cells, also from third-party donors off-the-shelf NK cells in clinical trials. This is a very nice cooperation with Jakob Passweg from Switzerland, where we purified NK cells from the respective stem cell donor, expanded them, and on day 3, 40, and 100 after stem cell transplantation, the patient received NK cells from the respective stem cell donor. To make a long story short, not only we, also others could nicely show here, our colleagues from US and from the Scandinavian area as well, that manufacturing of those donor NK cells is possible, and also in these phase 1-2 trials we all could show that it's safe without severe side effects. And this is probably the most important results of the study with Jakob Passweg on the right at the bottom. Also with increasing giving numbers of those NK cells, we did not see any severe side effect. Only if the impurity, the number of contaminating allogeneic T cells was too high, if it was higher than 25 or 50,000 T cells per kilogram body weight in this haploidentical situation, we saw a GVHD. And we could also clearly demonstrate that IL-2 stimulation leads to improved NK cell cytotoxicity. However, we also saw a lot of disadvantage, tumor immune escape mechanism. And for both, I want to show you 2 examples. This is from the beginning, a child suffering from AML stayed in blast persistence very early on after first haploidentical stem cell transplantation, and after a second haploidentical stem cell transplantation with additional NK cells reached for the first time complete remission. But this did not really last very long, and the patient died in relapse. And so the reason are a lot of different tumor immune escape mechanism here nicely shown for patients with head and neck cancer, where we screened 67 patients, and could show here on the left side, you see for these both NK cell subpopulation, I already mentioned there is a difference in these subpopulation between healthy controls and patients with head and neck cancer. There's a disbalance in those patients regarding the subpopulations. And in the middle, you see, I mentioned that NKG2D on the NK cell directly binds to MIG-A on the tumor side, and tumor immune escape, as an example, is that MIG-A is shedded, and the soluble MIG-A can bind to NKG2D and at the NK cell, and then the NK cell is not able to bind to tumor or leukemic burdens. And this is dose dependent, as you see in the middle, and also we could show other mechanisms like TGF-beta, which also hampers NK cell activity. And so early on, we asked how to overcome those hurdles. Are CAR NK cells a good possibility? And in the meantime, we redirected NK cells against different cancer epitopes. And you cannot only do that with NK cells, it's also possible to bring that on donor macrophages or on donor gamma delta T cells. But we stayed with the NK cell side, and I want to show you in the second part of my talk now to move from personalized medicine in CAR T cell therapy really to allogeneic CAR effector NK cells, and show you first our own preclinical results and then end up with a very nice international study. As already mentioned, the different important mechanism between NK cells and cancer cells. If you combine that with a chimeric antigen receptor, you have really these national cytotoxicity through the NCRs and the NKG2D, which can complement CAR-mediated direct killing, what you have already heard from the CAR T cell side from Alvaro. However, if you look more into detail on the NK cell side, there are on one side the same intracellular mechanism like on the T cell side, but you have also other mechanisms like DAP10, DAP12, which gives rise for more possibilities in these intracellular signaling and to make different CAR constructs at the end. At the beginning, we started with the same endodomain we have already used in our clinical trials on the CAR T cell side, and started with a CD28, 4-1BB, and CD3 setter for the signaling, made a codon optimization, and then we looked which is the best option to transduce these NK cells to make a good CAR on the surface. And on the left side, on the bottom, you see a comparison between alpha retroviral vectors, gamma retroviral, and lentiviral vectors. Lentiviral vectors, and especially alpha retroviral vector, make a very good transduction efficacy. It doesn't work as well with gamma retroviral vectors. And on the right side, you see a typical single cell cytotoxicity assay, flow cytometric based, where in red and in blue you can see the difference between targets and the NK cells. In the first row, activated NK cells against leukemic targets, and the third circle is the reaction between both of them. And cytokine activated NK cells clearly could eliminate around 75% of the leukemic cells during 48 hours. But if you take really redirected CD19 CAR NK cells, as shown here in the middle, you see more reaction between targets and effectors. And we clearly could demonstrate that all of the leukemic cells could be killed in between 48 hours. And we could also nicely show that with using anti-CD19 antibodies, it's possible to block that reaction. It's not only possible to contaminate, to make a good CAR on the NK cells with viral methods, as already mentioned, with own results. Here's a very nice overview that also non-viral method, piggyback transposon, Sleeping Beauty technology, mRNA transfection, even DNA transfection, astrocytosis can also make very good CARs on NK cells. And in the next step, we also redirected that against AML for bridging to transplantation. And similar what I have showed you for ALL, we could also demonstrate activated NK cells were able to have good cytotoxicity against AML cells, but CD123 redirected CAR NK cells could nearly completely eliminate them. And again, this has been able to block with the respective monoclonal antibody. And running a lot of those experiments, in red you see that always these CAR NK cells have better killing activity compared to green, the activated NK cells only. We also did that against patients' own AML cells, freshly isolated AML cells from our patients. And here in red on the left side, you see that these CAR NK cells have a good cytotoxicity, and you see no difference between different controls, EGFP or MOC control. And we also checked side effects against a lot of different organs and normal lymphocytes, here as an example against the lung cell line. And there we could demonstrate no difference between the CAR and the CAR construct and the respective controls. And here in a time-lapse movie, you see in green the CAR NK cell, which is able to attack the AML cell and completely destroy the cell. You see, it really goes completely to apoptosis. It's really visible. And if you do the same with a control on the right side, now in orange, the activated NK cell, it also attacks, binds to the leukemic cell, but the leukemic cell stays round and stable and is not destroyed at the end compared to the left side. And in the next step, we did similar what also Alvaro showed you for the CAR T cell side, and what is also in our small CAR T cell trials on the Prodigy, that we brought CAR NK cells now on the Prodigy, similar to the protocol I already mentioned, with the CD3 depletion and 56 enrichment, and then the cytokine activation over 12 days. And we could show in the chamber of Prodigy very nicely the growth of these CAR NK cells. And on the bottom, you see the expansion curve, which is similar to the CAR T cell side that we reach after around 10 to 12 days, a 30-fold expansion. And after 14 days, it goes up to 18-fold expansion of the CAR NK cells. But I all know that you are mostly interested in the translation to the clinical side, and you are aware that worldwide there are more than 800 ongoing CAR T cell trials right now. If you also count all the closed CAR T cell trials, that it's a lot of more than 1,000. And here for the CAR NK cell side in 2019, we collected that in a review, it was a little bit more than 20 clinical trials. Of those, half of them redirected against CD19, also bispecific CD19, CD22, and the others addressing different other tumor epitopes. And now very currently done by Miltony, a very nice summarize of the CAR NK cell trials. It's now 35, so 1.5-fold more. And what you can nicely see, there are different kind of sources to make CAR NK cells. NunQuest in US is running NK92 trials with the NK cell line. Fate Therapeutics is doing CAR NK cells based on iPS-induced pluripotent stem cell derived CAR NK cells. And most of the trials are done with peripheral blood or leukapheresis CAR NK cells, as I showed you also our results. Here on the right side, a lot of them in the Asian area, but also some in US. And there is only one NK92 trial in Europe right now. And on the bottom, you also see a very nice trial. I will report on that a little bit more on the last slides. Cord blood-derived CAR NK cell trial from Casey Raswani. And this is a first-in-human trial of CAR NK cells in patients with relapsed refractory B lymphoid malignancies. She used also the CD19, CD20 Zeta cassette with an ICAS9 cassette, and very important, included also an IL-15 cassette for long-term persistence of CAR NK cells in the patients. And you see on the right side the very good overall and event-free survival right now. In this small first trial, she included 11 patients, 8 complete and 1 partial remission, and very remarkable, no graft versus host disease and no cytokine release syndrome or neurotoxicity. And she and her co-workers also postulated that one CAR NK cell product is possible to take for up to 100 patients. And here, more the clinical results before treatment. You see the burden, and on day 21, the nice clearance in a patient suffering from CLL, which received 1 × 10⁶ CAR NK cells per kilogram body weight after lymphodepletion. And very remarkable is here these long-term persistence in both in the peripheral blood and the bone marrow of the patients in green and in red, you see on the left side, and even shortly after application of these CAR-NK cells, really first an increase in these CAR-NK cells in the patients, very nicely detectable. And the question is, why doesn't she see any cytokine release syndrome? We and others, here are our results, checked a lot of cytokines and pro-apoptotic molecules in CAR-NK cells. We found anti-inflammatory, pro-inflammatory, and pro-apoptotic molecules, and in both in the immune regulatory as well as the cytotoxic subpopulations. But these profile completely differ really from the CAR T cell side. And this is really a complete other story. And this might be, it's too early to say that really, but it might be the explanation that right now in these CAR-NK cell trials, there is not really report about severe cytokine release syndrome. And so I want to conclude and give you a small outlook. For allogeneic NK cells, we and others worldwide can show in existing clinical trials that allogeneic, even haploidentical or even third-party NK cell application is possible and safe. There is clearly a GVL effect without GVHD, but limitations due to tumor immune escape mechanism hampers the whole story of those normal NK cell application. And so if we move to the allogeneic as well as the off-the-shelf CAR-NK cell products, I showed you in this preliminary data that elimination of CD19 or CD123 positive leukemic cells by CAR-NK cells is clearly possible, and better results than using activated NK cells only. And this remarkable clinical trial from Casey Raswani really showed successful first clinical favorable cytokine profile and low risk of CRS. And also the benefit right now is promising. And if you look more on the mechanistic side, national cytotoxicity through these NCRs and the NKG2D can complement CAR-mediated cell killing. And so I think the improvement of CAR-NK cells in the future is a combination of CAR-NK cells and possible also immune checkpoint inhibitors. And also what I mentioned, going from vector transduction to the non-viral format, that CAR-NK cells with transient cytokine secretion might be a very good clinical option in the future for bridging to transplantation. And so at the end, I thank to a lot of different co-workers, some of them I've already mentioned. And I thank you for listening, and I'm open for questions.
All right, thank you, Dr. Ulrich. This was an excellent presentation. So I have a question regarding the contrasting the CAR T cell with CAR NK cell in terms of production feasibility. Like the isolation of those immune cells and the production of those cells in terms of difficulty or obstacles in producing such cells. Why would NK cell be probably better than CAR T cell? Okay,
very, very good question. And to my opinion, we will need both. On one side, national killer cells are innate immune system, and T cells are clearly adaptive immune system, and so more specific. And these really great results on the CAR T-cell side gives rise to improve that. But what we and others also see, I mentioned I've done now more than 500 CAR T-cell products right now, is really that we realize manufacturing failure. And this is clear because these are heavily pre-treated patients. They have a lot of chemotherapy and there is a exhaustion in the bone marrow, they have bone marrow failure, and they have really also exhausted T cells. And if you have really patients not in a very good condition, you cannot end up with a very good CAR T cell product in this personalized medicine. And there you definitely need, and this is in some reports goes up to 17%. In median, it's about 12% manufacturing failure. And this clearly shows that we need for our patients also alternative options. And we and others have shown that allogeneic NK cells from healthy donors is easily to transfuse without any severe side effects. So you can make a good CAR NK cell product. However, NK cells are more sensitive and more problematically to grow and especially to cryopreserve compared to CAR T cells. Yeah, so I would not recommend completely to move from CAR T cells to CAR NK cells. Yeah, to my opinion, we really need both. We need NK cells as an alternative program, and especially for those, let us say, as an example, patients suffering from AML. Yeah, we all are aware patients with AML which are transplanted in remission, they have a very low possibility to survive. And if you can really bring with CAR NK cells, there I definitely would go with allogeneic CAR NK cells, yeah, because there I need only a transient CAR expression for a while to really bring patients into complete remission up to the time point of transplantation. So at the end, for me, I think clearly we need both, but for different indications and for different reasons.
Thank you. Dr. Abdulwahab, do you have any question?
Yeah, just a small question. You know, everybody talks about the big limitation for NK T cell, CAR NK cells being the. What do you think about the NK exhaustion as a limiting factor for this modality?
Okay, it depends for sure. Mature NK cells don't survive years like T cells. That's clear. What I showed for the example of Casey, you can have them lively for months. That's possible, but not for years. And there are also possibilities if you not start with really mature NK cells, if you take immature NK cells, then you can even prolong the survival of NK cells. So it depends what is the indication, yeah? But I would never expect that with one application, like on the CAR T cell side, you have really a remission for years. You definitely will need NK cells for multiple applications, yeah? But if we think about cord blood derived or iPS derived or even pooled peripheral blood leukapheresis CAR NK cell products at the end, if you can make a product for multiple patients, you can also have it for multiple applications. So it's a question what you really want to reach at the end, yeah? And for sure, you have them in line. For the CAR T cell side, if you make it personalized, yeah, you really have to start with the leukapheresis, make all the product and give it back. We all are on the way to optimize, shortening the protocols. We are now in a couple of days, but also there, the patient has to wait for the respective products. If you go allo, it's ready to go in the freezer, yeah?
Yep, thank you very much.
Okay, thank you very much, Dr. Ulrich. This was really a great talk. We will move on to the next speaker. It is my pleasure to present Dr. Peter Bader. Dr. Peter Bader is the professor of pediatric in Johann Wolfgang Goethe University in Frankfurt, Germany. Dr. Peter research interest is focused on the preemptive strategies to prevent relapse of malignant diseases post allogeneic transplant and the development and application of innovative cell therapy. Dr. Peter, the microphone is yours, please.
Yeah, thank you very much for this kind introduction, and it's a great honor for me to be part of the faculty at this SSBMT, EBMT highlights meeting 2021. And you got me, so I would like to start sharing the screen, but it's blocked at the moment. So, okay, now it's fine. Thank you very much. So it is my pleasure now to try to meet your expectations when you gave me this this topic, allogeneic transplantation after CAR T therapy. So my question was, I thought it's better to put a question mark here. And so I tried to go through and show you the data and give my opinion to this. So these are my disclosures. So I have some advisory boards from Novartis, Celgene, Amgen, which might be relevant to this presentation here. We all know that in the recent years, we have made substantial progress in the treatment of patients with acute lymphoblastic leukemia. This is true in children and in adults. We have, however, the problems of patients who do develop second relapse, who are refractory in the first attempt, or patients who are not eligible for transplantation with a high risk profile, but also for patients who relapsed after allogenic transplantation. And so far, allogenic transplantation is the gold standard in the treatment of the patients with high risk ALLs. So, and then this topic entered the stage, CAR T cells, and these are photos taken from one of our patients in Frankfurt, and it was the first girl, Amy Whitehead, who received these cells in 2012, and the report at the ESH meeting really brought big pharma into the field to develop these type of treatment and give us a chance to offer this for many of them, not only for small numbers of patients, but for a vast, large patient population. So we in Frankfurt, we have had the privilege to participate in this worldwide licensing trial from Novartis, where the product tisagenlecleucel should be studied in children and young adults with refractory acute lymphoblastic leukemia, or patients with a second relapse, or patients who relapsed after allogenic transplantation. And you do know these results, they have been published in the New England Journal of Medicine in 2018, and this shows the picture. And I think this comes back in many results I'm going to show you, and this also matches more or less what Alvaro has shown you, although I must say the results in the adults are a little bit inferior, but roughly 60% of these multiple relapse and absolutely refractory patients could be rescued for a long term with the CAR T cell treatment. And recently, Stefan Grupp has given at the ESH meeting in 2019 real-world experience out of the North American registry, EBMT, and we will be able in Europe to give these results as well, as soon as you have seen in the presentation of the president of EBMT, Niklaus Kröger, who showed that 1,600 cellular CAR T cell treatments are registered in the EBMT register already, which is a great achievement. So are the real world data matching what we saw in the Eliana trial? Yes, This is true. In fact, ELIANA trials or clinical trials, the patient population is always a little bit more defined, and so probably a bit less risky patients than the real world evidence. But you can see here in these 154 patients who received CAR T cells in North America for the relapsed ALL patients, you see it was possible at day 28 to achieve a complete remission in 85%, and whereas it was in the ELIANA trial 82%. And these patients who do develop a complete remission at day 28, they are also MRD negative. So these are really excellent and encouraging results. And then you see the event-free survival at 6 months, 66 and 71%. The overall survival is quite high, 87 and 89. And it's remarkable that we do not lose patients due to treatment-related complications, or if this is a really rare event. For the pediatricians in the audience, it's also very interesting that in the real-world evidence, so children were included who received the treatment while they have been less than 3 years of age. Then you can appreciate here, these were 11 patients. 9 out of 9 did have safety sets and efficacy results. And you see that 8 of these 9 patients do develop a complete remission. So it's also feasible. And this group of patients was not included. This was not included into the ELIANA trial at the time the licensing was. So what is our experience in Frankfurt? Only a few slides. So far, we should have treated 38 patients. And you can appreciate here, 32 of them, or 84%, they have had a previous allogeneic transplantation. So clearly, this is the absolute high risk feature. The age was 1 year to 33 years of our patient cohort. We did also have some with extramedullary disease, which is also treatable by CAR T-cell treatment, and this could be discussed later on maybe. So Ulrike Köhl mentioned that there are production failures. Out of these 38 patients we wanted to treat, in 3 of them, so a little bit less than 10%, a transduction failure occurred, and there was 1 patient who needed 2 attempts to generate the CAR T cells, and then finally the patient developed a progress of the disease, and we could not offer the treatment to him. So altogether, we treated 34 patients so far. And this has been mentioned by Alvaro as well, and this is coming more and more clear, that the leukemia load by M1 or M2 marrow, MRD negative or not, becomes important not only in the context of allogeneic transplantation, but also in the context of CAR T-cell treatment. So you can see here patients with the indication for CAR T-cell treatment. They received the bridging chemotherapy till the product was generated, and then before we start the LDC, which means the lymphodepleting chemotherapy, we always control the bone marrow once again. And if the patients are in hematological remission, by this time, 53 of them, they have an excellent prognosis, and 90%, almost 90% of these patients are alive, 80 of them in remission. However, patients who do enter the lymphodepleting chemotherapy with a large leukemia load, this is problematic to treat them. But obviously, it's not a matter of the number of leukemia cells, because the CAR T cells, they do expand millionfold. So no, this is a surrogate marker to describe the resistance of the leukemia, the impossibility to induce apoptosis in these leukemia cells. And this is the mechanism to destroy the leukemia cells. So this translates then into the Kaplan-Meier estimates. All patients at 18 months, so let's say around 52% event-free survival. However, if we have a look in those with M1 marrow or M2 marrow, then you see the difference. At 2 years, the event-free survival is 60%. And this translates to the overall survival, which is 60%, as in the licensing trial as well. And you can divide those who do at least in part respond to the chemotherapy, the leukemia, who is responsive still a little bit. They have an excellent chance to be cured of more than 90%. And you must imagine more than 80% of these patients here, they have had a relapse after allogeneic transplantation, and I come back to that later. So I mentioned it, we do not lose patients at the CAR T-cell treatment as we do, unfortunately, if we are using allogeneic transplantation. So the non-relapse mortality rate is there higher in the transplant setting. So the relapse, this remains the major cause for treatment failure, and we discussed this with Ulrike's talk and Alvaro's talk before. I think there is cell, let's say, CAR immune cell related issues. We could improve the vectors, that we could increase the expansion, and sometimes we have a lack of persistence. We could use strategies to block PA1. And the question is whether this might be a treatment bridge to allogeneic transplantation. So maybe these patients should, when they did achieve a remission, be treated with a second or first allogeneic transplantation. And I will know this is the topic of this is the task you have given to me, and I'll try to comment on this. So what is literature saying? So the first publication from Memorial Sloan Kettering, published from Park and colleagues in New England Journal in 2018. This includes roughly 56 adult patients only. So what did they found? Okay, this M1, M2 mirror, MRD negative complete remission, this looks to be predicted. These are adult patients only, which is true for event-free or overall survival. And it does not matter in these patients whether the patients were treated after the CAR T cells with an allogeneic transplantation or not, neither for the event nor for the overall survival. However, there are other data. These are data from Crystal McCall's group from the NIH in Bethesda. So this slide was presented at the ASH meeting 2016, and it shows the results of 50 patients who were treated with a CD28 co-stimulatory domain CAR T cells directed against CD19. And so the problem of this CAR, the co-stimulatory domain, is, I mentioned this sentence here, that in the presentation in the old days, no CAR T cells were detected after day 68 in any patient. So, and that means, so if the CAR T cells does not persist, the remission will not last long time. And this is the red line. So if these patients with this CAR are not treated with a second allogeneic transplantation, then they will not survive the disease. However, it's excellent to induce remission, and you can achieve then with an allogeneic transplantation a good result in survival. And 2 weeks ago, or was it last month, this publication, this study was then published in the Journal of Clinical Oncology. And what we can see here again, authors did not show the Kaplan-Meier of the patients who went for allogeneic transplantation, but it was the vast majority of those who did achieve a remission at day 28. 80% of these patients went on for allogeneic transplantation. But what matters really, again, it's not the time from date of CAR infusion and relapse, but it is a lymphodepleting chemotherapy given, so allowing the CAR T cells to expand. But it's again and again the question whether the patients did respond to the bridging chemotherapy and have a M1 or M2 mirror. As you can appreciate here, the overall and event-free survival is strongly dependent on the fact whether these leukemia cells are still susceptible for any type of treatment. So the question is CAR T-cell the right treatment as a bridge to transplant? And I might doubt this really, because you may have seen this publication from Franco Locatelli from the Intreal group, Pediatric Relapse Treatment Consortium. And the question here was, in patients who relapsed after, who developed a relapse and were then treated by induction chemotherapy and were candidates for allogeneic transplantation. So they were randomized in patients to receive blinatumomab, a CD19, CD3 B-specific antibody T-cell engager, and induces T-cell response, T-cell destruction of leukemia cells, or whether they might benefit from chemotherapy before allogeneic transplantation. And what were the results? These results clearly show if we do induce remission with immunotherapy, T-cell engaging by the antibody, then and do treat the patients with allogeneic transplantation, so they have an excellent chance to survive. So therefore, I think it's not the fact to use the CAR T cells as a bridge to treatment. But what is after transplantation, if patients do relapse after allogeneic transplantation? So these were the 84% here. So then patients who relapse after allogeneic transplantation, they could normally not be rescued. So what we do see here is the result of a study published by Michaela Kuhlen of the patients who relapsed after allogeneic transplantation out of the ALL-SAT trial, which was published in Clinical Oncology. And you see only 10 to 20% do have a chance to survive. And the only chance for them to survive is a second allogeneic transplantation. And these are data from the EBMT, Pediatric Disease Working Party, showing that patients who made it to a second allogeneic transplantation and received it in remission, then they have a chance of 33% to survive the disease. CAR T cells, might they be better here? And I think so. These are the patients in our cohort, overall the patients who relapsed after first allogeneic transplantation were then treated by by CAR T cells, and you see how good their survival is. Overall survival of these patients who respond to lymphodepleting chemotherapy, receive their CARs, they do have a survival of 90%, and those who are really absolutely refractory, they could not be cured, neither by any attempt. So, are there other factors which might be relevant, for the outcome of the diseases? And I think, yes, there are patient and leukemia factors. The leukemia resistance, the ability of shedding the antigen, leukemia cells were so resistant, they do lack caspase 9, could not be brought into apoptosis by that factor. But there are also patient factors, and this was mentioned by Ulrike earlier. And this is why she opted for allogeneic CAR T cells and NK cells. So apheresis or T cell factors of the patients. There is no apheresis possible. There are transaction failures. There are out of specification issues. So the question is, are we able in the assessment of the patient to predict whether his or she or the T cells of the patient are able to be successfully transduced, expanded, and do show a durable response? Why is this important? Because many of these patients, they do develop, were treated after allogeneic transplantation so far. During the licensing trial, this group of patients could be included if they were off half a year. So, and you can see here, after 6 months, this is the immune regeneration of a patient after allogeneic transplantation. It takes up to 1 year till the full T cell repertoire is there again, and naive T cells are there. So, and if you go back even earlier, after 3 months, or let's say if the patient relapses after 30 days, it is clear that this T cell compartment is totally different, and this supposedly might influence also the response to the treatment. And so therefore we have started a project characterizing the T cells of the patients by investigating the beta T cell repertoire. We look for the T cell differentiation, look for exhaustion markers, PD-1, LAG3, TIM3, and see whether these T cells of the patient are able to proliferate after appropriate stimulation with CD328. And then you can read out this here, the other generations of the cells. So this is actively proliferating T cells with the capacity. Why is this important? Because if you see the lack of persistence of the CAR T cells, then when we arrive here, 0.5 per microliter, 0.2 per microliter, this probably might be the concentration of the CAR T cells, which avoids that B cells are coming back. So lack of persistence, early lack of persistence, as in this patient after day 84, this leads to a relapse of the patients. And to give you an example, this is a young girl which we treated in the age of 3 years. So she was diagnosed 2018, so in the first year of life. This is a clear infant leukemia, first combined relapse, which did not respond to any treatment, neither to blinatumomab, nor to either FLAG. We could just bring her into aplasia. Then she received allogeneic transplantation from an unrelated donor, conditioning fludarabine, triosulfan, thiazepam, and this went really smoothly. And the patient was in remission with a wonderful immune regeneration. However, 3 months later, she developed a fulminant relapse. And so we discussed what to do with this patient now. And as she has it already after 3 months, which is not usual, already 3,270 T cells per microliter, we checked the repertoire. And you can see here in this young patient, it was a virtual normal V beta repertoire. So we thought, okay, might be it's an option for the girl to receive the CAR T cell treatment. And we checked the proliferative capacity of the T cells, and at least for child generations was there a few naive T cells. So we decided, yes, let's try. We let these performed an apheresis, performed a CAR T cell transduction. Probably these cells were generated in Leipzig by Ulrike. That is possible, I don't know, but they work perfectly. So the patient was not in the remission at the time she received the lymphodepletion. But you see at day 7, day 9, day 12, so the T cells, CAR T cells, were exploding. She has had, after 12 days, 2,400 CAR Ts per microliter. And the leukemia poofed away. The patient regenerated, and she was doing excellent. She recovered, and she has a lot of persisting CARs in the peripheral blood, in the bone marrow. And so we followed the immune regeneration. She had T cells, she had CAR T cells, NK cells, a few, but no B cells, which was wonderful. Day 40, and then it arrives day 85, and then we saw, okay, CAR T cells, they are low, 0.6%, and there were no B cells at all, wonderful. However, what happened here? This girl and this leukemia shedded all the CD19 from the blasts. So blasts, as you can appreciate here, were CD19 negative, CD22 positive. So I think here we have wonderful CAR T cells, a huge expansion, a persistence of the CAR T cells, but inherited leukemia resistance mechanisms, which we so far cannot overcome. With this, I'm at the end of my presentation, and I sum up. CAR T cell therapy is extremely effective in inducing remission. It's currently, for me, the clear treatment of choice in patients who relapse after allogeneic transplantation. Unfortunately, relapse remains the cause for treatment failure, and this was my first presentation 30 years ago when I entered this field and say, okay, after allogeneic transplantation, relapse is the major cause for treatment failure, and this is still true today. What we do observe is CD19 negative relapses and lack of persistence of the cells, inherited apoptosis resistance mechanisms of the leukemia cells, which we cannot overcome with this approach. Neither this nor the chemotherapy. I do not consider consolidation by a second or allogeneic transplantation the treatment of choice for CAR T cells who do show and which do have the capability to persist long-term. Long-term means more than 6 months. However, as a bridge to transplant, this might be possible for non-persisting CAR T cells. But if we use it, in my opinion, blinatumomab is easier to apply, is cheaper, is broadly available, and this heralds excellent results. CAR T cell treatment should serve as a standalone therapy. Further improvement by checkpoint inhibitors studies, vector improvement, other cell types, maybe allogeneic CAR T cells, or by a better patient selection that we do treat only these patients in whom we do expect the persistence of the cells, and we are running these studies to try to find out what's the necessary precondition for these patients. So this is a transplant center here in Frankfurt, Pediatric Transplant Centers. That's my team. I'm very grateful, and I'm also grateful for all the colleagues who send their patients to our center during the licensing studies. And with this, I'm at the end of my presentation, and I'm happy to take questions.
All right. Thank you, Dr. Peter, for this excellent presentation. Nice illustrated data about examining the T-cell potency pre-CAR T-cell collection. So because of the time limitation, because we have an upcoming session now in a few minutes, so I have only one question for you, yes. Dr. Peter. Many transplant physicians would always ask themselves a question about whether to proceed for blina, then transplant, or to go for CAR T cell. And most of them, they're afraid that the blina could somehow affect the efficacy of CAR T cell in case the blina failed to do the job of clearing the leukemic blast.
Yeah, that is true, and this has been published as well. However, so these publications, for example, did not, or this might have a bias. So because there were also patients included who received blinatumomab, sometimes in their treatment way, even before allogeneic transplantation. Then the patient relapsed after transplantation and got then CAR T cell treatment. And I think this is not the appropriate way to assess this, because then the immune system might be different. And the fact that these patients did not only see chemotherapy, but also inotuzumab or blinatumomab might be even more an argument that the leukemia has advanced in their resistance profile.
All right. Okay, thank you so much, Dr. Peter. And I'm sorry again, because we have to move on now. So now I would like to thank Dr. Peter for this great presentation. Yeah, now we have a prayer break, and we will be back at 10 minutes past 4 for our next session, which will be the most awaited session, the award presentation for hematology research. Thank you so much, and we'll see you in 10 minutes, inshallah.
بسم الله الرحمن الرحيم. السلام عليكم جميعا. Welcome everybody. On behalf of the Saudi Society of Blood and Marrow Transplant, I would like to welcome all the audience in the second session of today's meeting, the 10th annual conference of the Saudi Society of Blood and Marrow Transplant with EBMT Highlights 2021. I would like, in this session, I have my co-chair with me, Dr. Mohammed Shahrani, who is a consultant in pediatric hematology, oncology, and bone marrow transplant at Prince Sultan Military Medical City, Riyadh. He is the vice president of the SSBMT, and he is the president of the Saudi Society of Hemophilia. He's also president of the Saudi Society for Thalassemia and Sickle Cell Disease. I am honored to co-chair this meeting with him. Dr. Shahrani will go over the agenda before we start the session. Dr. Shahrani.
Yes, hi, hello. Thank you so much, Dr. Ayman, and welcome everybody, and thank you for the SSBMT. We will have the three winners today will be announced by Dr. Ayman for the research, and after that we have three sessions this afternoon. Each session will be 25 minutes. So this is the second session.
All right, thank you. As mentioned, at the beginning of the second session, we will be announcing the research awards. The Saudi Society of Blood and Marrow Transplant has encouraged research in multiple aspects. And one of these aspects is forming a committee to review research publications that have been submitted for research award. This year, 3 research papers were selected as the winners for this year in different fields of hematology, basic research, clinical hematology, and transplant. So, I mean, if we were physical, we would hand over the winners their their awards, but now we will just announce them virtually, and then the awards will be sent to the winners after the meeting. So the first winner in basic research field is Dr. Dunya Jawdat, who has published in HLA typing. Her paper was HLA A, B, C, DRB1, DQB1, and DBB1 allele and haplotype frequencies of 28,927 Saudi stem cell donors typed by next generation sequencing. Dr. Jawdat is the director of the Saudi Stem Cell Donor Registry and Cord Blood Bank at King Abdullah International Medical Research Center. Congratulations, Dr. Jawdat. The award will be sent to you shortly. In the second field, in the clinical hematology, the winner this year is Dr. Mus'ab Damlaj, who has gained this award based on his work and his research, which was published, titled Optimal Preemptive Cytomegalovirus Therapy Threshold in a Patient Population with High Prevalence of Seropositive Status. Dr. Damlaj is a consultant in the Department of Oncology Hematology, Division of Stem Cell Transplant and Cellular Therapy at King Abdulaziz Medical City, Riyadh. Congratulations, Dr. Mus'ab, for your exemplary work that was published in the field of clinical hematology, and the award will be handed to you after the meeting. The third winner is in the field of stem cell transplantation, and the winner is Dr. Ahmed Al-Askar, who is well known in the hematology field. His paper that has been selected as a winner in transplant is entitled The Outcome of Fludarabine Busulfan Antithymocyte Globulin, FLU-BU-ATG, Conditioning Regimen for Allogeneic Hematopoietic Stem Cell Transplantation. Dr. Askar needs no introduction. He is a professor in adult hematology and stem cell transplant. He is the executive director of KMAR, King Abdullah International Medical Research Center, and he is the president of the Saudi Society of Blood and Marrow Transplant. Congratulations, Dr. Ahmed, and we'll give you the award. Without any further ado, we'll go on to the next session. And the first speaker in the session is Dr. Nicholas Kruger. His talk is about multiple myeloma, focusing on the role of allogeneic stem cell transplant. Dr. Kruger is a professor of medicine and medical director of the Department of Stem Cell Transplantation at the University Medical Center, Hamburg, Eppendorf, Germany. He is the president of the European Society of Blood and Marrow Transplant, EBMT. Dr. Kruger is well known and needs no introduction, and he will enlighten us about the role of allotransplant, which is not an easy task in multiple myeloma. Dr. Kruger, the screen is yours. Go ahead. Dr. Nicholas.
Yeah.
Yes.
I need, yep.
Can you share your slides?
Sure. Just a second.
All right, we can see the slides.
Okay.
But we cannot see you. You can open the camera.
Let me see, but you can hear me at least.
Correct.
Okay. So it's better to start to see the slides rather than me, if you don't mind.
Fine, go ahead.
Yeah. So first of all, thanks a lot, Dr. Ayman and Dr. Al-Sharani for the nice introduction. And you are right, this is a difficult topic to tell at this marvelous meeting. So once again, first of all, if you don't mind, I would also congratulate the 3 winners of the SSB awards this year. So congratulations. So I was asked to give a task, the role of allogeneic stem cell transplantation in multiple myeloma. These are my disclosures. So when you look back, and this was actually the first report about allogeneic stem cell transplantation in multiple myeloma, and this is a presentation, only a poster presentation from 1986. So it's now 35 years ago. This was the first report about allogeneic stem cell transplantation in multiple myeloma. I show this slide only because it shows you even 35 years ago, what were the problems in treating multiple myeloma patients by allogeneic stem cell transplantation. And this is kindly provided by Michele Cavo. All the others are still retired, by Michael Cavo is still active. And they report about 3 patients who received allogeneic stem cell transplantation with myeloablative conditioning in multiple myeloma. And what we reported actually is it's 3 patients. So 1 patient died of therapy-related mortality. 1 patient received relapse after a couple of years, but 1 patient is still alive now 30 years after the transplant. So, and this led to then the seminal study by Gösta Garton. This was already in 1991 in the New England, showing here we have a high therapy-related mortality, but we have maybe a plateau here in about 40% of the patients. And nevertheless, despite this early work now more than 35 years ago, allogeneic stem cell transplantation has not found its place in the treatment of multiple myeloma. I will give you in the next minute some overview. What is the status today, how we can improve, what is the future, if there's any, for allogeneic stem cell transplantation in multiple myeloma. So also autologous stem cell transplantation, which is actually still the standard care of treatment with induction, maintenance, maybe consolidation therapy. Ultimately, the majority, or if not all patients, will experience relapse and die from the disease. So as shown in this previous slide, so allogeneic stem cell transplantation might be a curative treatment approach, but there is a high risk of non-relapse mortality driven by the conditioning regimen, but also because of the therapy-related complications, mainly graft versus host disease. And when we look to the registry is the EBMT registry is actually reflecting the current use of treatment, of transplant treatment in Europe and worldwide. So here on the right-hand side, you can see autologous stem cell transplantation. And you can nicely see that more than 50%, nearly 60% of all autologous stem cell transplantation procedures nowadays in Europe are done for plasma cell disorders, and this is mainly multiple myeloma. But when we look to allogeneic stem cell transplantation, you can see that the percentage of plasma cell disorders is only about 2% of the cases who are receiving allogeneic stem cell transplantation. The majority still is acute myeloid and lymphoid leukemia, but also more recently MDS and MPN. So why should we do allogeneic stem cell transplantation? Well, there's a benefit, and this was already published in 2000 and 1999, is actually the depth of the remission. Although in this study, which used minimal residual disease here measured by immunoglobulin heavy chain rearrangement, they could show, both study groups should show that after allogeneic transplantation, in patient in complete remission, in both the rate of molecular remission was significantly higher than after an autograft. And when we look to EBMT data registry, including more than 70,000 myeloma patients, you can see the major problem still is relapse, even after allogeneic stem cell transplantation. Here, if you use it as an upfront single or either as an auto-allo upfront, you can see the risk of relapse here after 10 years still is between 51 and 75%. The risk of relapse is higher in autologous stem cell transplantation. Here, either a single or double transplantation, it's between 74 and 80% of the cases. So there is a difference, and the difference is mainly caused by graft versus myeloma effect. So because of the less toxicity in using a combined auto-allo approach, several study groups compared this auto-allo approach to tandem transplantation in newly diagnosed multiple myeloma patients. And here you can see different study groups. These were all prospective studies, mainly using HLA identical siblings, and there was not a clear randomization in all the studies. It was more what we call biological randomization. If there was an HLA identical sibling, then the patient should go for transplant. If there was no, then he received autologous stem cell transplantation. So in yellow, you can see the significant difference between both arms. So first of all, in nearly all studies, the rate of complete remission was higher after auto-allo. Event-free survival was only in benefit in 2 of these 6 studies, and overall survival was only in benefit in 2 out of 6 studies. In all of the other studies, there was no significant difference between auto-auto or auto-allo. So more recently in the study we completed, we used also, after this randomization or biological randomization between so-called autologous transplantation and allogeneic stem cell transplantation, we used some maintenance therapy, at this time with thalidomide, and in allogeneic stem cell transplantation, also donor lymphocyte infusion. And we presented first results at the last EBMT meeting. So we included more than 200 patients 200 received first auto, a second transplant was performed in 178 patients, but you can see the majority received allogeneic stem cell transplantation, because in this study we included also matched unrelated donors. And in our countries, the likelihood to get an unrelated donor who is completely 10 of 10 matched is pretty high. So only 46 patients received an auto. Here you can see the results after 10 years. So it looks like there's a difference of nearly 20% in event-free survival. However, due to the low number of patients in the auto arm, this difference was not significant. So after 8 years, after allogeneic stem cell transplantation, we still have about 43% who are disease-free. In the auto arm, it was only 21%. However, 8-year survival is pretty good. So after 8 years, still 50% are surviving, or 55%, but there was no significant difference between auto-allo and auto-auto. Most strikingly is the maintenance therapy. Here you can see patients who received the maintenance therapy allogenic with thalidomide. This is the corresponding autologous arm, while these are patients who are received auto-allo or auto-auto, but without any maintenance therapy. Here you can see the survival, suggesting that keeping the maintenance therapy, in this particular case, it was thalidomide, is still of benefit also after allogeneic stem cell transplantation, because this was the first trial who investigate and maintenance therapy systematically in allogeneic or after allogeneic stem cell transplantation. So more recently, Costa and co-workers looked for a so-called long-term survival in all the studies, and they had individual patient data from 4 prospective studies. This was the original BMT CDN study, which included the most patients with more than 700, then the EBMT study with more than 350 patients, then the Italian study, but also the Spanish study. So they included more than 1,300 patients to compare the auto-auto to the auto-allo approach. Here you can see the major results. Here you can see the non-relapse mortality. You can see there was a significant benefit regarding lower non-relapse mortality in auto-auto to auto-allo. But you can see overall the mortality is not as high as described in the literature with 30 or 40%. It was less than 20%. However, the benefit for allogeneic was seen in the lower risk of relapse. Here you can see the relapse probability for auto-auto, and this is for auto-auto, and this was also significant in favor of auto-allo. Here you can see the long-term follow-up, 15 years follow-up. You can see the difference seems not to be so very high. However, it was significant in favor for auto-allo regarding progression-free survival. But on the right-hand side, you can see also there was a benefit regarding overall survival in favor for auto-allo transplantation. So for high-risk patients, here defined more as 414 or P53 mutations, you can see there was a significant benefit for the auto-allo. However, in the overall survival, even there seems to be a difference. This was not significant in this multi-center meta-analysis. So especially regarding high-risk features, so this is a study from the French study, retrospective studies, suggesting that high-risk features on non-high-risk patients did not result in a different progression-free and overall survival, and also similar risk of relapse. This is one of the German study, which has been published recently, also a prospective studies investigating auto-allo to auto-auto. And what they found in a rather small group of patients with P53 included here, you can see the P53 patients who are receiving allogeneic stem cell transplantation, this is the red curve, has a significant better survival than those who have P53 mutation and received only autologous stem cell transplantation. However, we have to consider the number of patients here with P53 positive are pretty low. More interesting, and this is, you know this already from the non-transplant and from autologous stem cell transplantation, seems to be the achievement of so-called minimal residual disease. And these are data looking for auto-allo approach and then achieving so-called stable molecular remission. That means in 2 or 3 consecutive samples in bone marrow, PCR negative MRD status. And then we have patients who have a so-called mixed status. They are MAD positive, but sometimes they are negative and positive. So it's not stable negative. And you can see this is the survival of the so-called mixed, while this is the survival curve for overall survival for MAD positive patients. But clearly suggesting here after auto-allo, the achievement of a stable minimal residual disease negative status seems to be associated with long-term survival, and probably this is a chance to be cured from the underlying disease, in this particular case, multiple myeloma. We look then in the database of EBMT, collecting more than nearly 5,000 patients and checked for the progression-free survival in multiple myeloma, depending on the status of the disease or status in the course of the disease in myeloma. And here you can see in the green curve, this is auto-allo, or in blue, you can see out-allo, single allo in upfront therapy. So you can see here you have you can achieve in about, after 10 years, about 40% progression-free survival. If you transplant patients later, so let's say after the first relapse after auto, this is here in red and in black, you can see you ended up in a progression-free survival about 20 to 25%. Results become a bit worse, or it becomes worse if you transplant patients in relapse beyond second or third line therapy. Then you ended up in only about 10% progression-free survival after 10 years. So how is the community in Europe doing allogeneic stem cell transplantation? Here you can see, at least from 1919 to 2012, you can see that in the beginning there was only myeloablative upfront allogeneic stem cell transplantation, which then decreased in 2002. And nowadays it's about 10 to 12% who received allogeneic stem cell transplantation as an upfront allogeneic single myeloablative conditioning. So in the early 2000s, the so-called auto-allo or tandem auto-allo approach becomes quite popular. You can see, but more recently this declines after all the studies, and it has not become a standard care of treatment. So nowadays about nearly 20% of the patients who received allogeneic stem cell transplantation received it upfront for auto-allo. The most patients, and this is increasing in the last years, received nowadays an allo approach if they have already received relapse to a first or second autograft. And these are more than 60%, so 64% of the patients received it in this. However, to be honest, the evidence for this, to doing this, is very low. And I show you some evidence, or at least some data, because so far no prospective study is investigating an allo approach in the first, second relapse after failure to an autograft. So this is a retrospective donor-donor, no comparison between several centers in Italy and Germany. And they showed there is, of course, a lower non-relapse mortality if there is a no donor, but the progression-free survival and overall survival here at 7 years are significant in favor for going for a donor. So this means for going for allogeneic stem cell transplantation. So currently, we in Germany started a study, a multi-center study, investigating again after in the first relapse after autologous stem cell transplantation in patients less than 65 years of age. So patients were registered and then they received the so-called triple therapy, which is approved mainly based on antibodies or carfilzomib, which is up to the patients and then to the centers, and then we do a donor search. And if there is still at least a stable disease after 3 cycles and there is an HLA identical or HLA compatible unrelated donors, then if the patient agrees, we do a 1-to-1 randomization to allogeneic stem cell transplantation, followed here by DLI maintenance therapy, or patient should continue with the salvage treatment he started with, or in patient who would like, this is also possible to receive the second autograft. So this will be the first prospective study investigating allogeneic stem cell transplantation after failure to an autograft. However, how can we improve the results for the time being? And these are our own data using allogeneic stem cell transplantation in first relapse after autograft. And you can see the achievement of a good remission. Here we have the so-called stringent CR, resulted in a significant better improved survival. Here you can see after 10 years, so still 65% of the patients are still event-free if they have achieved so-called stringent CR at day 100. So this is a landmark analysis by day 100. And more interestingly, if you achieve this MRD negative status, here either defined by Euroflow or a PCR technique, you can see the results becomes even more impressive. So it seems to be that the achievement of MRD negative status can be also a treatment goal or treatment aim of the procedure. So then we started to use prophylactic donor lymphocyte infusion in patients after allogeneic stem cell transplantation if they were off immunotherapy, so after 6 months usually. And then we started with some so-called escalating, starting with a very low dose DLI, so 10 to the 5th or 5/10 to the 5th, and then escalating up to 1/10 to the 7th if there was no response. So were all patients who were not in complete remission, or let's say not in molecular complete remission. And in this 61 patient, you can see in the majority, so there's a 77%, we achieved in these patients always what we called an upgrade of the remission. So from CR to molecular CR in 14% or 15%, from very good partial in molecular remission, 11%, and so on and so on. So the aim of this study was to upgrade the remission to achieve a molecular remission, and then to hopefully achieve the cure. So here are the data. So these are data patients who received this molecular remission. You can see if they received the molecular remission, you can see the progression-free survival. Here it's still pretty short, it's after 3 years, but it's very high in contrast to those who achieved only a CR, but not molecular CR. And these are the patients who did not receive the CR. So you can see here progression-free survival and overall survival, at least suggesting that targeting the molecular remission after allogeneic stem cell transplantation seems to be of importance if you want to achieve long-term remission, freedom in your patients. And then we extended our approach in those patients. So we tried to look for more in detail in a lower number of patients where we used these escalating donor lymphocyte infusions. And if they didn't respond to donor lymphocyte infusions, we added so-called post-transplant therapies. In this particular study, it was at this time thalidomide or bortezomib. Later on, we extended to lenalidomide. And you can see if we started first with DLI and one in thalidomide and bortezomib, you can see we upgraded the remission into molecular remission in 7 out of these 30 patients by FACS or molecular methods. But if they don't respond in a molecular remission, we added another proteasome inhibitor, or we changed to lenalidomide or thalidomide, and you can see we increased again the molecular remission, at least in 8 patients by specific primers, in 10 patients by FACS. So overall, what you can see in this study, we achieved in 50%, we could achieve a molecular remission if we try to upgrade the remission, not only by DLI, but the combination of DLI and novel agents. And here you can see the results. So those who achieved MRD negative, still is a minority of the patient, but they have a really good, here this is overall survival, but their progression-free survival is similar. Here after 10 years, excellent progression-free survival and overall survival. These are the patients who have this mixed response, and these are patients who remain positive. So just to conclude what we know from allogeneic stem cell transplantation in multiple myeloma, so it seems to be a potential curative treatment options. So the T-cell mediated graft versus myeloma effect exists, but T-cells need to be more specific to avoid graft versus host disease. So maybe selected myeloma patient, high risk benefit from an early autoallo tandem transplantation. Allograft as salvage treatment after relapse to an autograft needs to be in studies. And I showed you one of the recently started prospective studies. And more importantly, the achievement of a molecular remission can induce long-term freedom from disease and cure. Maintenance therapy, but should be included as well to achieve long-term freedom from disease. And just briefly to mention the member of the department, but also from EBMT, mainly here the Chronic Malignancy Working Party. So I thank you for your attention, and I'm open for questions.
Well, thank you very much, Dr. Kruger, for this elegant presentation and handling a very difficult topic. I don't see many questions here posted by the audience, but I really have lots of questions in my mind. Maybe we'll start by asking you. Now, most of these studies, as you know, have started quite some time ago, although updated recently. And probably there is, enthusiasm about really allo, is it really needed or not? I'd like to ask you, which patients of multiple myeloma would you really consider for allo transplant now?
Yeah, this is a very good question. So, you know, the myeloma field is rapidly expanding. So we have so many new agents, novel drugs, CAR T cells coming now into the field. All this data are, let's say, they have good remissions, but we don't have long-term survival data so far. This is lacking. And you know, if you want to see some benefit in myeloma, you have to wait now for 10 or even longer years. So we try to make some Sugarov marker like MRD positivity or complete remission. So I personally, so in daily clinical practice, so when we see myeloma patient, when I would offer allogeneic stem cell transplantation outside of a clinical study and how I would perform it. So two, one is young patients, let's say young is 60 and younger, who relapse early after autograft, yeah? So currently, every patient received a triple induction nowadays, and then received auto transplant and received also maintenance therapy with lenalidomide. And if this patient relapsed pretty early, so let's say after 18 months or even earlier, maybe with high-risk cytogenetic, and are young, then they are potential candidates for an allogeneic stem cell transplantation. And at least I would offer them, and I would recommend also to go then really for a curative approach. That means we will start with maintenance therapy. We would try to target minimal residuative negativity, you know, and we would change. So we would add also, if possible, and the insurance is agreed, also antibodies as maintenance therapy. So antibodies is very, very useful also as maintenance therapy. This I would do for this category. And the other category, which maybe allogeneic becomes more into the field, is the future. Because now, if you look now, even young patients, so they started with induction antibody, IMiDs, proteasome inhibitors, and then they have maintenance, auto, and then maintenance therapy. And if these patients are relapsing, yeah, even after 2 or 3 years, then they have received already maintenance, they have received antibodies, they have received proteasome inhibitors and IMiDs. So these are also maybe in the future becomes more interesting to use then in first relapse, as I mentioned in the study, allogeneic stem cell transplantation. But as mentioned, we need clinical studies, and it's difficult nowadays to convince patients because we have so many other options and so many exciting options. But we need also long-term follow-up. So we will hear about the CAR T cells. So there is no presentation of CAR T cells myeloma, but the effective is pretty high. But currently the relapse is also very high, and the remission is only short-lasting. This is in general the problem in myeloma we have.
All right. So if I can summarize, young patients with high-risk disease relapsing shortly after auto, you would consider for allotransplant. Would you use high-dose melphalan as conditioning, or would you use something else?
No, we usually have the melphalan already in the autograft, and in this high-risk patient we still use also double transplant. So they already have received a lot of melphalan, but we are focusing on, let's say, alkylating agents, which are the most effective drugs in myeloma. So what we are currently doing in this is we combined tiotaper, busulfan, and then we give PTCy as GVHD prophylaxis. So then we have 3 alkylating agents, and this is not so toxic, but we have let's say, anti-myeloma activity beside the graft versus myeloma effect by this alkylating agent. So this is our current protocol.
So busulfan thiotype, not TBF or thiotype, is it?
No, it's
TBF,
TBF. It's
busulfan
TBF. It's no fludarabine, because only if we go for haplo. If you don't go for haplo, the risk of graft failure is so low in myeloma because they are immunosuppressed by 2 prior autologous transplants. So we go only for TUT-PABU and then PT-Cy as GVHD prophylaxis. But if you have an haplo, then we would add fludarabine, of course. Then we go for TBF.
A more difficult question where we have 2 patients that we are considering is a second allo. I mean, we have 2 patients in their 30s that have relapsed post-allo transplant with a high-risk disease, 17p deletion. Would you consider these patients for a second allo?
Yeah, so the chance for a second allo to be cured then is very low. So we go for a second allo, but we use a different approach. If you look carefully to your patients with myeloma who relapse after allograft, they usually maintain complete donor cell chimerism. Yeah, so it's different from MDS and AML where you're losing chimerism. So these patients have usually a complete donor cell chimerism. It's only the plasma cells who are then coming from recipients. And this allows us actually to go for an, we call it pseudo-autologous. So we take the donor cells again, but we do a CD34 selection without any T cells because the patient still has donor cell chimerism. So it's like a boost. So we give then melphalan 200 or we give some, and we give CD34 selected. And then it's regarding the complication because you don't need any immunosuppression. You will not get GVH. So it's like an autograft. We add then a day 100, day 120, we give them some DLIs, which we keep from the waste, from the CD34 selecting. And then the toxicity is very low. So we haven't seen any non-relapse mortality. If you go for a transplant with different donor, with GVHD prophylaxis, then you should be aware then the mortality will be pretty high. However, it's not curative. You can save like an autograft again 2 or 3 years in remission.
All right, there are a few questions here that came up. How about, is there any data regarding haplo post-auto in multiple myeloma from Dr. Ahmed?
Yeah, they come up some data. So we have a study with using haplo PT-Cy, but EBMT recently published, I think it's just online. You can use it. The results looks like unrelated and looks like sibling. It does not look better, but it's more advanced disease. I think the advantage here is to have another alkylating agents. It works, but I wouldn't say it's better than the usual myeloablative sibling or unrelated transplant.
Another question from Dr. Majid. You have alluded to this, but his question is, don't you think that the advances in CAR T-cell in multiple myeloma provides a better and safer approach for these patients?
Oh, can you repeat the question there?
It's about, I mean, do you think that CAR T-cell is a better and safer approach, or is it not fair to really compare the effect of CAR T-cell to allo transplant?
I think it's too early to compare. The CAR T-cells are used in a very late stage of the disease. They induce high remission, but also in allo you have a high remission. The problem is the relapse here. And probably the CAR T-cell, the future of CAR T-cells, we will see if it becomes earlier in the course of the treatment, maybe after auto or as consolidation or early on, then we can see toxicity is of course less, is not zero, is less, but we need long-term follow-up. Probably in myeloma, this is my personal opinion, is not always to compare A to B and B to C. It's probably to include all the different options we have. And you can see this is now the way in doing induction, doing maintenance, doing consolidation, and to combine different agents because there are so different clones in myeloma. And if you really want to cure, you have used this, what Balogi told, total therapy.
There is a question that always comes in, and most of the time I don't see good answers. It's about extramedullary disease.
Mm-hmm.
I mean, do you think allotransplant is an effective modality in those patients, or graft versus tumor effect is not the best, and the escape mechanisms are more effective in those patients with extramedullary disease?
There are only very few data. We recently analyzed in EBMT the impact of auto-allo, and tandem auto in extramedullary disease. And there we could show that in patients with extramedullary disease, at least tandem is better than the single auto transplant. So I would at least recommend tandem transplantation in these patients. And we have also a couple, not a lot, auto-allo. The auto-allo results were similar like auto-auto, so, but it's a bit more toxic. So we would start with auto-auto in these patients. And whether it's working less than in non-extramedullary disease, at least for allo, there are no data confirming this. So we have to look carefully. But in general, in registry data, extramedullary disease resulted in worse outcomes. So, but I have no data whether this is also true for allogenic. Mm-hmm.
All right. I mean, there are too many questions, as I said, but unfortunately, we are limited with time. Thank you very much, Dr. Kruger.
Thank you
for the presentation and the discussion.
Thank you.
Muhammad, the mic is yours.
Okay, assalamu alaikum. Good evening, everybody. Thank you so much, Dr. Ayman. It gives me great pleasure to introduce the second speaker, Dr. Selim Karbojaklo. He is a professor and chair of the Department of the Hematology and Oncology at Stem Cell Transplant at the Children's Hospital in Regensburg, Germany. Professor Karbojaklo, he is focused on the curative option for the hemoglobinopathy and transplant-related systemic endothelial complications such as VOD, SOS, and BRIS. He is PI of the multi-center defibrotide prevention trial in children, and he is the PI for a prospective international trial to evaluate haploidentical stem cell transplant as a curative option for patients with sickle cell disease. He received the Van Beckom Award of the EBMT in 2010, and he is author of numerous peer-reviewed articles published in New England Journal of Medicine, Lancet, Blood, Leukemia, and Bone Marrow Transplantation. And he's currently the Scientific Council Chair and the Chair of Pediatric Disease Working Party of the EBMT. His title of his lecture today, he's going to talk about, do we have the challenge to our current donor hierarchy for patients with hemoglobinopathy? So Professor Salman, the floor is yours.
Thank you. I think I have to start my video, which I cannot do. Do we need my video?
Okay. Did you share it? You can open it in the desktop and share it.
Wait a second. I can open this and then I can share my screen. Hold on a second. Okay. Do you see my screen?
Yes, yes.
Okay,
right.
So again, thank you very much for the invitation. And I really love this meeting, more in person than by video, but let's take it as it is for now. I really would love to see you all again. So the question that we are posting here is a very provocative question concerning how to transplant our sickle cell patients and our hemoglobinopathy patients. And I think that slide here is redundant because we all know the problems with TDT and sickle cell disease with this huge prevalence, and the additional problem that this prevalence is predominantly in low and middle income countries where the treatment options, be it conventional or curative, are extremely limited. TDT and the sickle cell disease with regard to stem cell transplantation differ significantly. Also with regard to gene editing. I mean, for thalassemia, we have more than 300 mutations that cause severe transfusion-dependent thalassemia. And in sickle cell disease is a single point mutation. So the future approaches will be significantly different between both approaches. We can transplant them both, but gene editing approaches might stay on different paths for both diseases in the future. Well, one disease, TDT, is one that is afflicted by chronic iron overload and severe anemia, whereas the other is a disease that is less chronological, but rather risky, where patients out of the blue get strokes, other vascular crises, acute chest syndromes, starting early on in life. So the presentation of both diseases is different, and therefore also the indication for transplantation or any other cure might be challenging for both patient entities. This slide is very clear on the left-hand side. We know that even optimal care, conventional care, does not prevent these patients from a reduced life expectancy in Italy. And we know what is going on in low and very low income countries, that these patients succumb to their diseases very early on in life. On the right-hand side, we see here the classical Pesaro classification, which clearly states the earlier you transplant the patient with a matched sibling donor, the better is the outcome. Accordingly, the overall survival and the transplant-related mortality is increasing in adults. Alternative donor transplantation for thalassemia. Here's a publication by Lee et al. In Blood Advances. They looked at 1,110 patients from an international survey comparing matched-related, mismatched-related, matched-unrelated, and mismatched unrelated event-free survival and overall survival presented here. And I want to draw your attention to the matched sibling and matched unrelated donor transplantation, where both outcome parameters are basically overlapping. And that is, for most of us at this moment, not really surprising, because that's what we expect with leukemia, so that's true for thalassemia. We have to see that this might not be the case for sickle cell disease. When we look at the slide again, we see that there's a significantly worse outcome for mismatched related transplantations, event-free and overall survival. But when we take a closer look, it is exactly the same population that is over 16 years of age. So that patient that is basically left over because after years of watching and looking for a mud donor, didn't get any other chance to transplant than a experimental approach via haploidentical transplantation. And mostly these transplants are not done in prospective trials. And I will also show you what the difference is between patients transplanted in a prospective controlled approach versus as you like. Haploidentical transplantation for beta thalassemia. This is a nice presentation or publication by Hong Eng's group in Thailand. And I just yesterday was in a meeting with him and he updated these data. And they're very impressive. 83 transfusion-dependent patients with thalassemia, 3-year projected overall event-free survival over 96%, only 2 graft failures, and patients with extremely high titers of donor-specific antibodies, and 7% of the patients developed severe GVHD. So he has this treatment approach, post-transplant cyclophosphamide with a pre-treatment with fludarabine and dexamethasone in order to avoid rejection in these patients and also to calm down basically the hyperactive and hyperproliferative bone marrow. So a nice and cost-efficient approach for lower middle-income countries, but also probably for industrialized countries. And these are the numbers that any form of gene editing or gene therapy has to compete with. And this is something that we have to keep in mind, in particular with regard to socioeconomical effects of these treatment options and costs. So we can conclude matched sibling donor standard of care, considering aggressive downstaging of these patients prior to transplant, is a very important tool. So for 3 to 4 months, using a double chelation therapy with the desferal and the ferrociprone or any other combination of the existing drugs might be very useful with regard to secondary complications, early complications such as veno-occlusive disease, and they are really efficient, even only be done for a couple of months prior to transplant. MUD is equivalent to matched sibling donor. That's not new. Haploidentical transplantation is definitely a curative and comparably effective approach to matched sibling donor transplantation in this setting. And post-Cy is cost-efficient and affordable in low and middle-income countries. So this treatment option with a statistical ratio of 2.7 donors per patient is absolutely a chance for transplanting these patients in the majority of countries and centers that can do transplantation. So the classical donor hierarchy can be challenged here. Does not have to be challenged, but can be challenged. Why? Because a haploidentical transplantation using post-Cy is definitely cost efficient. It is quickly available and logistically much easier than having a mud donor from an international donor bank. Sickle cell disease, totally different story. We know again then even the best conventional care still does not prolong the life expectancy of patients with sickle cell disease, as Michael DeBoer nicely updated in Blood in 2019. So their life expectancy is still 20 years and more shorter compared to African Americans living in the United States. So again, a curative approach for the sickle cell patient is mandatory. And for sickle cell disease, it's interesting, it is really a disease more and more in the focus of even the media. And just yesterday, there was an article in the New York Times about sickle cell disease and the neglect of African Americans with regard to that disease compared to cystic fibrosis, a classical disease of the white man, where there are a plethora of drugs available and licensed for cystic fibrosis. Whereas for sickle cell disease, until very recently, there was just one drug, hydroxyurea. Now we have crizanlizumab, voxelotor, and enlerin, and some other drugs are coming up now for conventional care. But we still do not know if any of those drugs can prevent long-term chronic vasculopathy in sickle cell disease. Matched sibling donor, standard of care, no doubt about that. But mind you, look at age 15 and beyond. This excellent event-free and overall survival is declining in even a young adolescent to 88% with an incidence of chronic GVHD of 20%. On top of that, this is an unmet need because donor availability is below 20%. Mud donor transplantation, and now this is one of the major differences, data from Mary Epen's registry publication at Lancet Hematology 2019, comparing matched sibling with mud donor is significantly different. Event-free survival, 89 versus 69%. Overall survival, 96 versus 82%, and 3-year chronic GVHD, 19 versus 31%. And again, here, the cutoff age is 13 years. So a mud donor transplantation is not comparable to matched sibling donor transplantation, and the rate of chronic GVHD is rising exponentially when patients get older. Plus, again, donor availability is below 20%. So the sickle cell population is definitely a population in need for an alternative donor transplantation or even gene editing because of the lack of any form of classical hierarchical donor search and donor selection that we can apply here. Haploidentical transplantation has not been done for many, many years. And I would say the history of haploidentical stem cell transplantation for sickle cell disease is probably less than 10 years old. Post-transplant cyclophosphamide, this is basically the classical, most widely used haploidentical approach. Here in the Vanderbilt Consortium, a prospective approach combining the 3 centers in London, Imperial College led by José de la Fuente, Paris, and Vanderbilt, and these data were provided by Dr. de la Fuente. So the classical Bolanos-Mead approach that was published in 2012 with Flu/Cy, TBI, and ATG yielded a very high rejection rate in the sickle cell population. So this Vanderbilt consortium moved on and applied strategy 1B with thiatepa, and then added strategy 2 with hypertransfusion, hydroxyurea, and azathioprine pretreatment and preconditioning. These are the results in preconditioning and non-preconditioning, 23 and 10 patients, single center experience at the Imperial College, graft failure rates acceptable, acute GVHD grade 2 to 4, 13 and 50%, for my flavor, a little too high, chronic GVHD beyond day 100, 21 and 40%, definitely too high for this population. Mortality 20 and 10%, more or less acceptable. Still, it could be a little lower. Important is the incidence of macrophage activation syndrome, in particular in the patients that received the preconditioning. Mind you that the incidence of chronic GVHD beyond 18 months post-transplant was 0. Now, I did not show you the results of the haploidentical transplantation from Mary Epen's publication from the registry, because when you look at those data, the outcomes are so bad that you definitely should not do a post-site transplant, haploidentical transplant anymore. Graft failure rates, 38%, mortality, 36%. And the importance here is not to do post-transplant haploidentical transplants anymore. The important message here is you have to enroll these patients in controlled prospective trials. Otherwise, it is really not applicable in a patient with a non-obligatory elective transplant indication. So please be aware of that fact that enrolling these patients in any form of prospective, thoughtful approach is definitely for the benefit of these patients. We in Germany traditionally apply a different haploidentical approach. We started about 10 years ago out with a CD3, CD19 approach, then switched to T-cell receptor alpha beta and CD19 in vitro selection. And so far we transplanted 38 patients in a direct comparison at sibling donor versus haploidentical transplantation. Now with a longer follow-up, we included in this series 25 patients' median age was 14, and the substantial number of patients were really advanced stage sickle cell patients, as you see here. The key indicators are presented here. We have an overall survival of 88%, disease-free survival, again 88%, and the transplant-related mortality of 12%. There were 3 fatalities. One was a CMV pneumonitis because of a no-show of the patient for several weeks. One patient suffered from major ABO, or we selected a donor with a major ABO incompatibility, and he suffered from a late graft failure. So this is something that we are excluding after this patient that we have transplanted. And one patient is equivalent to the haploseries from De La Fuente with a diffuse alveolar hemorrhage and macrophage activation syndrome. All the remaining patients are off immunosuppression with 100% chimerism. There was no incidence of graft failure or graft rejection besides the one that I presented. Importantly, the incidence of acute and chronic GVHD basically negligible in this patient population. We had no grade 3-4 acute GVHD, and the chronic GVHD was present in 15 and 16% respectively, so comparable between matched sibling and haploidentical transplantation. And it was only mild and moderate, and by 18 months of age, 18 months of post-transplant follow-up, the patients were off GVHD and treatment. But again, here, as we know, the impact of age is significant in acute and chronic GVHD, independent of the transplant approach that we're using. So the message, again, as with thalassemia, you have to transplant these patients as early as possible, not too early, I'll get back to that, but do it before they reach the age of 18 years. The slide is not moving. Okay. So based on these results, we are now engaging in a phase 2 trial to assess haploidentical alpha beta T-cell depleted stem cell transplantation and sickle cell disease. It's a stratified prospective trial where we are comparing a matched sibling donor transplantation, very available, with a haploidentical transplantation. And we are intending to enroll 27 international centers in 12 countries, and maybe also 1 or 2 centers in Saudi Arabia. Now, next step, we're moving forward. I talked about stem cell transplantation. At the last EBMT meeting and at ASH, we presented the first data on gene editing concerning safety and efficacy with a CRISPR-Cas-based approach for thalassemia and sickle cell disease. Now, the background for the gene editing approach here is that elevated fetal hemoglobin is associated with decreased disease severity. I think you guys know this better than I do, with a combination of beta thal or sickle cell disease with hereditary persistence of fetal hemoglobin. So the higher the hemoglobin F level is, the less transfusion dependent are thalassemia patients, or sickle cell patients suffer from less vaso-occlusive or less severe vaso-occlusive crises. Now, BCL11A is one of the regulators of fetal hemoglobin expression. There are naturally occurring genetic polymorphisms of BCL11A that are associated with elevated fetal hemoglobin. It suppresses the expression of fetal hemoglobin postnatally, and editing of BCL11A results in reactivation of gamma globin expression and formation of hemoglobin F in mouse models. CTX001, the product that was applied in the trials that were presented, is produced using ex vivo editing of the erythroid enhancer region of BCL11A in CD34 positive hematopoietic stem cells and reduces erythroid-specific expression of BCL11A. An infusion of CTX001 leads to an increase of hemoglobin F. There are 2 ongoing trials, the THAL-111 and the SCD-121 trial. Both are phase 1 to international multicenter open label single arm trials enrolling 45 patients each. And These are the results presented here with a follow-up of over 3 months in the FAL population. There were 7 patients that were enrolled at that time point a couple of months back. 5 females, 2 males. Age at consent was 23 years. The treatment characteristics on the right-hand side, these patients received 11.6 times 10 to the 6 CD34 positive cells per kg. Neutrophil and platelet engraftment was on day 32 and 37 respectively, so slightly longer than you would expect with a regular autologous transplant. Importantly, there were no adverse events that were related to CTX-001, and the outcome is remarkable. Overall, there was a significant rise of hemoglobin from 10.1 to 14.1, and basically exclusively the hemoglobin variant that was present was hemoglobin F in these patients, with a follow-up, longest follow-up of approximately 18 months now in 1 patient. More important in the sickle population than the THAL population is the expression of hemoglobin F. And here in the THAL population, that is not surprising, we see a pancellular expression of hemoglobin F in basically all red cells, up to 100% in these patients. And almost immediately after engraftment, these patients all achieved transfusion independence. The sickle population, there were 3 patients with a minimum follow-up of 3 months, 2 females and 1 male. Treatment characteristics, a major difference here. The cell yield was only 3.8 times 10 to the 6 CD34 positive cells per kg. Neutrophil and platelet engraftment, again, slightly delayed with 22 and 30 days respectively. Again, here in this population, no adverse events that were related to CTX-001, and in both populations, all adverse events were associated with the classical autologous transplant, and in particular with the use of busulfan. Clinically, mean hemoglobin levels were achieved early and maintained in all 3 patients. So hemoglobin rose from 7.2 to 12.0, 6 to 11.5, and 9.2 to 13.2, respectively. But the difference here to the THAL population is that approximately half of the hemoglobin is hemoglobin F, and the other half is hemoglobin S, which is as you would expect it. And this peripheral distribution of both hemoglobin variants possibly reflects also the bone marrow expression or ratio of edited and non-edited cells. Now, a hemoglobin S level of 50% is significantly higher than that of a sickle trait. So these patients, at least theoretically, should suffer from sickle cell crises. But the far better indicator for clinically meaningful curative options is the expression of hemoglobin F and the percentage of F cells. And as you see here, the percentage of F cells is almost 100%. So what means F cells? F cells means that erythroid cells express at least a certain percentage of fetal hemoglobin. And it's a net mixture of fetal and hemoglobin S in this situation that protects these red cells from polymerization. And that is reflected in the clinical situation of these 3 patients. All 3 patients remained free of vaso-occlusive crises after CTX-001. So the red cells with this, or the F cells with this admixture of fetal hemoglobin, seem to do what we expect from them, and they do not sickle. BCL11 editing was observed in bone marrow CD34 positive cells after 6 and 12 months, and that was durable with 76.1 and 80.4% after 12 months, and it might be predictive of longevity and persistence of these edited cells in the bone marrow. But of course, we have to follow these patients for much longer. In conclusion, we can say that it worked, simply that the proof of concept was demonstrated for both diseases, and that both patient populations achieved meaningful hemoglobin F and total hemoglobin levels, and that they were free of vaso-occlusive crises and were transfusion independent with the follow-up of 4 and 21 months. Now, the question is gene editing, gene therapy the new standard of care? Well, I would not say that, because when we look at the little older trials that were run by Bluebird Bio that were stopped right now because they observed in approximately 8% of their edited or treated patients myelodysplastic syndromes and leukemia, that is something that, of course, can also occur with CRISPR-Cas editing. So we have to watch for these patients and then have to look out carefully for any clonality and any associated complications with either one of those treatment options. Unfortunately, I would say that the lentiviral approach is now becoming obsolete. Also, in particular, when you look at the presidential symposium of the EBMT presented data concerning gene therapy of cerebral adrenoleukodystrophy, a disease that really has no curative option. And that is different from thalassemia and sickle cell disease, where you, as you have seen, can do excellent stem cell transplantation with fantastic outcomes if you transplant these patients in experienced centers and most importantly, early on. Here, they transplanted or treated 42 patients, and out of those 42 patients, 2 patients presented with clonality, one with neutropenia and the other one with pancytopenia. So this is another hint that a lentiviral-based gene therapy approach has to be considered with a very careful eye. And I think it's a difference if you go for treatment of patients with no other treatment option versus patients where a stem cell transplantation might be really a valid option. And this is one of the things that we have to consider for all our patients. Just present them very transparently the risks and benefits of the different treatment modalities that we have at hand now. So conclusion, matched sibling donor is standard of care. When these patients get older, I would really consider a haploidentical transplantation. And sometimes maybe this sounds crazy, I would rather prefer a haplodonor versus a mud donor, definitely, probably also versus a matched sibling donor, where we have to keep in mind that a T-depleted transplant has the caveat of a significantly delayed immune reconstitution in sickle cell patients. And I think this is also due to the systemic vasculopathy that is affecting the thymus, but I'm not going to go into detail with that here. Haploidentical transplantation is curative for almost everybody. It is increasingly comparable to matched sibling donor transplantation. And again, here it is definitely cost efficient and affordable in low and middle income countries, also compared to the mud donor transplantation. And here, compared to thalassemia, I would definitely vote to challenge the classical donor hierarchy, matched sibling versus mud, or over haplo, and switch it to matched sibling and then go to haplo if even if a mud donor is available. Gene editing, gene therapy, we have no problems with GVHD, we have no donor problems, we have no issues with rejection and any other classical complications that are related to an allotransplant. But of course, it's still experimental. We don't know the off-targets effects in the long run. We don't know anything about gene silencing and insufficient expression over time. It is definitely a surrogate therapy. So 100% expression of hemoglobin F is a problem, in particular when we will be able...
We have only 1 minute.
Okay, Rob. Thank you. When we are able of doing a non-chemotherapy-based conditioning, so the loss of fertility is no issue anymore. So these patients will have problems during pregnancy. The future for sickle cell disease, I think, is definitely gene editing or gene correction with homologous recombination. Thank you very much.
Okay, thank you so much, Professor Karbojaglou, for this excellent overview of the hierarchy of the patient with hemoglobinopathy. Actually, I didn't see any questions, but it was being explained very well. But I have questions regarding the ethical part of for the transplant. If you have a child and he's 14 years and he's almost, to some extent, he's control of his pain and doesn't have any stroke, and he has just maybe 1 or 2 history of acute chest syndrome, and they ask for transplant, would you transplant him?
Yes. I would go for transplant. I mean, matched sibling donor transplantation, I think, is an absolute indication at any age beyond 3 years of age. I did not show the last slide because of time. I would stay away from the younger ones because of pharmacokinetic reasons, VOD, adenoviral infections that are not necessary to take that risk. But otherwise, I would go for transplant. If he has no matched sibling donor, I would go for a haplotransplant, because we know that in the long run, these patients will develop significant problems, nephropathies, heart failure and other issues. And transplanting them at young age is definitely at much lower risk than when they're older.
What about the infertility?
infertility is an issue, but when he's 14, he in particular as a male, he is at an age where fertility preservation might be easily and applicable and might be very successful. So it's not so much of an issue in that age, right? If they're younger, of course, and you have to go for more experimental approaches, but you can do that. Don't forget that, infertility is a natural complication of sickle cell disease anyway. So if you wait longer, this problem is going to rise anyway.
There's one question is coming. If I can get to the hemoglobin F over 35% with hydroxyurea, is there any role of the allotransplant?
Well, we have seen the data from the US where even optimal care still is associated with a reduced lifespan. So yes, it is a good option for the majority of patients, in particular if the hemoglobin F is high. But when they get older, compliance is an issue. When they get into pubertal and post-pubertal age, compliance is an issue. And I think still that a patient that is not chronically ill is a happier patient when he's safely transplanted. So I think I would not maintain that patient forever on hydroxyurea.
Okay, thank you so much. So we'll go to this the third speaker, and he's the last one in this second session. It's gives me great pleasure to introduce Dr. Samir Al-Amoudi. Dr. Samir Al-Amoudi, he's been a graduate from the King Abdulaziz University in Jeddah, and he has his clinical fellowship in the hematology from the Kingston General Hospital in Canada, and he has his fellowship in bone marrow transplantation at Prince Margaret Hospital in Toronto. Dr. Al-Amoudi, he is the program director of the adult and blood blood and marrow transplantation program, and he is also the director of the hematology and bone marrow division at Prince Noura Oncology Center in King Abdulaziz Medical City in Jeddah. Also, he is assistant professor in medicine and hematology at King Saud bin Abdulaziz University of Health Science College of Medicine, Jeddah. And Dr. Samir is going to talk about the life of the chronic lymphocytic leukemia. Dr. Samir, the floor is yours.
Thanks, Dr. Shahrani, for the introduction. Just I want to thank the SSBMT for arranging this meeting, and also thanks AbbVie for sponsoring this meeting and also sponsoring this satellite symposium. So can you see my slides?
No, not yet. Yes, it's coming, yes.
Oh, okay, so in the next 20 minutes, I'll talk about deep dive CLL today, which mainly I'll talk about relapse refractory CLL disease. So this is the disclaimer, and this is my disclosures. So the evolution of CLL treatment changed over time. So initially it was the only aim of treating CLL just palliative, just to alleviate the symptoms in early 90s. Then after that, with introduction of the chemotherapy, the outcome improved, which is leading to improving response rate and quality of the response. Then after that, after introduction of the novel agents, the outcome totally different. So we're talking now about progression-free survival. These novel agents include BCL2 inhibitors, BTK inhibitors, either the first generation or second generation, or BIK3 inhibitors. Now in this 2020 also, we're talking now about improving outcome, and we're talking about improving overall survival. So the question that usually comes in any case, relapse or refractory CLL, what's the best treatment for that patient? Is it chemotherapy, non-chemotherapy regimen, continuous therapy, or fixed duration? So I'll try to answer these questions during my presentation. So here, regarding the first question about the chemotherapy or non-chemotherapy regimen, as you can see here in NCC guidelines on this year, regardless if in case of relapse or refractory without deletion 17p TP53 mutation, regardless the patient fit or not fit, you can see here actually the preferred regimen is non-chemo protocol. In both regions, they both, like in case of fit patient, they can, one of the options using chemotherapy in case of the fit patient or frail patient as a second options, but it's not the preferred regimen. This is in case of without deletion 17B or TP53 mutation. So what about if there is presence of deletion 17p or TP53 mutation, you can see here is there is no chemotherapy as preferred regimen. So in NCC guidelines, the novel agents in case of relapse is the preferred regimen. What about other guidelines like ISMO guidelines? So this is ISMO guidelines 2020. You can see here, if the patient had TP53 mutation or deletion 17p, or the patient had like short remission duration, which is less than 3 years, the preferred regimen are the novel agents. In case of late relapse and absence of the high-risk mutation, they put one of the options is that consider chemotherapy, but still novel agents is the best options. So this is regarding the first question. So which regimen it use, chemo or non-chemo regimen? So it seems from the guidelines, the novel agents is are the winner. So let's talk about 3 novel agents. Mainly I'll talk about ibrutinib, acalabrutinib, and venetoclax. So ibrutinib, as you know, it's first generation BTK inhibitors. In this trial, resonate trial, so they compare the relapse refractory CLL patients that include deletion 17p and TP53 mutation to receive either ibrutinib as a continuous therapy or ofatumumab, which is one monoclonal antibody. So a total 391 patients with the progression, with the median follow-up around 65 months. The progression-free survival, as you see that with the ibrutinib, is around 44 months compared to 8 months to the ofatumumab group. And when you look at the subgroup analysis, you can see that patient without high-risk feature, like deletion 15p or TP53 mutation, they do better compare in the presence of high-risk feature, which is expected. So now that was the response. So what about the safety profile? As you can see here, that this is the 5 years follow-up. So the safety profile, so the ibrutinib can cause grade 3 or more adverse effect in form hematological toxicity like neutropenia, also anemia and thrombocytopenia. In case of non-hematologic toxicity like hypertension, atrial fibrillation, and also infection. So one thing that just to observe in this slides, that the degree of toxicity differ from which year. So some toxicity, the toxicity will persist while the patient is on therapy. Like you can see here, the neutropenia. So you can see in the first 2-3 years, still the patient at risk of developing neutropenia. But some toxicity, they are more in the first 2 years, like atrial fibrillation. But you can see like hypertension is persist. So even the patient after 2 years on ibrutinib has risk to have hypertension. Also, infection is one of the complications. You can see it persists even while the patient on the therapy. One of the complications also it's common with the ibrutinib is the hemorrhage, which you can see here around like, can happen around the first 2 years around 10%. And regarding the atrial fibrillation, it happen also around 10%. So here is, so ibrutinib, it's continuous therapy, effective in case of relapse refractory CLL, but it has an issue with some toxicity. So what about the other agent, which is acalabrutinib, which is a second, more selective BTK inhibitors. So in this, they compare the patient relapse refractory CLL to either receive acalabrutinib as a continuous therapy or fixed, or to other group, which is bendamustine rituximab or idelalisib rituximab. So you can see here in the median follow-up around 22 months, there's the progression-free survival not reached in the acala group, while it's around 18 months in the bendamustine group compared to 16 months in the idelalisib group. So progression-free survival is better in the acalabrutinib group compared to other group. So when you look at the subgroup analysis, you can see here regarding the mutation status, as you can see, presence of the high-risk feature like 17p deletions, TP53 mutation, unmutated IGHV, and complex karyotype all favor the acala group, favor the acala therapy. But one thing you can see here, the patient had 4 or more lines of therapy. This like this is this group crossed the line, so there is no difference between the two groups. So acala is effective. What about the safety profile? So you can see here acala can cause neutropenia, but this is less compared to the chemotherapy group. Other toxicity, like it can cause diarrhea, thrombocytopenia, pneumonia, TLS, but you can see it's very low, the percentage. And we look at grade 3 adverse effects, and we compare it because this is, as I mentioned, selective BTK inhibitor. You can see the risk of atrial fibrillation around 1%, hypertension 3%, and even major hemorrhage around like 3%, which is less compared to the ibrutinib. So here, acalabrutinib can give showed the significant progression-free survival in case of relapsed refractory CLN with different subgroup and even if the high-risk group, and it has like good safety profile compared to the ibrutinib. So now I talked about like the continuous therapy. So what about the idea of giving fixed duration therapy? So in this, so we came like the Murano trial, which is compare relapsed refractory CLL patients to receive either bendamustine rituximab for 6 cycles or to receive venetoclax rituximab. So venetoclax in the first week, first 5 weeks, the ramp up of the doses, which is 20, 50, 100, 200, then 400, then 6 cycle rituximab, then the patient will continue on venetoclax 400 for 2 years. They include in this study any patient with previous line of therapy, even if he received chemotherapy, but one condition that this patient should, if he had bendamustine rituximab before, at least should be more than 2 years before the progression of the disease. The primary endpoint was progression-free survival, and the secondary endpoint was like progression-free survival and high-risk feature group like deletion 17B, overall response rate, overall survival, and MRD, minimal residual disease clearance. So this is the feature of this type of patient, this study. So you can see more of them are male around 70%, median age around 65, with the ECOG around 0 to 1. Around 53% of the patients that have high risk, medium risk to TLS. So they divided the risk of TLS either high, medium, or low. So the low does mean if the lymphocyte count less than 25 and the lymph node less than 5 centimeter. High risk for TLS if the patient has lymphocyte more than 25 or has like more than extranodal site or bulky disease like more than 10 centimeter size of lymph node. You can see in this study around 27% of the patient had deletion 17B. And regarding medium, the previous therapies, as you can see, median number of prior therapies, 1, most of them are chemotherapy. So what is the result of this study? So you can see here the progression-free survival. There is significant progression-free survival benefit in VEEN group compared to the bendamustine rituximab. As you can see, around 53 months compared to the 17 months. So just to remind you, this is like this trial is a fixed duration. So that means the patient after 2 years he's off therapy. So all these years are like the patient he's off therapy, he's not in therapy. And you can see here, as I mentioned, so at the 2 years the patient is off therapy. And while he's off therapy, he continued to have better progression or stable, sustained progression-free survival compared in the venetoclax group compared to the bendamustine rituximab group. When you look at the subgroup analysis, you can see here the venetoclax group, the subgroup analysis is, you can see, so you can see that regardless of which type of high-risk mutation like deletion 17B, living Q, or unmutated IGHV, or TP53 mutation, or favor the VEEN group or VEEN arm. So if you look deep here, so you can see here, so this is the progression-free survival in case of deletion 17B. So as I mentioned, VEEN group, they do better in case of the presence of deletion compared to the chemo group. But let's say what if the patient will do subgroup analysis. So those with normal normal 17, there is no evidence of 17B deletion. They do better in progression-free survival compare in the those who had 17B deletion, but around 7 months. So the progression-free survival around 55 months in the non-17B deletion, compare 47 months or 48 months in the 17B deletion group. And this is also you can see the same in the form of TP53 mutation. So in both vein group, either having, if they don't have the mutation, the progression-free survival around 56 months, which is much better, around 10 to 11 months compared to the patients who had the TP53 mutation. So when you look about the progression-free survival in the IHV mutation, as you can see here, the progression-free survival benefit with venetoclax group is better and maintain 5-year analysis independent on IHV mutation. So you can see here that the progression-free survival around 52 months compared not reaching case of the mutated IGV mutation. So what about overall survival? You can see here there are the venetoclax group. They overall survival is better compared to the bendamustine rituximab, as you can see his graph. So what and this overall survival is sustained even after stopping the therapy, as you can see here. At the 2 years, which is the time of stopping the therapy, then after 3 years, you can see persistent and sustained the overall survival in vein group compared to the other group. So what about the overall survival subgroup analysis? You can see here actually in presence of high-risk feature like TP53 mutation, deletion 17B, still it's crossed the line. So still the overall survival is questioned on these types of patients. But as I mentioned, overall, they do better. So what about, so in Murano trial, which is one of the secondary outcome I mentioned, which is the minimal residual disease. So the idea of minimal residual disease is just to know who had the negative MRD, which is defined the blast cells or abnormal cells should be less than 10 to the power minus 4. Because the theory, if you have still persistent MRD, you're at risk of progression. So you can see here at the end of therapy, around 62% of the patients achieve MRD negative in vein group, compare around 13% of the chemo group. Not only that, those patients who had the MRD positive around in the vein group, around 19%, they have low MRD detectable level compared to the chemo group. And you can see here the progression for free survival. It's based on the MRD status at the end of therapy. So you can see the patient with the vein group, they do better in form of the reaching MRD negativity compared to the chemo group. And in the presence also, the patient who had MRD positive in the vein group, they do better compared to the MRD negative in the chemo group. But you can see here the MRD positive patient in the same group in vein, they do worse compared to MRD negative. Here we're looking also the progression-free survival, as I mentioned. So if the patient achieves end of therapy MRD negative, the progression-free survival 2 years around 85% compared to the group which didn't achieve the MRD negativity, the progression-free survival 37 months. And this also was translated to the overall survival. Negative MRD in vein group, they reached overall survival around 99% compared to the MRD positive around 88.6%. So what about the safety profile? As you can see here that the grade 3 toxicity or adverse effects around in the neutropenia around 57% in the vein group, which is more compared to the chemo group. But this wasn't translated into a clinical significant febrile neutropenia, which is, I think this is an important observation. And the other toxicity like TLS with the measures that applied or the protocol in case of high risk for TLS and low risk of TLS, you can see here there is no significant TLS. This is, as I mentioned, so it's this is the grade 2 or the adverse effect. So it's almost comparable in both groups. There is no major safety concern. And as I mentioned, this is update of 5 years analysis. So no new safety signals identified, excluding non-melanoma skin cancer, with 2 new secondary malignancy have been reported. There were no new reported events of Richter transformation and no new safety signals.
Dr. Samir, we have only 1 minute.
Okay, so yeah, this is the last slide. So as summary, so the Murano study 5-year overall, 5-year follow-up showed progression-free survival is better in the vein group compared to the chemo group, and also this was seen in the overall survival. MRD negativity at the end of therapy was associated with longer progression-free survival and overall survival. Clinical response, so the patient who received previous BTK or venetoclax respond well also to the fixed duration regimen. And the safety profile, as I mentioned earlier, there is no reporting of new issues or concern after 5 years follow up. So just last comment. So the question, which therapy to use? I think there are several factors depend. So one of them is the comorbidity of the patient, the preference of the patient, does he wants him to be on continuous therapy or just fixed duration therapy, and the character of the disease, presence of high risk feature will make the physician more comfortable to be on the continuous therapy rather than fixed duration therapy. And thank you.
Thank you so much, Dr. Samir, for this beautiful journey in the deep dive of chronic lymphocytic leukemia. I'm in pediatric hematology oncology, but I don't have any much clue about the chronic lymphocytic leukemia. But very interesting, you have the minimal residual disease on the CLL. So it is the same like the acute lymphocytic leukemia, like the other leukemia, the acute leukemia.
So still, so the MRD still in the usual, the MRD based all the guidelines only on the clinical trial. Still, it's not like a routine practice in the real life. So until now, it's only just in the clinical trial. It's not recommended to do MRD negativity in the clinical practice outside the clinical trial.
So it's not a standard.
Yeah, not yet.
Not standard. Okay. Actually, I don't see any much question here, but because the time, I think we're going to conclude our second session. Thank you so much in behalf of the audience. I would like to thank our eminent speaker for the excellent talk, and also we'd like to congratulations to the winner for the research award. So we will have now just 5 minutes break, and then we'll come back for the third session. The third session will be about the acute leukemia. It will be presented by Dr. Ahmed Barifa and Dr. Muna Al-Asiri. Astaudakum Allah. Bye bye.
Hello,
Yes.
I'm Giovanni Martinelli.
Yes, Dr. Giovanni. We'll start this third session now. So on behalf of SSBMT, I would like to welcome all to the third session of this conference. And I would like to welcome my co-chair, Dr. Ahmed Ba'arfa. He's a consultant adult hematologist at King Abdulaziz University. Our first lecture will be by Professor Giovanni Martinelli. He is a General Director and Scientific Director of Romagna Scientific Institution for Study and Treatment of Cancer, Scientific Hospitalization and Care Institution in Italy. He's the Editor-in-Chief of Journal of Hematology Reports, and he's a member of 10 different associations like European Leukemia Net, International Association for Comprehensive Research on Leukemia and Related Disease World Committee, European Hematology Association, American Society of Hematology, and American Society of Clinical Oncology, and European Association for Cancer Research. He has a research and clinical activity interested in CML, AML, ALL, and MDS. He has more than 260 published reports in AML, ALL, MDS, and CML. Professor Martinelli will talk about AML disease burden and clonal evolution, especially FLT3 mutation. Dr. Martinelli, the floor is for you. You can start.
Dear Mona Al-Aziri and dear colleague, it's a great pleasure for me to be invited at this very important meeting. And it is an honor for me to be part of this important meeting. My talk will be related to the use of molecular profiling in acute molecular leukemia, particularly in relapsed refractory acute myeloid leukemia patients. This is my disclosure. I'm consulting relationship with several pharmaceutical companies, including Astellas, Celgene, Jets, Janssen, Pfizer, Amgen, AbbVie, Roche, Incyte, and others. And my talk will be focused on acute myeloid leukemia disease burden and clonal evolution, particularly with attention with the FLT3 mutation. And this is still my disclaimer. My presentation overview will be related to the unmet need of patients with FLT3 and mutated acute myeloid leukemia. I will talk about also prognostic value of FLT3 mutation. I will talk about MRD-based definition of CR, and finally, clonal evolution of acute myeloid leukemia. I would like to focus the attention at the annual conference of SSBMT, a Saudi Society of Blood and Marrow Transplantation, 8th annual Saudi Onco Nurses Conference, EBMT related highlights that acute myeloid leukemia is a heterogeneous hematological malignancies which associated with several gene mutations. Is not easier to define an acute myeloid leukemia, very heterogeneous disease with just one genetic lesion. However, there are overall a different frequency of selected genetic mutation in acute myeloid leukemia. The more important one is related to the mutation internal tandem duplication or tyrosine kinase domain mutation, which are frequently related to 37% of the acute myeloid leukemia patients at the diagnosis, but it could became more important at the relapse and refractory time of leukemia. There are several factors associated with a negative impact of prognosis in acute myeloid leukemia. The first is related to disease status, which is related to refractory and early relapse between 6 and 12 months. Another negative factor is the presence of the only one mutation, which is FLT3 internal tandem duplication. Or another important negative impact on prognosis is high-risk cytogenetic. So the FLT3 internal tandem duplication is alone a very bad negative impact on prognosis. There are multiple mutation or non-mutational factors that impact responsiveness to acute myeloid leukemia. In retrospective multivariate analysis of 138 refractory acute myeloid leukemia, we were able to demonstrate that several factors are relevant, including molecular parameters. I just would like to focus your attention on FLT3 receptor tyrosine kinase. FLT3 receptor is an immunoglobulin like loops with a transmembrane domain, an extramedullary, an extracellular domain, an internal cell membrane domain, which is frequently internal tandem duplicated, which means that is prolonged in the receptor, getting a possibility that this prolonged will activate, self-activate without any binding of the receptor outside the signaling on FLT3 receptor. And FLT3 TDK mutation, which is more rare than this internal tandem duplication, but do the same things, activate the receptor, even in absent of the binding domain ligand. So FLT3, the FEMS-like tyrosine kinase 3, is a transmembrane receptor kinase that promotes proliferation and blocks differentiation. The two main aspects of an acute myeloid leukemia: promote proliferation and block differentiation. There are 30% of acute myeloid leukemia harboring the FLT3 internal tandem duplication, 7% of acute myeloid leukemia harboring a tyrosine kinase domain mutation. Consider every time you get a patient at relapse to test again, and not only a diagnosis, which is the mandatory, but also the relapse, the status of an acute myeloid leukemia, since this mutation grow up during the course of the leukemia. In acute myeloid leukemia, mutation status could be possible that might change. In a retrospective analysis of patients with FLT3 internal tandem duplication negative acute myeloid leukemia, 268 patients, about 10% of the 77 relapsed patients acquire a new FLT3 internal tandem duplication. And so an analysis of 60 patients with FLT3 internal tandem duplication alone prior to therapy showed that other FLT3 mutation might emerge during treatment. So there is a sort of dynamic in acute myeloid leukemia outcome of the patient. This is related to the presence that mutation in FLT3 can be acquired and can be associated with negative prognosis, including high risk of relapse. So please consider testing acute myeloid leukemia to confirm status of relapse. I just would like to remember that if you get patient with a no FLT3 mutation, you get a better overall survival. But if you get FLT3 mutation, or more importantly, internal tandem duplication, you get a worsening prognosis in acute myeloid leukemia. Another point that I would like to move on is that the FLT3 internal tandem mutation is an independent factor, and that has a highly negative impact in prognosis in acute myeloid leukemia. The prognosis significant FLT3 mutation is associated with this cartoon. Internal tandem duplication mutation has a negative impact in long-term outcome. You can see here about the possibility to get a relapse, grow up, relapsing increase of about 20% if there is FLT3 internal tandem duplication. The prognostic role of FLT3 TDK is still under debate, but however, there is a great opportunity that there is a 16% worsening disease-free survival if you get FLT3 internal tandem duplication or mutation. And finally, the patients that are still alive with a percentage of internal tandem duplication negativity is roughly 44% in 5 years, 4 years follow-up, versus only 32% who harbor the mutation. So every time you get FLT3, you get a worsening prognosis, more relapse, less disease-free survival, less overall survival, and probability to still be alive in a long-lasting outcome. In a European Leukemia Net 2017 recommendation from an international expert panel, it has been highlighted the importance of the mutation of NPM1 together with 1821 inverse 16 translocation, RANX or core binding factor mutation, biallelic CBP alpha, but more importantly, if you get mutated NPM1 without this FLT3 internatand, you get a favorable outcome. If you get wild type and NPM or mutated NPM with FLT3 internatand duplication highly expressed or low expressed but without an adverse risk of cytogenetic, you can get an intermediate risk in acute myeloid leukemia. But finally, associated with other diseases such like translocation pH positive, 619, AV1, and inversion chromosome 3. If you get wild type NPM, but you get high expression, allele expression of FLT3 internatand duplication, or mutated P53, RANX, AXXL1, you get a worsening adverse events. This is related to the therapy, of course. So we have to understand that there is a sort of clonal evolution in acute myeloid leukemia, particularly in NPM1 mutated acute myeloid leukemia. In hematopoietic hierarchical hematopoietic stem cell, we get an early events, which is mostly of the case is associated with the DNA methyltransferase 3A, NPM1 or EDH2 isocitrated dehydrogenase 2, which make an initial transformation of leukemia. Then we get a late events, mostly related to NRAS, uniparental disomy of chromosome 13, deletion of chromosome 9, but more important, acquiring FLT3 internatand duplication of TKI, getting a total completely transformation from a myelodysplasia or chronic myeloid leukemia status to a plenty acute myeloid leukemia. And then we apply a therapy, which is a sort of Darwinian selection. And this Darwinian selection could be able to, given the same type of leukemia with the identical clone, with evolution in 30% of the cases, but more irrelevant to acquiring new mutation in the majority of the cases with an additional 19 patient identical clone, but 30%, roughly 49% getting an evolution from the same clone. But this, at the relapse time, we get also some ancestral clone like this, ancestral clone with evolution like this, but acquiring a new mutation, or an unrelated clone like this, which is a very rare event. So 49% has the identical clone with the FLT3 internatand duplication, which is a lot. And we can use this marker to target a new therapy, particularly now that we have a very efficiently FLT3 inhibitors, such like gilteritinib, which is approved in the United States, in Japan, in the majority of the country in Europe, and very, very soon probably also in Saudi and Arabia countries. I would like to remember that the NPM mutation is a quite stable mutation. DNA methyltransferase 3A mutation is quite stable. FLT3 is probably one that you can lose in 25% from diagnosis to relapse. There are some cases that are positive at diagnosis and they lose a relapse, but in the majority of the cases, there are cases that were negative at diagnosis and became positive at relapse. About 41% of the entire population acquire a relapse FLT3 internatand duplication. So I strongly suggest to my friends and colleagues in Arabia that they have to check every time you get a mutation the presence of this kind of mutation. How we can do this, the test of this mutation? Can be done by cytogenetic, but it's difficult to find out. By FISH, also this is not really applicable, but by conventional PCR, more than next generation sequencing. I'm in favor of next generation sequencing, but this is usually a little time consuming and expensive. So it takes roughly 2 weeks to get the answer if a relapsed refractory acute myeloid leukemia has or has not the FLT3 internal tandem duplication. Please provide for this alteration a conventional PCR, which looks for a hotspot mutation DNA, particularly for FLT3. You can get the results in a very short time, 24, 48 hours, and you can use blood and bone marrow. If you get a FLT3 acute myeloid leukemia, please go quickly to the treatment of this patient. Since the FLT3 relapse refractory with the FLT3 is very rapid in an outcome and ongoing the clinical of leukemia. And then extensively use next generation sequencing, which typically explore 500 genes by amplification and by informatic focus on AML genes of interest with a turnaround of 2 weeks that can complement the very quick analysis of FLT3. So please do mutation analysis with the conventional PCR for FLT3, then next generation sequencing for better understood which kind of relapse refractory AML you get. European leukemia recommendation advocate prompt testing for FLT3. They support the idea that you can have this FLT3 testing in a very short time, 48, 42, 72 hours. It can be by PCR, including also getting the allelic ratio in this population. And this has not only a prognostic importance, but more important to start immediately tyrosine kinase inhibition, particularly with gilteritinib, a very strong and active FLT3 inhibitor. This prognosis scoring can be applied in the majority of the patients, and there are 3 of these that are frequently used: in the GOLAS score, the European Prognostic Index score, and the SALFLAG score. But let me focus your attention that 2 of these this very important one, particularly these, the GOLAMS and the SALFLAG score, as in their score, not only the CR duration, CR1 duration, which is of course important, but more important the FLT3 internal tandem duplication status. If it is positive, you get an additional point of negativity. And if you get the FLT3 positive, you get an additional point of negativity. So the more important prognosis scoring system in Europe and in the world introduce FLT3 positivity as the one of the worsening aspect in acute myeloid leukemia. And this is associated to an overall surviving, according to the prognosis group, that makes poor the outcome of the patient with the FLT3, whatever is the treatment, including also the fludarabine-based regimen or the fludarabine and idarubicin, including regimen. So remember that the FLT3 status is very important to be analyzed, and not only the presence of FLT3, but more important, the allelic ratio, which is if it is over 0.51, get a better prognosis, but if it is more than 0.551, makes a very difficult to be cured acute myeloid leukemia with this. So it's time to move probably to a better definition of MRD based on CR in transplant eligible patients, similar survival in CR. MRD versus no MRD will be very important. In my personal opinion and experience, I try every time I get a patient with relapsed refractory acute myeloid leukemia with a FLT3 to do target therapy before moving the patient to transplantation. it makes not sense, in my opinion, to transplant a patient in a fully blastic situation. And with the gilteritinib experience, we get a lot of patients be able to obtain a fully plenty MRD negative CR, second CR, to move this patient to the transplantation with a better survival advantage, like you can see here. And let me say also to introduce the FLT3 inhibition 3 months after the first transplantation to be promote a prolonged survival of the patient and prolonged CR of this patient, because I would like to remember that some of the best FLT3 inhibitor can be resumed after the transplantation and getting great advantage of our patient. I would like to thank all my clinical acute leukemia teams, my molecular biology lab, my data manager and project manager, my cytogenetic and molecular diagnostic, the GMEMA data center, and all the researchers of the protocol 181Y and Seragnoli Institute in my university, which particularly my colleague Carolina Terragna, Valentina Robustelli, Simona Soverini, and Cristina Papadenise. Here is my contact for any question, and eventually if you would like to send me an email for my presentation, I would like to thank you for the kind invitation, and I'm opening and waiting for your question. Thanks a lot.
Thank you so much, Professor Martinelli. That was excellent and very informative. I will start with one question and wait for the audience question as well. The use of now selective FLT3 inhibitors with the patients with AML versus use of older non-selective FLT3 inhibitors that can also inhibit other tyrosine kinases. What's your opinion regarding now the shift from non-selective FLT3 inhibitor to selective ones? Are we losing any responses with that?
Thanks for this very important question. I'm not able to start my video. Mona Hal Aziri, probably you have to open in my video connection. However, I will answer immediately. I totally will be thanks, Mona. I totally thanks in favor of a selective FLT3 inhibitor, because if you use a selective FLT3 inhibitor, you get a prolonged inhibition of phosphorylation of the receptor and a prolonged advantage on the switch off the signaling. And personally, there are some of these, I know that they are not yet registered, they are coming to be registered in Saudi, but this type of inhibitor like gilteritinib, for instance, are able to prolong the inhibition for more than 24 hours, which means you get a switch off the receptor for more than 24 hours. You get a bit also inhibition in the hour below. So you can get 36, 38 hours of total inhibition, which is just one pills treatment and one single treatment. They are very well tolerated, no cross reaction, no side effect, very, very well tolerated for a prolonged exposure. It can be accumulated during a week and then accumulated eventually during 2 weeks without any side effect. And this is very successful in the majority. A lot of people would like to use this FLT3 inhibitor like a conventional chemotherapy. It's not the case. You have to be patient. There are some AML patients that takes time to be cured, months of exposure. But I suggest to my colleague in Saudi to be patient and to expose the patient for a prolonged time, because the successful arrive every time if you are able to take the patient under the pressure of FLT3 inhibitor.
Excellent.
So my personal opinion is to be patient. If you get the marvelous results immediately, it's better, of course. But if you don't be afraid. Stay on treatment, please.
Excellent. Another question is regarding the slide that you mentioned in your presentation, the allelic ratio and the allelic burden and the impact of that on decision regarding transplantation, maintenance, treatment. Can you expand on that more, please?
Yeah, this is an important issue. Allelic ratio means that you get a lot of expression of the receptor, so you get a self-activation, a strong self-activation. However, in my personal opinion, if you get a good inhibitors, very well tolerated, you can overcome the double effect of the allelic ratio. And personally, it's something that is more related to a C220 or other sorafenib or other a bit less effective inhibitors. If you move to the new one, more selective, more precise, and more tolerated, you can overcome the worsening effect of the double allelic mutation, the highly allelic high burden.
Excellent, thank you. So two questions. One is how long you use FLT3 inhibitors post-transplantation, and the other one is in patients who are not eligible for transplant, who have AML with FLT3 mutation. How long give them the...
I start from the first question. They are very clever and important. Thanks for this question. The first is how long it takes a patient in treatment. I start as soon as possible because FLT3 is very damaging. I take the patient at least for 2 years, eventually reducing a bit the dosage. If I use gilteritinib, I'm using gilteritinib. I reduce the amounts. The dosage is 120. It can be increased to 200 milligrams, but I use 80 milligrams, a bit less. So 2 pills, not 3 pills a day. And this can be used for a prolonged time, for 2 years. After 2 years, if you are completely molecular negative for a prolonged time, you probably can stop. But a lot of people, patients say, no, I would like to continue to take my pills because I will tolerate. The other question is related to what I can do if I cannot transplant a patient. I take the patients in the continuously treatment. Sometimes I have some breakpoints if they go down in platelets and in hemoglobin, but in majority of the cases, I will be able to take the patient to 40 or to 80 milligrams for a very prolonged time without any side effect. So if you get an elderly with a FLT3, use the drugs and you don't have a transplantation, use this drug as long as possible, as much as possible.
Excellent. So thank you so much, Professor Martinelli. That was very excellent. And we'll move now to the second talk of the session.
Thanks a lot for your invitation. I really appreciate it. Bye-bye.
Thank you. Bye-bye. So my pleasure now to introduce the second speaker, Dr. Iola Pressot. Dr. Iola Pressot graduated in medicine from University of Rennes, France. She obtained master's degree in biology, biotechnology, research therapy from University of Nantes in France. Then carried to complete her hematology fellowship from the University Hospital of Nantes and from the University Hospital of Saint-Antoine in France. Currently, she is working as Associate Professor, Clinical Hematology and Cellular Therapy Department in Hospital of Saint-Antoine in Paris, and has been an active in various research and peer review journal. So Dr. Iola Pressot, the floor is yours.
Okay, thank you very much for your kind presentation. I just up. Okay. So, thank you very much for also asking me to talk about a very interesting topic, according to me, incorporation of novel therapy in the treatment of ALL. So these are my disclosures. And we know that the past decade had witnessed tremendous progress in the treatment of ALL, primarily due to the development of targeted therapies, including monoclonal antibodies, targeting cell surface antigen, bispecific antibodies, and of course, CAR T-cell therapy. In the past 7 years, blinatumomab, a bispecific antibody that target both CD3 and CD19, and inotuzumab ozogamicin, a conjugated antibody that targets CD22, have been approved by different medical agencies, especially for relapse and refractory B-ALL. And these agents have been approved for use as monotherapy. However, more recently, they have been incorporated in combination or sequentially with cytotoxic chemotherapy. So I will talk about blinatumomab and inotuzumab ozogamicin. I won't focus my talk on CAR T-cell because we had already excellent talk on this topic at the beginning of the Congress. What about blinatumomab? This is a bispecific antibody that can redirect T cells to tumor cells and active T cells. After activated T cells release perforin and granzyme through the immunological synapses, and these cytolytic proteins can form endosomes in tumor cells and lyse the tumor cells ultimately. So you're aware of this TOWER study, that is a main study for blinatumomab. It was a phase 3 randomized study that compared blinatumomab versus standard of care in patients with relapse and refractory Phe-negative ALL. At the end, overall response was 45% in the blinatumomab group versus 30% in the standard of care group, and it was statistically significant. At 12 weeks, molecular remission rates was 75% with blinatumomab versus 48% with standard of care. And as you can see on the left curve, overall survival was significantly superior with blinatumomab versus chemotherapy. And it was also true for event-free survival. However, you can see that the curves are still low. When they did a subgroup analysis, you can see that all subgroup, it was in favor of blinatumomab, even if for older patient or if patient had already been transplanted. What about molecular response? So this is a study that was published by Professor Koch-Budget. The aim was to analyze the impact of MRD response after 2 cycles of blinatumomab treated for patients with relapse or refractory B-ALL. Just to be clear, MRD response was considered if there was a complete MRD response, that no detectable patient-specific rearrangements of immunoglobulin T-cell receptor genes, and also if MRD response also include patients with detectable leukemic cells, but inferior to 10^-4. And what you can see on the result is that MRD response had a better overall survival, a median with almost 21 months versus 12 months. And it was also true for relapse-free survival. So in this study, blina was effective in inducing MRD response in patients who with multiple prior lines of therapy, because more than 2/3 of the patients had already more than 3 lines of treatment. So, and when they look at MRD responder, they demonstrated longer overall survival with allogeneic stem cell transplantation, as you can see on the blue curve, but it was not statistically significant. In conclusion, MRD response was associated with better outcomes in terms of OS and RFS, supporting the value of achieving MRD for patients. In Tower studies, they also study the quality of life. That is a very important point, considering this patient was primarily heavily pretreated. And at the end, they conclude that it was in favor of blinatumomab for all measures except insomnia, social functioning, and financial difficulty. That is quite easy to understand, to apprehend. And what about the data in the real world, as we say? Badar and colleague published in 1 year ago a retrospective multi-center cohort analysis of 239 patients with B-ALL, and most of the patients had a relapse and refractory B-ALL. Median age was 48 years old, and almost 20% already received allogeneic stem cell transplantation. You can see that 29 patients had a Phi plus ALL and received blinatumomab in association of TKI. So this is a characteristic of and the response to blinatumomab. At the end, 67% of the patients achieved CR. So this is it is really similar to the Tower study. And it's always a good thing to see that the results in real life are as good or are similar to the clinical trial. And what you can see that most of the patients who were treated for MRD, 75% achieve MRD negative. So it was exactly like in Tower study. They could see 40% of the patients that develop a cytokine release syndrome, but most of the time it was a grade 1 and 2. And for neurological adverse event, 23% of the patients develop this kind of secondary event, but it was also manageable. And that didn't see particularly veno-occlusive disease that we are more used to see with inotuzumab. The median relapse-free survival was 32 months, so it was quite a very interesting result. And in the subgroup of relapse and refractory Philadelphia positive B-ALL, who received the association of blinatumomab plus TKI, the overall survival was not reached compared to 30 months in patients who received only blinatumomab. So this is quite interesting data for our patient to know that first, this is feasible to associate blinatumomab and TKI, but also it seems to be superior than blinatumomab alone. At the end, the median survival was in patients who achieved CR was 29 months. And in this study, allogeneic stem cell transplantation retained favorable prognostic significance. So what about patients who received transplantation after blinatumomab? Jabour and colleague in fact studies almost 100 patients who underwent transplantation from Tower study. 65 were treated previously by blinatumomab and 32 by standard of care. It is important to know that adverse events were not recorded after transplant unless they were related to blinatumomab. At the end, transplantation conferred a survival advantage in both blinatumomab and standard care groups compared with no transplantation. And so you can see this is this two line, in fact. When they did a subgroup analysis in patients who received blinatumomab, so it was 67 patients, they couldn't find, there were not enough evidence to detect a difference between patients with or without unstudied transplantation. And allogeneic stem cell transplantation were in fact beneficial in patients who failed to achieve CR. So in fact, patients who were not in CR and received transplantation, so this is this line, allogeneic stem cell transplantation seems to erase the bad prognosis of not being in CR at transplant. In population who received blina and achieved CR, they did not find any difference between the two groups. And so survival was found to be driven by response to study treatment and by salvage status, regardless of unstudied transplant study. But this data should be interpreted with caution because this current study was not designed for this endpoint. So this is a more recent publication. It is a multi-institutional publication in adults who received blinatumomab for relapse and refractory ALL. And almost 90% of the patients received transplant after blinatumomab in CR. The PFS was almost 19 months. So this is quite, I think, interesting result. And this is a curve you can, I think, keep in mind when you know the result of also of CAR T cell. At 3 months, the cumulative incidence of grade 2 to 4 acute GVHD was 24%, and of grade 3 to 4, 10%. So this is what we are used to see in transplantation patients. And for chronic GVHD, it was 34% at 2 years, and for moderate to severe chronic GVHD, 24%. So it was acceptable. The median number of cycles of blinatumomab to transplant, or the median time from blina to transplant, was not associated with GVHD. Interestingly, the NRM was quite low because it was less than 10%. Of course, they'll look at the status at transplant and patients who respond at better survival probability. And it is also the case in patients who are MRD. So we can conclude with these studies as blinatumomab is safe and effective in bridging relapse refractory ALL patients to transplant. And I think this is usually the way most of the hematologists use blinatumomab actually. So what about blinatumomab in Phi+ ALL? So there is another study that it was a single arm phase 2 multi-center study. This name is Alcantara study. They include Phi+ ALL adult patients who had relapsed after or were refractory to at least one second generation or later TKI, who were intolerant to a second generation or later TKI. They enrolled 45 patients. What they could see that around 36% achieved CR within the 2 cycles. And the median follow-up was only 9 months, in fact, with a median RFS of 6.7 months. So this study is important because thanks to that, you can we have some data on blinatumomab in a prospective study, but probably the association of TKI and blinatumomab seems really better than only blinatumomab in this case. When you look at RFS, it was 6.8 months, the median OS 9 months, and of course MRD negativity was very prognostic. A median time to relapse for the patient was around 7 months, and at the end 11 patients received TKI during the long-term follow-up period. 9 patients underwent allogeneic stem cell transplantation. And about safety, this is quite we are used to see around 10% of CRS, but none were more than grade 3. And neurological adverse, it was 62%, but most were grade 1 or grade 2. So the efficacy and safety findings from the final analysis were consistent with what was reported from the primary analysis. And trials evaluating the efficacy and safety of the combination of blina and TKI with or without chemotherapy are really wanted. So now I'm going to talk about the second antibody that is used in B-ALL, that is inotuzumab ozogamicin. And as you can see, this is a different construction. This is an antibody with a linker with the chemotherapy that is calicamycin. And after the antibody has been bind on the CD22, it is internalized in endosome and lysosome, and then calicamycin can induce apoptosis by a DNA break. The main study was INNOVATE, that is also a phase 3 study that randomized in patients who were in relapse and refractory B-ALL to receive either inotuzumab versus standard of care. The median follow-up was almost 30 months, and the proportion of patients who achieved CR was higher with inotuzumab compared with standard of care. It was 74% versus 35%, so more than the double. And the duration of remission was also longer with the INOMA arm, but as you can see, it was almost 1 month. The PFS was also longer. As you can see, the curve in a pink red of inotuzumab is significantly better than standard of care. However, as blinatumomab, you can see that they are quite low. The median overall survival was 7.7 months versus 6.2 months. And so it was statistically significant when we consider statistic, but it is really a bit different in a clinical way. More patients proceeded to transplantation at any time after study treatment in the INO arm. And inotuzumab treated patients achieving CR, overall survival was significantly improved for patients who underwent a transplantation in comparison with patients who achieve CR, but who do not proceed to transplant. As you can see, this curve. However, it's very important to know the hepatotoxicity adverse event that were more frequent in INO arm, and almost 14% develop a SOS syndrome. What about a patient who were treated with transplantation. So Marks and colleagues pooled analysis included more than 100 patients treated with inotuzumab and 31 with standard of care. And they could see that patients with inotuzumab were more likely than those in the standard of care group to have elevated bilirubin and cytolysis also, and reduced platelets. Cumulative incidence of NRM at 3 months was really higher in the inotuzumab arm. When you look, it's 22% versus 6.5%. But this difference generally decreased over time, as you can see the curve. However, you have really to be careful because almost 10% of the patient died from VOD in the INO arm. PFS and OS varied over time with evidence of a increased mortality early, but a decreased mortality later. And very recently, they study also the level of CD22 expression on leukemic blast. And the aim of the study was to assess the relationship between the CD22 expression and the outcomes in inotuzumab versus standard of care. As you can see, when leukemic blast express more than 90% of CD22, they find that the survival probability was higher, but it was not the case if the CD22 expression was lower than 90%. And so patients with high CD22 expression and normal cytogenetics benefited the most from inotuzumab ozogamicin therapy. So what about combination? Because we know that antibody are are very effective, but it's only antibody. Combination is always a better option. I mean, when you look at, for example, in lymphoma or myeloma. So there was this study published by Jabour and colleague about 48 patients who received mini hyper CVD with or without blinatumomab in first salvage. As you can see, patient received first mini ICVD, then 4 cycles of blinatumomab, and then a maintenance phase. When you look at the patient, the median age was 39 years old, but one patient was almost 87 years old. And they, in fact, also look at the result that 50% of the patient underwent hematopoietic stem cell transplantation in CR2. The 2-year overall rate for patients who underwent transplant and those who did not were quite comparable. When you look at overall survival at 2 years, it was 54% and PFS 42%. So we are in second line. So I think this, when we look at historical study, there are really interesting results, and this association is very interesting for patients. And what about testing these antibodies, but in first line? So we have some study that...
So 2 minutes.
Okay. That in fact combine blinatumomab and with also chemotherapy in first line. And what they saw, in fact, that we can see there, that they compare this result with historical study, and they saw significant better overall survival and event-free survival. And for the last, very interesting, and we have all seen, is to use a chemo-free treatment in first line using dasatinib and blinatumomab that was recently published in New England. what they saw that patients were treated with dasatinib and glucocorticoid, and then with blinatumomab. At day 85, 98% were in hematological CR. So this is really, interesting data. And at the end of the second cycle of blina, 60% was in molecular response. And this is a new chemo-free induction, and the consolidation strategy was feasible. So to conclude, the incorporation of monoclonal agents has revolutionized and changed the treatment of ALL. However, the optimal sequencing and combination of this agent has to be defined. We know that early infusion of blina and eno after debulking with low-intensity chemotherapy may reduce the need for intensive chemotherapy and also reduce TRM. And there are also other monoclonal antibodies that have been under investigation that will be new, in fact, targeted treatment and approach for for the future years. So I would like to thank all my colleagues from Saint-Antoine Hospital, especially Professor Moti for his mentorship. And I would like to thank you for your attention. And I will be very pleased to take any question. Thanks.
Thank you so much, Dr. Bresso, for this excellent presentation. We have a question from Professor Martinelli. He's asking about, in your opinion, why some patients didn't respond to blinatumomab?
Yes, there is a biological study that have been recently published. And finally, what seems to be interesting is the level of CD19 on expression of leukemic cells, and also the characteristic of T cells of the patient. This was, but it's not really easy to have prognostic factors to know if this patient with response to blina or not. We're not really able to know that.
So it's not clear from upfront.
No, but usually you have to do 2 cycles and you have your response. If patient don't respond after 2 cycles, it won't work.
So I think there is no more question. Thank you so much, Dr. Bresso, for this talk. You have a nice day, inshallah. So our third lecture will be by Dr. Gassina Bouk. She will talk about incorporation of novel therapy in treatment of AML-MDS. Dr. Gassina Bouk is a consultant and senior physician at the Department of Medicine at Goethe University in Frankfurt, Germany. She's a head of the transplant and cellular therapy program in her institution. Her clinical research interest is in malignant hematology with some focus in leukemia and MDS. She has conducting a study in post-transplant intervention using epigenetic modifier and kinase inhibitor. She's a member of many national and international institution society, and she's a chair of post-transplant pharmacological modulation subcommittee of acute leukemia. Welcome, Dr. Gassina, and you can start, please.
Okay, thank you, Mona. Just a second. Okay, can you see my?
Yeah.
Okay, very good. So yeah, thank you very much, the organizers, for inviting me to this very interesting meeting. Dear colleagues, I'm going to talk on the incorporation of novel therapy in the treatment of AML and MDS. These are my disclosures. So in the last decade, we've seen improvement of survival in AML patients from 35% at 3 years to more than 50%. And this is also true for MDS patients, especially in the first 3 years after transplant. However, patients still die, and within the first 100 days after transplant, this is primarily from the underlying disease, but also from GVHD and organ failure. After 100 days after transplant, most patients die from relapse of their underlying disease. These are commonly used conditioning regimens in AML or MDS. And as you can see in myeloablative conditioning regimens, primarily busulfan or TBI has been used, and reduced intensity conditioning regimens also contain melphalan, but there has not been much change within the last years. Novel therapies might improve survival after transplant, and novel therapies have been incorporated in the pre-transplant, peri-transplant, or post-transplant setting. So pre-transplant for induction or consolidation therapy, midostaurin, gilteritinib, CPX-351, venetoclax plus hypomethylating agents, or gemtuzumab, also gamacine, have been used in the peri-transplant area for conditioning or GVHD prophylaxis. Treosulfan has shown improved survival in MDS and AML patients, primarily because of very low non-relapse mortality. And post-transplant cyclophosphamide has made feasible haploidentical transplant in many centers. And in the post-transplant area, for maintenance of preemptive therapy, non-targeted therapy have been used, targeted agents against FLT3, BCL2, IDH1 or 2, and Hedgehog, as well as cellular therapies. At the last EBMT meeting, data from the Connect Myeloid Disease Registry, which is a large ongoing US multi-center prospective cohort study with patients with AML or MDS treated in different centers, have been included. And the first analysis concentrates on newly diagnosed AML patients, nearly 600 patients. Half of them received intensive induction and nearly 20% proceeded to transplant. And you can see that mainly patients that have received intensive therapy were in remission. And all the novel drugs I've mentioned before have already been used. And the treatment flow for patients in CR show that about 1/3 of patients proceeded to transplant, and a surprisingly high number of patients received maintenance treatment with novel drugs. So here are the patients in CR that proceeded to transplant or not transplant, and patients who were transplanted were younger, but all other characteristics were not very different. And you can see that overall survival of transplanted patients is superior than those without transplant. That was, however, not statistically significant. So prerequisites for targeted therapy post-transplant are that therapy must target a lesion that persists at relapse. It must be tolerable in vulnerable patients after transplant. It must be compatible with immunosuppressive and supported therapy. It should not increase GVHD, and it should not impair GVL effect. I will now focus on FLT3 inhibitors, and there are 3 inhibitors in use: midostaurin, sorafenib, and gilteritinib. And midostaurin and sorafenib are multi-kinase inhibitors that target other kinases than FLT3, and gilteritinib is much more specific. Now, midostaurin has been approved for induction therapy and consolidation in combination with intensive chemo, and can also be given for maintenance, but not in patients who were transplanted. Gilteritinib has been studied in the Admiral randomized phase 3 trial and has been given, has been compared to salvage chemotherapy in patients with relapsed or refractory FLT3 mutated AML. Primary endpoints were overall survival and CR rate, and about 20% of patients had received prior transplant. In these patients, the CR and CRI rate was 35% in the gilteritinib arm versus 11% in the chemo arm. And patients that had early relapse after transplant had benefited more from gilteritinib than patients with later relapse. And in the recent EBMT meeting, there were also data on gilteritinib monotherapy in relapsed or refractory AML, FLT3 positive, and results were very similar. Patients received gilteritinib prior to transplant or after transplant. CR rate was about 50% and overall survival 36% at 1 year. So gilteritinib is quite effective. What about midostaurin? Midostaurin was tested as maintenance treatment in the RADIUS randomized phase 2 trial in patients with FLT3 ITD positive AML in CR1. These patients had no TKI exposure pre-transplant, and midostaurin was randomized versus standard of care. Patients started treatment between day 28 or 60 after transplant for 1 year, and primary endpoint was relapse-free survival at 18 months. Now, as you can see, relapse-free survival was not different between patients that received midostaurin versus those who had no midostaurin maintenance. But this trial included 60 patients, and only half of them completed the 1 year treatment. So the median midostaurin exposure was 10 months, and midostaurin was effective, but only if the phosphorylated FLT3 was inhibited more than 30% compared to baseline. So patients that did not had no benefit, their FLT3 inhibition was not effective enough. The sorafenib maintenance trial, the SORMAN randomized phase 3 trial, included patients with FLT3 ITD positive AML in CR after transplant. Patients started treatment between day 60 and 100 after transplant and continued for 24 months. Primary endpoint was relapse-free survival. 83 patients were included, median age 54 years, and patients received treatment for 8 versus 12 months. And the most common reasons for discontinuation of treatment were in the sorafenib arm adverse events and in the placebo arm AML relapse. Now this study achieved its primary endpoint, and relapse-free survival was significantly better in the sorafenib maintenance arm than in the placebo arm, 85% versus 53% at 2 years. And also overall survival was significantly improved. About 2/3 of patients were not in CR or had MRD positive AML before transplant. And these patients also had a benefit, but the strongest benefit of maintenance treatment were observed in patients that were MRD negative at the time of transplant. None of these patients relapsed after transplant. And there's another Chinese randomized phase 3 trial that evaluated sorafenib in FLT3 positive, ITD positive AML in CR prior to transplant and after transplant. Treatment was also scheduled between day 30 and 60, but only for 6 months. And primary endpoint was 1 year cumulative incidence of relapse. 202 patients have been included. These were very young, only 35 years of age, median. And as you can see, relapse was much higher in the control group than in the sorafenib group, 31% versus 12%. Leukemia-free survival and overall survival were also improved in the sorafenib maintenance arm, and these results were significantly better. Now, sorafenib has another benefit for patients after transplant beyond inhibition of FLT3 ITD, because AML blasts downregulate the production of interleukin-15. And interleukin-15 promotes survival and activation of alloreactive T and NK cells. And it has been shown that sorafenib increases IL-15 production in AML blasts and in patients that respond to sorafenib after transplant, IL-15 levels in the blood are increased, actually. Now, there have a real-life experience of sorafenib maintenance after transplant has been published at the most recent EBMT meeting. And as you can see, the 20 patients that have been included many of them stopped sorafenib prematurely. The median sorafenib exposure was 180 days, and most common toxicities were skin, gastrointestinal, hematologic, but also hypertension and hepatitis. But still, patients had a benefit from sorafenib maintenance, and 2 years overall survival was 88% versus 45% in a non-maintenance comparison. Now, there are many other studies evaluating FLT3 inhibitors as post-transplant maintenance, as you can see, and we expect this data within the next years. I now switch to hypomethylating agents. Here, there's a paper from EBMT combining HMA and venetoclax, a retrospective analysis of 24 patients with de novo AML or relapsed refractory AML. Venetoclax has been administered at 400 milligram a day continuously in 28-day cycles and combined with standard dose decitabine or azacitidine. And patients received a maintenance of 3 cycles of venetoclax in combinations with hypomethylating agents. CR/CRi rate was 60%, and patients responded fast, 2 months after start of therapy. Now, 9 out of 28 patients were able to proceed to transplant after a median of 3 cycles. And all these patients are alive and in CR. And median overall survival for transplanted patients was better than for non-transplanted patients. And toxicity was quite manageable, mainly hematologic toxicity. But azacitidine can also be combined with DLI as salvage treatment for relapse after transplant. Here, 27 patients have been studied retrospectively who relapsed after transplant and had a median number of blasts of 30%. They received a median number of 2 AZA cycles and also 2 doses of DLI. Overall response rate was 41%, 22% of them, of the patients achieved CR. And CR and also stable disease duration was quite prolonged, nearly 1 or 2 years. And patients who had a lower disease risk index had better survival, as you can see. Patients could not receive DLI for disease progression or GVHD mainly. And these patients can also be bridged to a second transplant. Now, there is another paper that combined venetoclax with azacitidine or low-dose cytarabine. Retrospective analysis, and venetoclax was used at the dose of 100 mL continuously and combined with posaconazole. Therefore, the dose was quite low, plus azacitidine or low-dose cytarabine. Patients had a median time from transplant to relapse of 1.8 years, and 50% of them had adverse cytogenetics. Patients responded fast after 2 cycles, but responses were short, only 2 months, and infectious complications were quite common. The others recommend treatment breaks because patients have very deep aplasia during this therapy, and patients should be allowed to recover and before the next treatment cycle is started. This treatment can be used for patients for which another transplant is scheduled. Now, these drugs are not sufficiently effective in patients with open relapse after transplant, but preemptive therapy in patients with MRD or falling donor chimerism may be more effective, and this has been studied in the RELASER-2 trial. Primary endpoint was relapse-free survival after 6 months, and standard dose of AZA was applied for a maximum of 24 cycles, and patients were AML or MDS patients in complete remission. Now, patients did better after transplant than those who were included after chemo only. And this was because we know that azacitidine can modify the anti-leukemic efficacy by upregulation of tumor antigens in AML blasts. I come back to that later. So another maintenance trial using azacitidine has been performed in the United States. It was randomized against a standard of care. And AZA was used in a much lower dose, only 32 mils per square meter, day 1 to 5. Treatment should be started between 42 days to 100 days after transplant for 12 cycles. In this trial, patients with high-risk AML were included, and in total, 187 patients, median age 57 years. No difference in outcome was observed between the azacitidine and standard of care arm, but only 1/3 of patients completed the 12 cycles. And this study was performed over quite a long time. It needed 7.5 years to enroll and was prematurely finished. So maybe AZA has some benefit, but only in prolonged maintenance. The last study I'd like to present is a Chinese study using decitabine and GCSF maintenance. Decitabine is known to be more effective in AML blasts that enter cell cycle. So GCSF is used to bring AML blasts into cycle and then add decitabine. So GCSF is given day 0 to 5, and decitabine is added day 1 to 5 in every 6 to 8 weeks in 6 cycles versus standard of care. Treatment started at day 60 post-transplant earliest, and the primary endpoint was cumulative incidence of relapse. So in this trial, patients with high-risk AML were included. They needed to be in molecular CR post-transplant, and these patients also were very young, with a median age of only 30 years. As you can see, patients who received maintenance treatment had a much lower cumulative incidence of relapse of 15% versus 38% in the standard of care group. And patients who were in molecular CR also prior to transplant, they had the highest benefit. And in these patients, the cumulative incidence of relapse was only 6%. There were also lab analysis that accompanied this study. And as you can see from the 3rd cycle on, CD8 T cells and NK cells increased in number, and also regulatory T cells. And this might contribute to a better control of leukemic cells by the immune system. And this might contribute to the lower relapse, to the better relapse-free survival in patients that receive decitabine and GCSF maintenance. So to conclude, post-transplant targeted interventions focused on FLT3 inhibitors and hypomethylating agents. The most recently published studies have explored maintenance strategies, randomized evidence for reduced relapse rate and improved relapse-free survival for sorafenib and decitabine GCSF maintenance have been shown. And preemptive therapy is mostly limited to small retrospective study. In the salvage setting, FLT3 inhibitors or hypomethylating agents are of limited benefit, even if combined with DLIs. And studies with novel agents like venetoclax or IDH inhibitors are ongoing. Future studies should concentrate on maintenance and preemptive strategy to maximize the impact on survival. And with that, I'd like to thank you for your attention, and I'm looking forward to your questions. Thanks a lot.
Thank you so much, Dr. Bug. That was excellent. While waiting, we have a few minutes maybe before the break. I'll start with a question. Maybe it's an arbitrary question. The graph that you showed, the patients who had excellent survival after achieving MRD negativity with FLT3 inhibitors. I wonder, any of these patients who achieved MRD negative status did not get transplant, and how was their survival if there is no transplant for them?
Well, indeed, it is a question if patients that achieve MRD negativity prior to transplant should be transplanted. So the problem is patients with FLT3 ITD mutations, they relapse very rapidly. And so it is quite a challenge to follow these patients on MRD basis and make a decision on transplant when MRD is occurring again. So in view of these very, very good results of patients that proceed to transplant in an MRD negative status, at least young patients and patients with a low transplant risk, they should proceed to transplant.
Excellent, thank you. Maybe last question, for post-transplant relapses, any specific molecular mutations will guide you to use venetoclax hypomethylating agent versus other targeted therapy in those patients?
Yeah, so except for FLT3 mutations, we don't have specific targeted drugs at the moment. So it is known that patients with NPM1 mutation and IDH mutations, they respond excellently to venetoclax HMA combination. So, and for patients with unfavorable cytogenetics and molecular genetics, we should give a trial. It's not clear which patients respond. So post-transplant salvage treatment should start at the earliest time point possible with low blasts in the bone marrow, because then the salvage treatment is more effective. And I think we will see novel drugs like specific IDH inhibitors or like BCL2 inhibitors that will improve the results further.
Excellent. Thank you so much, Dr. Bug. That was great. Thank you.
Thank you.
So with that, we are going to conclude our third session for today. I would like to thank my co-chair, Dr. Mona Asiri, and the eminent speakers that were with us in the three talks. We'll have a break for prayer, and then we'll be back at 7:30 for the fourth session, lymphoproliferative disorders, and will be chaired by Dr. Amal Abdel Wahab and Dr. Sarah Al-Ammari. Thank you so much.
Hello. Assalamu alaikum wa rahmatullah.
Hi, hello.
Yes, hello. Assalamu alaikum wa rahmatullah. So on behalf of SSBMT, I'm welcoming you all. I'm Dr. Sarah Al-Ammari, hematology consultant currently working in Sir Central Hospital South Region. And me and Dr. Amal Abdul Wahab, we have the honor to lead our last session in this collaborative great event. So it will be focused on the lymphoproliferative disorders, and we will start by thanking the organizing committee and the sponsor. Special thanks to AstraZeneca for sponsoring the first talk, which will be about the evolving treatment strategies in CLL. It will be presented by Dr. Porshik Yorshik, who is our special guest speaker, graduated from Academy of Medicine, Krakow, Poland, and he carried on his PhD and specialized in internal medicine and hematology. He is also a consultant of AMA, covering a number of companies. He is currently the chair of the Department of Hematology in Krakow, Poland. And he has been working on several high impact factor research publications. It's a great honor, Dr. Yorshik, to have you today or tonight, and we are waiting to hear from you. The mic is yours. You can share your slide, please.
Okay. Hello. Let me share the screen, please. Hello. It's a great honor to be with you. Thank you for joining me after such a long day full of interesting lectures. Now, for the next 20 minutes, I would like to guide you through chronic lymphocytic leukemia. In Central Europe, where I live, chronic lymphocytic leukemia seems to be the most important and the most frequent indolent lymphoma. It accounts for 1/3 of all lymphoma cases. Therefore, every general practitioner will sooner or later encounter a patient with a chronic lymphocytic leukemia. To summarize it, it's the disease of the elderly. The median age of diagnosis is above 65. 10% of the cases has less than 55 years. 70% of the cases are older than 65 years old. It is important because if we regard the number of comorbidities, it does increase with age. If you look at the population of over 75 years, at least 40% of the patients will have 5 coexistent comorbidities. It does limit the chemotherapy offer, and we have the very specific subpopulation of patients which have the indolent disease. However, the very disrupted immune system, particularly prone to infections. It was especially true in the time like we survived in the time of COVID pandemic. Once we looked at the infection-related mortality, it was pretty devastating. So if you're looking at this cumulative illness rate scaling, which we use, the most frequent one is Sears geriatric score, and it's very pragmatic to use one of those web-based calculators. I particularly like them because they very clearly indicate what is important and what is not important. Not everything is very straightforward. Like if you look at the heart conditions, you may have vascular problems, but you may also have cardiac problems, and they are slightly separated. So as you see, the majority in Europe, the majority of population will have hypertension, a third will have lipid disorders, a quarter ischemic heart disease, 1/5 diabetes mellitus, or rheumatoid arthritis. Nearly 90% of the patients will have at least one major comorbidity, and half of them will have one severe comorbidity. Therefore, it is still true that as long as we may, watch and wait is the standard of care. We do not want to treat the patients unless it's necessary, specifically with CLL, which is the disease which is a slow, dynamic, recurring process. Therefore, what was true 2 decades ago is still true at the moment. We do not treat the patient because of diagnosis. We treat the patient because they have symptoms like B symptoms, classical for hemato-oncological diseases, night sweats, weight loss. Once they have a tumor burden assessed by progressive lymphadenopathy, large splenomegaly, a fast doubling time of lymphocytes, if it's observed in less than 6 months, and organ dysfunction. Eventually, we look for the bone marrow failure, like progressive anemia and or thrombocytopenia, regardless the cause, and immune dysfunction. If we look at the prognosis, it's still an incurable disease, but it changed very rapidly over the last 20 years. If you look in the era of chemotherapy, which was between 1960s and 1990s of the last century, we tested a lot of different chemotherapy regimens, starting from alkylating drugs, then purine analogues and combinations. Now, whatever we do, we increased or prolonged the progression-free survival. However, the overall survival time was not affected. It was usually 5 to 7 years, regardless how intense the chemotherapy was. The first single drug which prolonged overall survival was monoclonal antibody, namely rituximab, introduced around year 2000, which not only increased complete regression rate, but also prolonged progression-free survival, and the median overall survival was between 10 to 12 years. And now in the present era, after 2010, when we have new monoclonal antibodies, new drugs with alternative action to cytostatics, like BTK inhibitors, IP3K inhibitors, BCL2 inhibitors, we have the median overall survival of 20 years. Now, if we have the patient who is diagnosed in 2021, he still have the same incurable disease. However, we may tell him that within the last 30 years, we prolonged overall survival 4 times. If all goes well, it's quite possible that within the next 20, 30 years, we will also prolong overall survival, double or triple it. Therefore, the chronic lymphocytic leukemia, for the majority, will be the chronic disease with the patient, and the patients will die with this disease and not because of this disease. So at the moment, if you look at the chronic lymphocytic leukemia cell, it's not the place for chemotherapy. It's a place for monoclonal antibodies like rituximab, obinutuzumab. It's a place for BTK inhibitors, all generation, but everything here started with ibrutinib. Then we have acalabrutinib, we'll talk about today, zanubrutinib, and the third generation inhibitors, eventually venetoclax, the BCL2 inhibitor, or IP3K inhibitors. IP3K inhibitors are a little bit abandoned due to the adverse events which were pronounced, at least in the first generation drugs. So looking at bruton thyroid kinase inhibitors, how selective they are. Ibrutinib was very good drug, but a rather unspecific inhibitor of a lot of TEC family kinases. If you look at this chart, the smaller the number, the greater the strength of the drug. Therefore, if you look at the ibrutinib, which has here 1.5, then the second generation are slightly weaker. However, still the action is important. If you look at the TEC kinase, the TEC kinase was strongly inhibited by ibrutinib, but is very weakly inhibited by the second and third generation BTK inhibitors. Therefore, we may say that the atrial fibrillation, which was number one problem because it caused quite a proportion of the patient to, it made quite a proportion of the patient to be discontinued on ibrutinib. It's possibly due to ibrutinib metabolism, and it is frequent with this drug. As I will show you later, it does not happen with acalabrutinib. The bleeding is particularly connected with inhibition of TEC kinase, so it's much more pronounced in ibrutinib than in second generation inhibitors, and so is the diarrhea, which is somehow connected with EGFR kinase. If we have the pooled analysis of safety data, look at the number. It's one of the papers we published this year. It's over 1,000 patients. And as you see, acalabrutinib is a very safe drug. Just look at the infections. Yes, that's true. We have 60 to 70% of patients who will suffer from infections. However, look at the time factor here. After 2-3 years, we very rarely have new infections. Therefore, if the patient survives the first couple of years, then the drug could be used very, very safely. Now, the thing which is particularly encouraging is the rate of atrial fibrillation. Practically, it's kept below 4%. And it's a striking difference with ibrutinib. The same pooled analysis of safety data we published for zanubrutinib, a smaller number because that's a drug which is on the market for a couple of months only, really, and the same issue. The plateau in infections, slightly more infections than in ibrutinib, not that very much, grade 3 or greater, and a magnificent curve for atrial fibrillation or flutter. Once we look at the history, we had, for the last decades, we taught our students that immunochemotherapy is the standard of care. We even divided all the patients to go-go patients, slow-go patients, or no-go patients. We tried to figure out which are the best chemo regimens for subsequent groups. But this is challenged against molecularly targeted drugs like ibrutinib, acalabrutinib, and other BTK inhibitors. Therefore, we may say that although we still use immunochemotherapy, it's used less and less frequently, particularly in the States. If we take 220 ESMO recommendations for the first line of CLL, it divides patients into 3 categories. Those with TP53 mutation or deletion of 17p, and these are the patients where we do not think of anything else but acalabrutinib, ibrutinib, or venetoclax. These are the patients which will not react to the classical chemoimmunotherapy. Then we have patients with unmutated EGVHV status, however, without mutation. And this is the major change, as in 2019, we still allowed chemoimmunotherapy here. Now, it's very clearly that the therapy of choice are BTK inhibitors, and we're talking about the first line. And eventually we have the diagnostic subgroup with which these are the best patients. the EGVH mutated status, no mutations. And here we have the only subgroup, the younger patients, where FCR regimen is allowed. The NCCN was even more stringent. It was absolutely certain that the patients with 17p deletion or TP53 mutation, they do not allow any immunochemotherapy. It's acalabrutinib or acalabrutinib plus obinutuzumab, which is regarded the therapy of choice. For the patients which with a better prognosis without mutations, it's still BTK inhibitors. And look here, acalabrutinib for NCCN is the category 1, is the first therapy of choice. So all these recommendations were based on very profound clinical studies. So let me guide you through the clinical studies at CLL at diagnosis. These are the old data, however, upgraded in 2017, demonstrating that FCR is suitable only for young patients with a mutated status, with mutated EVH genes. This is the best diagnostic subgroup. We may observe even a plateau here. For all the others, we do not like this kind of therapy. Again, if we look for the old studies and deletion of 17p or mutation of p53, you see that it's such a patients with deletion or mutations are clearly worse than the others, and chemoimmunotherapy is not allowed. So FCR as the most efficient immunotherapy will not be used in those patients. Now, on the contrary, this is the worst diagnostic subgroup, so the subgroup with 17p deletion, treated in the first-line BTK inhibitors. This was shown last ASH, and it's at 4 years, we have 80 patients without progression. Median progression-free survival is not reached. And this is the chart which summarizes the patients from 4 randomized studies, a kind of meta-analysis. If you want to look at in details, these are those studies, and as you see, in whatever the study we take, there is a progression-free survival advantage of a BTK inhibitor versus immunochemotherapy. So if you look at...
Sorry, doctor, we have 1 minute more.
Sorry?
We have 1 minute more. Still, we have another 5 minutes for questions.
I don't quite understand you. Shall I carry on?
Yes, 1 minute more.
Sorry?
1 minute more. We have limited time. 5 minutes will be for question and answer.
Oh, I see. I thought that was 20 minutes. So SSD, ibrutinib was better than placebo, was better than chlorambucil, specifically in high-risk patients. Then we checked BTK inhibitor with monoclonal antibodies. And monoclonal antibodies does not increase progression-free survival, but they increase the response rate. So there were generations of studies which explored this problem. Now, let me just mention this younger patients with naive disease, where ibrutinib plus rituximab was better than FCR, and it was better in progression-free survival as well. Sorry, I made it faster, but once I looked at the program, I thought we had 25 minutes for the session. Now, if we summarize the acalabrutinib studies, there are a variety of them, and the most important one for the treatment-naive patients was an ELEVATE-TN study, where we had over 500 patients previously untreated, which were randomized to acalabrutinib or acalabrutinib with obinutuzumab versus chlorambucil with obinutuzumab, which was regarded as standard of care for the young patients. And to summarize it, we had marked an important progression-free survival difference with sustained in whichever the risk subgroup we analyzed. The adverse events were moderate and were absolutely acceptable compared to the options. In relapsing refractory setting, which I will just want to indicate that acalabrutinib proved to be very efficient in patients intolerant to ibrutinib, and the ASCENT study we recently published, acalabrutinib was better than a therapy of choice. And at that stage, the therapy of choice was chemoimmunotherapy or idelalisib, which is IP3K inhibitor. And evidently, it was the first study which clearly demonstrated the BTK inhibitors are better than IP3K inhibitor. Again, the sub-analysis showed that the results hold in all treatment subgroups. And eventually, before we end, we have to mention a Murano protocol, the only time-limited protocol we have, where we have venetoclax plus rituximab, always also with a magnificent results expressing an efficacy in relapsing refractory patients. The last slide I want to show you is the third generation BTK inhibitor, which proved to be efficient not only in BTK naive patients, but also in the patients who progressed on BTK. In fact, we had 60% of responses in patients who were refractory to chemotherapy, to immunotherapy, to BTK inhibitor, and to venetoclax. And I'd just like to draw your attention to two head-to-head randomized comparisons we have, and you'll have the results presented at EHA and ASCO meeting. So we have an acalabrutinib versus ibrutinib head-to-head comparison, the study which met the primary target, and the adverse events of acalabrutinib are very much less important than those of ibrutinib, and acalabrutinib is not, results are not worse than ibrutinib. And eventually there's zanubrutinib versus ibrutinib, the paper which got to the presidential EHA symposium 2 days ago. So therefore, the take-home message is that targeted therapy is undebatable standard of care in chronic lymphocytic leukemia at the moment, and it's moving from relapsing refractory to the first line. And the only alternative we may have is the BCL2 in combination with rituximab. And the last thing is that inhibition of BTK and BCL2 seems to be very, very efficient. Sorry for prolonging the lecture, but I thought we had more time. Thank you.
Thank you, Dr. Yorshik. I think we don't have more time for the question, but only I need one comment about the cardiac side effect in acalabrutinib. How would you manage it? Shortly, please, and thank you so much.
How shall I manage acalabrutinib in? Didn't quite get your question.
The cardiac complication in acalabrutinib, how would you manage it?
The complication of acalabrutinib, sorry, the line is bad. So you want the application, the acalabrutinib, and what I want to say is that if you have the patient who is not tolerant to the first line BTK inhibitors like ibrutinib, you can certainly switch them to acalabrutinib, which is safe and efficient. Now, there are very rare clinical cases where we have to discontinue acalabrutinib. On the long-time run, it's less than 10% of the patients, compared to nearly a quarter of ibrutinib patients who have to be discontinued. If that answers your question.
Thank you, Dr. Yorshik. Thank you. Dr. Aman.
Yeah, thank you, Dr. Sarah. So now moving into the next presentation, which is a management of multiple myeloma post-transplant. And Dr. Mohammed Mati, he's a full professor of hematology and head of the hematology and cellular therapy at Saint Antonio Hospital and Sorbonne University, Paris, France. He's also head of translational research team at the Saint Antonio Research Center. He also served on the board of EBMT and IFM. The floor is yours, Dr. Mohammed.
Thank you very much, Dr. Amal. Assalamu alaikum and Masa al Khair. It is really a true pleasure and a big honor to be with you tonight. And inshallah, next time we can be together in person as we used to do, since we have launched a few years ago this initiative of collaboration between SSBMT and EBMT, thanks to the great efforts of and leadership of Dr. Al-Askar. So I have been asked for tonight to give you an overview about the treatment options of multiple myeloma after transplantation. These are my disclosures, and I think I need first to clarify the definitions of what we mean by post-transplant therapy. Obviously, in general, we would love to have a fixed duration of treatment for patient, and everybody would love this. In the case of multiple myeloma, unfortunately, we're not yet there. This is why we still need, and I'll show you the data, this continuous therapy, which can be divided after transplant into two big categories: the consolidation and the maintenance. The consolidation is actually a short duration, usually strong treatment with the aim to deepen the response rate after transplant. So this is usually something you give between 2 and 3 months after auto transplant, and then the goal is about increasing and deepening the response. Then after consolidation, we usually speak about maintenance treatment. And the maintenance treatment is more about a gentle therapy that you would give over many years or until disease progression. And here you would appreciate that the logistical and practical aspects, but also long-term safety, are extremely important, because obviously you cannot convince a patient to take a drug for many years if you are not able to show that it is safe, but also you need to be able to improve the outcome, namely overall survival, because otherwise the patient would say, and the health system who's paying for this would say, well, why should I take it for many years if survival is not improved? So let me start first by highlighting the data that can serve as a basis. Why do we need consolidation and or maintenance? I think everybody now in the field is convinced about the value of the response after transplant. Actually, the better response you have, the better outcome you will achieve. And actually, more and more these days, it's about achieving MRD negativity, minimal residual disease negativity, or measurable residual disease negativity. And obviously, if you want to achieve such level of deep response, then definitely you need to give therapy after transplant, because we know very well that melphalan alone and transplant would not be sufficient to achieve this kind of deep MRD negativity. But we need to be careful. It's not only about achieving MRD negativity, it's also about sustainability. So it's not a single time point measurement and then the game is over. Actually, you need to make sure that this deep response is sustained over time. And actually, if you want to make it sustained over time, actually, on one hand, you have to hit first. This is consolidation. You achieve your deep response. And then you give the maintenance therapy to keep it under control. And you can see the data in favor of this. Also, there is a growing interest in the use of MRD negativity as a dynamic way to assess disease risk. And in this publication from the Spanish group a couple of months ago, they were able to show that MRD negativity can overcome the dismal prognosis of patients with high-risk cytogenetics. So in another word, actually, if you are able to deliver sufficient and enough therapy to achieve MRD negativity, even in the high-risk cytogenetics, then definitely you can change the natural history of these patients, and probably you can improve their outcome. So I hope you are convinced about the value of post-transplant therapy. Now, let me walk you through the data that we have in relation with consolidation after auto transplant. Actually, it's a 15-year-old story. Remember, in the 90s and early 2000s, the auto transplant story was a relatively simple one. You would do your induction with VAD, you do melphalan, and then wait and watch. Now, I think the consolidation concept and the maintenance concept are well established. And actually, 10 or 15 years ago, it was shown through small studies or larger studies later that by just delivering 2 cycles of consolidation, and then you can use the same regimen that has been used during induction, for instance, VTD here, bortezomib, thalidomide, dexamethasone, you can upgrade by 15% your response rate. And this is clearly of great value. And this has been very nicely shown in this Italian GIMIMA randomized trial. So this is a trial that established VTD, bortezomib, thalidomide, dexamethasone, as a standard care for induction compared to doublet TD. And actually, as part of this trial, they have given 2 cycles of consolidation. And you can appreciate that when you look to the arm of the trial, actually, you do have up to 30% of upgrade to complete remission post-consolidation. And actually, this is feasible with a relatively good safety profile. So very nice, I think, proof of concept. And they were able actually to document this and to prove it from a biological perspective, where they could show in a subset of patients reported in this abstract from 2010 that consolidation, and this is exactly the spirit of the procedure, can allow up to 5 log of median reduction of the tumor load. So you get rid of the tumor load, and then of course, you will be able to reach a deep response, and hopefully you will improve the outcome. So based on these data, actually, most European centers and cooperative groups recommended consolidation after transplant to everybody. And actually, this is our current recommendation. However, we need to be balanced and fair, and you have this American so-called STAMINA trial, which after transplant compared maintenance, consolidation maintenance, double auto maintenance. Then it's a very nice randomized trial to test the value of each of these interventions. And unfortunately, they were not able to show any difference. And the conclusion was that actually you don't need a double auto, a second auto for consolidation. You don't need a consolidation. Maintenance would be enough. However, of course, the devil is always in the details, and then it has to be read and analyzed in view of the criteria of this trial. Because when we look into the European Myeloma Network trial, and this has been recently communicated, and it will be published very soon in a nice journal. Actually, when you look in this randomized trial from EMN, and that was shown at the last ASH meeting, actually they have shown that there is a benefit for VRD consolidation. But again, as I mentioned, the devil is in the details, because then you have to figure out what did they receive before consolidation and for induction. So in the Stamina trial, patients were allowed to receive different sort of induction, different numbers of induction, maybe a long induction. So maybe the value of consolidation is not very important if you have used 6 or 7 cycles for induction of VRD. But if you have used something like VCD for induction and VMP, well, definitely, and melphalan, definitely a consolidation is useful and can has a benefit. So in summary, our view of consolidation is that it should be delivered to everybody, and that is our recommendation. Now, what about maintenance therapy? Well, the maintenance therapy story is also a relatively old story. You may remember probably the different randomized trials about thalidomide maintenance, and some of these trials could show an overall survival advantage. Some of them did not. The problem with thalidomide, also it's an oral drug, it has a lot of side effects, and usually the major side effect is about peripheral neuropathy, and usually you cannot give it for a long time. And what you would like to achieve in a maintenance setting is to give it for a long time. This is why lenalidomide was shown to be more attractive. Lenalidomide is less toxic compared to thalidomide. It's more effective. And you have 3 randomized trials, one from France, one from the US CLGB, and one from Italy, which looked into lenalidomide for maintenance after transplant. All these trials could show a PFS benefit. Not all of them could show an overall survival benefit. However, when you put them in a meta-analysis, and that was published by Dr. McCarthy 3 years ago, actually you do have a long-term overall survival advantage. Exactly, you are ticking the box of the need of the requirement for maintenance therapy after transplant. And this was further confirmed in this myeloma 11 randomized trial from the United Kingdom, where they could show that lenalidomide maintenance can also improve overall survival. And today, in the ESMO guidelines, of course, lenalidomide is approved and is recommended. Just one word about the use of proteasome inhibitors. We do have small data with the use of bortezomib, which can be useful, especially in the high-risk cytogenetics, because in general, we know that proteasome inhibitors are probably more effective in the high-risk cytogenetics. Unfortunately, they are not really always widely used because initially bortezomib was IV. Now we have subcutaneous bortezomib, which can make it a little bit easier. And in the HOVON trial, it has been given every 15 days. Of course, ixazomib, which is an oral proteasome inhibitor, very convenient, very safe, can be a good option. And it was tested in this randomized trial. The weakness in this trial is about the control arm, because it was tested against placebo. And of course, you would love to test it against the standard of care, which is lenalidomide, or you would like to combine it. So for me, actually, the question is more about how can we combine actually ixazomib plus an IMiD like lenalidomide, and this is gonna be tested or currently being tested by the Spanish randomized trial. But we have also another ongoing randomized trial testing daratumumab plus lenalidomide. So very interesting, using a monoclonal antibody, an anti-CD38. And daratumumab is a good drug for maintenance therapy. And in the next EHA meeting in the next couple of weeks, you will see the presentation about the update of the Cassiope trial, where we will show that daratumumab maintenance, single agent, is very beneficial. And now the question is, can we combine it with lenalidomide? So consolidation is probably very useful. Maintenance is definitely useful. Can we do better and further combine these approaches? And this is exactly the spirit of the Forte Italian trial communicated by Dr. Gay. So to make a long story short, I think you've heard the story some time ago. They use KRD. This is a standard induction, better than KCD. Then you have consolidation, but also what they tested is a doublet maintenance. And what's really interesting in this study is that they could show that, for instance, a doublet maintenance with carfilzomib and lenalidomide is clearly improving the outcome of these patients. Of course, carfilzomib is IV, not very convenient, but still, I think we do have a nice proof of concept. And maybe the field of maintenance is moving towards doublets or even triplets. So in summary, when it comes to the strategy of the transplant-eligible newly diagnosed multiple myeloma patient, I think it is now well established that quadruplet induction, I didn't mention them because that wasn't the topic of this talk, but quadruplet induction with daratumumab VTD or daratumumab VRD are the standard of care. Melphalan 200 is here to stay. We still didn't solve the problem of tandem auto, double auto. We usually use it for the deletion 17p high-risk cytogenetics. Otherwise, we do recommend consolidation using 2 or 3 cycles of the same induction regimen. And for the time being, maintenance is with lenalidomide for everybody. And as you can guess, the idea is clearly about decreasing and deepening and keeping significant control of the disease, although even if you cannot eradicate the malignant clone, but if you keep it under control for a long term, in a long-term fashion, well, definitely you will be able to achieve a sort of a functional or operational cure. So with this, I'd like to thank you all for your attention. Again, it is really a pleasure being part of this amazing and highly successful event with hundreds of people participating. This is really amazing. Thank you very much.
Thank you, Dr. Mohammed, for this elegant talk as usual. So the first question we have is how long post-transplant you suggest the MRD assessment and starting of the maintenance therapy?
Yeah, so this is a very good question. So when it comes to starting maintenance therapy, so usually we would offer consolidation between the 2nd and 3rd months. So if we're talking about when do we start maintenance, well, as soon as you finish your consolidation, so it's going to be like the 4th or 5th month. But also it depends on the tolerance and the general status of the patient. Because of course, maintenance is recommended. However, we should not neglect that, for instance, lenalidomide can induce fatigue. You may have some cytopenia. So of course, you have to adjust to the situation of every patient. In general, this is going to happen between the 4, 5th, or 6 months around this time frame. Now, the question about MRD testing, well, it depends if you're doing MRD testing routinely or not. Assuming you're doing it routinely, we would recommend having a sort of a baseline, let's say 3 or 4 months after transplant, and then maybe another measurement 6 months later. The problem is that you have to do a bone marrow aspirate, and usually patients don't like it. So we try to limit this to, over the long term, once per year, or maybe every 6 months. But of course, there is no clear recommendation today about how we're going to monitor MRD in these patients receiving maintenance, because the problem is that we do not have evidence-based data about what to do with the result. Assuming you are receiving lenalidomide maintenance and you prove that the patient is MRD negative, then you would love to stop maintenance. However, you don't have data telling you that you have to stop maintenance. On the other hand, if you show that the MRD remains positive, you don't have data telling you that maybe you have to switch drugs or change, combinations. So this is exactly what's being done now in the prospective trials, and hopefully in 2, 3, 4 years, we will get these results on how to use MRD to guide the treatment.
Thank you. So how about the toxicity? I mean, I know it's still early regarding combination of maintenance like DARA and lenalidomide. How about the toxicity? Especially those patients, they have still the bone marrow is sensitive. So they barely tolerate lenalidomide alone. So how about the combination?
Yeah, no, very good question. And of course, it will depend on the age, the comorbidities, the bone marrow reserve of your patients, the organ damage. In general, my feeling that it's going to be well tolerated. Probably you will see the side effects of lenalidomide. So you have roughly 30 to 40% of cytopenia, but we don't have infections, and then can be handled easily with GCSF. I think the major side effect is about fatigue, 70% of the patient with lenalidomide. And here, I think one way to get, to circumvent or to improve things is to give 3 weeks and give them 1 week rest, for instance, and not necessarily use dexamethasone, and also adjust the dose. You don't need to give 15 milligram, you can give 10 milligrams. So you have to adjust to each patient. When it comes to daratumumab, actually the safety profile of daratumumab is fantastic, especially if you're using the subcute daratumumab. So for maintenance, giving every month or every other month, subcute daratumumab if you are combining them. Of course, I'm not saying you should combine them because we don't have yet the results, but I'm just speculating on the feasibility once we will have the data. But I'm convinced that this is going to be very practical, for instance, to give lenalidomide oral drug and daratumumab subcute, because actually, if you give it subcute, this is 5-minute injection, and the patient will come to the clinic or to the hospital, and all the patient will come anyway every month or every other month for a checkup and to see their doctor. So it's not a big burden on the patient, I think.
Right. The last question, do you think there is any role for CAR-T in multiple myeloma post-transplant, like if they fail the transplant or if the disease progress or relapse?
Yeah, this is a very, very good question. Very nice. I think, there is a lot of speculation about CAR-T and auto-transplant. First of all, I think probably they will be randomized. And the question is whether you can just replace auto-transplant by CAR-T, exactly as it is being done now in lymphoma. That's one point. I think CAR-T can be useful in myeloma after transplant as consolidation. Assuming, for instance, that after auto-transplant, which provide a very nice immune environment for the expansion of CAR-T cells, you can give a single infusion of CAR-T cells and achieve deep MRD negativity, and then don't use any maintenance. So I think this is really a very good option. And of course, for relapse or for positive MRD after transplant, obviously CAR-T cells are really a very attractive option. So I'm very much enthusiastic about the combination and joining forces between auto-transplant and CAR-T cells.
Exactly, and especially it's a relative, like it's a new modality of treatment, and then we have to think about the maintenance consolidation in terms of CAR-T. How would we add it? Shall we consider it as a first line? Would it replace the auto-transplant, for example? Would it replace the allo-transplant? I mean, there are lots of concern about it and the toxicity. Also, the cost is one of the things that we have to consider it, and the quality of life, especially myeloma patients. They are so fragile. They are not like lymphoma, if you agree with me.
Yeah, no, I agree with you that we do have many unknown issues and unanswered questions. So we have to distinguish, in my opinion, the hope, the hype, and the reality. We are all very optimistic, and we would like to improve the outcome and use these CAR T cells and all immune therapies. We need to be careful not to go into lots of hype, because you need to see the evidence. And if you don't have the data, the prospective trials, the comparisons, it's only pure speculation. I think what's really important is to build things in an evidence-based fashion. And for me, it's not a problem tomorrow if you have a randomized trial showing that CAR T cells can do better than auto transplant. Well, automatically CAR T cells should replace auto transplant, no question. And then we'll think about the issue of pricing, because evidence-based medicine is when you show that the treatment is better than other, then it becomes a standard of care. So I don't care, even if I'm a transplanter, if tomorrow someone is telling me that CAR T cells in acute lymphoblastic leukemia can do better than allogeneic stem cell transplant, then of course we will stop doing transplant. Remember, 20 years ago with Gleevec, the famous imatinib STI 571, it was randomized against transplant and it showed to be better. Then we stopped doing transplant for CML and everybody's happy. So I think the question is about doing the right effective treatment to cure patients and or to extend their survival. And with whatever you can do it, then it's fine.
Right. Okay, thank you so much. It's always a pleasure to have you with us and hope to see you soon physically.
Shukran jazeelan, and I wish you all the best, and inshallah we'll come and natbarak bikum, inshallah.
Inshallah, inshallah. So now moving to next session, Dr. Sarah.
Yes, I'm pleased to introduce our last speaker, Dr. Anna Suraida. She will talk about Hodgkin lymphoma post stem cell transplant treatment strategies. Dr. Suraida is nowadays head of the clinical hematology department in Institution Oncology Hospital, Barcelona. She has focused her career on the clinical investigation into the treatment of Hodgkin, non-Hodgkin lymphoma, and multiple myeloma, with special interest in the immunotherapy. And Dr. Suraida was a chairperson of the LWP and EBMT from 2004 to 2010. And currently, she is elected president of the Spanish group of the hematopoietic stem cell transplantation and cellular therapy in March 2020. And recently, she is president-elect of the EBMT. Congratulations, Dr. Suraida. And really, it's our honor to have you tonight. And the talk, it will be 25, and we will have by the end 5 minutes for the questions and discussion. And please go ahead, Dr. Suraida. Can you share your slides, please?
Yeah, this is what I am trying to do. So wait a second. So I think that I'm having some problems with sharing my presentation. I don't know.
It is a green bottom at the bottom.
I know.
Yeah. Maybe someone from the IT can help.
Hi, Doctor. Can you just go to the share button on the bottom? click share screen, the green button, then click the desktop one.
Yeah, this is what I have. This is what I am doing. And in principle, I have my presentation, which is minimized in the screen, but I cannot see it.
So Anna, if you would like to send it to me by email, then I'll share it from my computer for you.
And are you going to move the slides on my behalf, or how
I can do it, you know, whatever you want, I can do. You're my friend.
That's okay. I'm sorry about that, because it should be working.
Hi, Anna. Hi, Mohammed.
Hello. So, Mohammed, I think I have sent it to you.
Okay, so hopefully it will travel quickly.
Yeah.
So, Anna, meanwhile, try again with this share button in the bottom, and
I don't know if this is happening because I have upgraded my Zoom.
I know it should work actually better.
Yeah, but
Mohammed Dwaisi.
So click the green button. Then once you click this, you should click the desktop one after this. Okay.
Perfect.
Okay.
Yeah, but I am not sharing the presentation. I'm sharing the desktop.
Yeah, that's fine.
That's fine. So open the presentation now. Okay.
Okay, now we can see it.
Now we can see the presentation.
You can see the presentation now?
Yes, yes.
Okay, oof, my God, perfect, perfect. So thank you very much. So after these technical issues, I'm sorry about that. First of all, thank you very much for the invitation to participate in the annual conference of SSBMT, and thank you very much for your kind introduction. My name is Ana Sureda. I work in Barcelona, Spain, and my task today will be to discuss with you basically in patients with Hodgkin's lymphoma post-stem cell transplantation treatment strategies. And here you have my disclosures. So the first thing I want to mention, and I'm sure that all of you know that, is that classical Hodgkin's lymphoma is one of the most curable hematological malignancies with first-line treatment. And basically we are doing it really very well with the young population of patients, although this is clearly not so true when we talk about the elderly population of patients with classical Hodgkin's lymphoma. But nevertheless, even if we have really very good first-line treatment strategies for these patients, we have always to think about the 5 or 10% of the patients that being treated with ABVD, they are primarily refractory, or patients that achieve a complete remission, but they later on they relapse. And for these patients, and at least for the time being, autologous stem cell transplantation has been the standard of care for many years. And here you can see a table that I took from the last indications manuscript coming from the EBMT and published in 2019. We have 2 prospective clinical trials that indicate that autologous stem cell transplantation should be the standard of care for chemosensitive patients that fail first-line chemotherapy treatment. And here in this slide, you have some information regarding the second one, which was published by the German Hodgkin's study group back in 2002. And in this particular trial, which was, by the way, the largest one, consolidation with an autologous stem cell transplantation in these patients was significantly better in terms of freedom from treatment failure than just giving the patient conventional salvage chemotherapy with Dexabin. But as you can see in this slide, even if we are considering an autologous stem cell transplantation for all these patients, we have to acknowledge that at least at that time point, around 50% of the patients being treated with an autologous stem cell transplantation would relapse later on. So these patients have represented for many years a big unmet medical need. So here I have put in this slide some of the relevant issues that I think that are interesting to be discussed in patients with relapsed refractory classical Hodgkin lymphoma in 2021. First of all, I'm going to discuss a little bit about consolidation strategies that I have to say that they are not so well established than the ones that Mohammad has been discussing before for patients with multiple myeloma. Second, I would like to discuss with you which is the outcome that nowadays we can expect from those patients relapsing after an autologous stem cell transplant, and if we have improved this outcome at all over the last few years. And finally, which are the options for patients relapsing after an autologous stem cell transplant. So let's start with consolidation strategies. And here you have the design of the ETHERA trial. The scientific background behind the design of the ETHERA trial was the fact that not all patients had the same long-term outcome after an autologous stem cell transplant. And there have been many retrospective analyses identifying some adverse prognostic factors that would eventually decrease the possibilities of a patient that was a candidate for an autologous stem cell transplantation to be cured with this treatment strategy. So the ETHERA trial is the only prospective randomized clinical trial that has looked at consolidation strategies after autologous stem cell transplantation in patients with high risk of relapse after the autologous transplant. And here, brentuximab vedotin up to 16 cycles was compared head-to-head in front of placebo, also up to 16 cycles, basically in 3 groups of patients. Those patients that were primary refractory, patients with a short first complete remission, and patients with a long first complete remission, but with extranodal disease at the time of relapse. And patients were randomized very shortly after the autologous stem cell transplantation to receive either BB or placebo. The primary endpoint was progression-free survival. We have quite solid data coming from the ETHERA trial, and in these 5 years follow-up, you can see that consolidation with brentuximab vedotin was able to significantly improve progression-free survival of patients after autologous stem cell transplantation in front of placebo. And the higher benefit was seen in the higher risk of patients. What about safety and tolerability? So we always have to acknowledge that BB has quite a well-known toxicity profile. If we talk from an hematological point of view, neutropenia is the most important side effect, and peripheral sensory neuropathy is the most significant extrahematological side effect that appeared in 67% of the patients being treated or being consolidated with BB. Fortunately enough, there were no grade 4 events. Grade 3 events were seen only in 13% of the patients, and peripheral sensory neuropathy was resolved or significantly improved in up to 90% of the patients in these 5 years follow-up. Nowadays, we also have information that we can use the combination of brentuximab vedotin and checkpoint inhibitors, in this case, nivolumab as consolidation strategies for patients that have a high relapse risk after the autologous stem cell transplantation. This is a small study, but basically indicated that with a 19 months follow-up, progression-free survival of a high-risk population of patients was as high as 90%. And it was also modified with the number of adverse prognostic factors that the patient had at the time of autologous stem cell transplant. How well tolerated is this combination? So here in this slide, you have basically some information regarding adverse events. So the most common grade 3 or plus adverse events were neutropenia and, as expected, some immune-related adverse events, basically ALT elevation and pneumonitis. 27% of the patients required systemic corticosteroids due to immune-related adverse events. All of them were grade 3 or less. And of note, around 50% of the patients were able to complete the 8 cycles of consolidation of both BV and nivolumab. 76% of the patients completed all 8 cycles of either BV or nivolumab, and 10% of the patients had to discontinue BV and nivolumab due to the appearance of adverse events. So, consolidation strategies, I think that are quite, it's quite clear that are beneficial. Basically, brentuximab vedotin alone, as demonstrated in a phase 3 prospective clinical trial for those patients that are at high risk of relapse after autologous stem cell transplant. But let's focus our attention in those patients that already relapse after autologous stem cell transplantation. And here comes the next question, which is the outcome of patients relapsing after autologous stem cell transplantation? And have we been able to improve it at all? So I think that the answer can be given with this retrospective analysis that the Lymphoma Working Party of the EBMT presented as an oral communication at the last ASH meeting. And here we analyzed a significant group of patients that relapse after an autologous stem cell transplantation. And the major objective of this analysis was to look at the overall survival of patients after disease relapse after autologous stem cell transplant. And as you can see in this slide, we have been able to improve the overall survival of these patients. It was 35% at 4 years for those patients relapsing between 2006 and 2008, but we have been able to improve it up to 61% in those patients that relapsed between 2015 and 2017. The major benefit of the measures that we have applied for those patients relapsing after an autologous stem cell transplantation is being seen in those patients that have an early relapse. So basically, patients that relapse within the first 12 months after the autologous stem cell transplantation. And for the sake of time, I'm going to go through this slide quite quickly, but you will have to believe or to think that some of the strategies that we are using nowadays for those patients that relapse after an autologous stem cell transplantation are responsible for this improvement in overall survival. And for that, we have to think about brentuximab vedotin, we have to think about checkpoint inhibition, and of course, about the role of allogeneic stem cell transplantation in this setting. And this slide leads to my last question of this presentation. So which are the options that we have for patients relapsing after an autologous stem cell transplantation? So I have to say that the future is quite bright. Of course, we don't want anybody relapsing after an autologous stem cell transplantation, but nowadays we have quite a good number of potential options for these patients. I have put in circle the 3 options that we have nowadays for patients relapsing after an autologous stem cell transplantation outside prospective clinical trials. So we will be discussing the role of allogeneic stem cell transplantation, the role of brentuximab vedotin, and the role of checkpoint inhibitors in this setting. But we have many new drugs and many new strategies that are being tested outside or inside prospective clinical trials. And we have to mention ADC, anti-CD25 monoclonal antibodies. We have to mention combination of new drugs like the one that I am pointing out here in this slide, everolimus in combination with itacitinib, and of course, anti-CD30 CAR T cells, which are also being tested in patients with relapsed refractory Hodgkin lymphoma. If we start discussing allogeneic stem cell transplant, allotransplant has been the standard of care for many years in young patients with chemosensitive disease and a donor available that relapse after an autologous stem cell transplantation. And we have to say that we have been clever enough to be able to significantly improve the results of allogeneic stem cell transplantation over time. And this information comes also from a retrospective analysis published by the Lymphoma Working Party of the EBMT in 2020. So if you have a look at these survival curves, the overall survival of those patients that were allografted between 1990 and 1994 was not higher than 20%. And nowadays, or between 2011 and 2014, the overall survival was over 60%. So we have improved that. And the other important thing to be taken into consideration is that probably Hodgkin lymphoma is the lymphoproliferative disorder where the role of haploidentical stem cell transplantation has been more clear from the very beginning. And I am showing here a retrospective analysis also coming from the Lymphoma Working Party of the EBMT that indicated that haplotransplants using cyclopost as the GVHD prophylaxis platform were able to render very similar results in terms of non-relapse mortality, relapse rate, PFS, and overall survival than HLA identical sibling donors and matched unrelated donors. But in spite of these potential advantages of allogeneic stem cell transplantation, we have to recognize, I don't know if unfortunately, yes or no, probably no, that the numbers of patients that are being allografted nowadays because of this specific disease is clearly decreasing. And these data come from the lymphoma database of the EBMT. And this landscape is exactly the same to what is happening in US. I don't have this slide for that, but it's very clear that also in US and probably even more than in Europe, the numbers of allogeneic stem cell transplantation being performed for Hodgkin lymphoma are decreasing. And of course, the reason for that, as you may imagine, and I have already pointed out before, is the introduction of new drugs in this setting. So both brentuximab vedotin and checkpoint inhibitors. We have the 5 years follow-up that were already published back in 2015 of the phase 2 pivotal trial that indicated the benefit of BV in this particular setting. And in this 5 years follow-up, we see a PFS that has a somewhat kind of a plateau around 20%. And this PFS is significantly better in those patients that achieved complete remission with brentuximab vedotin. And also, brentuximab vedotin as a single drug was able to give a very interesting overall survival in this population of patients relapsing after an autologous stem cell transplantation that was significantly better in those patients that achieved the complete remission with the drug. But nowadays, we not only have brentuximab vedotin, but we have quite a large experience with the use of checkpoint inhibitors. And in this slide, you can see the 2 years follow-up of CheckMate 205 that was considering 3 different cohorts of relapsed refractory classical Hodgkin lymphoma patients, not only failing autologous stem cell transplant, but also failing brentuximab vedotin. So excellent overall survival curves for those patients that achieved the complete remission, partial remission, or stable disease with the drug, and better PFS curves and duration of response curves for those patients that achieve a complete remission with nivolumab. And we have this kind of twin prospective clinical trial, Keynote 087, and here you have the 2 years follow-up of this prospective clinical trial that was looking at the role of pembrolizumab single drug also in 3 different groups of patients. Patients that had eventually progressed not only to after an autologous stem cell transplantation, but also after BB, patients that had received BB, they were chemorefractory and they were not candidates for an autologous stem cell transplant, and patients that were brentuximab vedotin naive. No differences in terms of PFS in these 3 groups of patients, and the progression-free survival for those patients that achieve a complete remission, as you may expect, also significantly better than for those patients that only achieved a partial remission or a stable disease with the drug. To make the situation a little bit more complicated, we have the data coming from Keynote 204 that was looking not only at patients relapsing after an autologous stem cell transplant, but also patients that were not candidates for an autologous stem cell transplantation. And in a quite peculiar design, let's put it this way, because the number of cycles of BB that this patient was supposed to receive was significantly larger than what we are doing normally in our clinical practice. Pembrolizumab gave in this specific setting a better progression-free survival than brentuximab vedotin. So which is the best sequence to treat our patients that relapse after an autologous stem cell transplant? So we have BB, we have checkpoint inhibitors, and we have allogeneic stem cell transplant. And we have to say that nowadays, in many of the cases, we are considering allotransplant for those patients that have failed BB and that have eventually failed checkpoint inhibitors, because we want to take advantage of the known curative potential and a good long-term follow-up of the results of allogeneic stem cell transplantation, but also of the better short and long-term toxicity profile of the so-called new or not so new drugs. But anyway, being a transplanter, I think that the transplant community for many years has tried to combine both strategies. And we really know that it's quite safe, or it's very safe, to combine brentuximab vedotin and allogeneic stem cell transplant. In fact, there were some small and initial retrospective analysis indicating that maybe bridging patients with BB to the allogeneic stem cell transplantation procedure was able to significantly improve the results in terms of PFS. We did a similar exercise in the Lymphoma Working Party, looking at the potential benefit of BB bridging patients into an allogeneic stem cell transplantation and improving the outcome of allogeneic stem cell transplantation itself. And we have to say that we were not successful. As you can see, the 4 long-term outcomes were quite similar between both groups of patients. And if anything, BB was able to lower somewhat the incidence of chronic GVHD after allogeneic stem cell transplant. What it was quite clear from this retrospective analysis is that BB was able to take more patients into an allogeneic stem cell transplantation than salvage chemotherapy strategies. Nevertheless, if we look at the combination of checkpoint inhibitors and allogeneic stem cell transplant, things are not so easy, because it was very clear from the very beginning that eventually checkpoint inhibition increased somewhat the incidence of some of the inherent toxicity associated to allogeneic stem cell transplant. Nevertheless, we have a small and retrospective analysis that was published in 2020 by an Italian group indicating that checkpoint inhibition did not significantly increase the incidence of acute and chronic GVHD, was able to significantly reduce relapse rate after allogeneic stem cell transplantation, and that eventually improved progression-free survival after allogeneic stem cell transplant in this heavily pretreated population of patients. I think that when we talk about the combination of allo and checkpoint inhibitors, we have to focus our attention in this very recently published paper by Merriman that included 200 patients with classical Hodgkin lymphoma that were allografted after receiving checkpoint inhibitors. Quite a lot of them receiving cyclopost as GVHD prophylaxis platform. And as you can see in this slide, overall survival, PFS and GRFS were really promising for the type of patients that were taken into the allogeneic stem cell transplantation. The major benefit was not the type of donor, but basically the use of cyclopost as GVHD prophylaxis. And the other thing I want to highlight is that non-relapse mortality and relapse rate after transplant were around 20%. I have said that the future is quite bright because you can see here in this slide a non-comprehensive list of drugs that are being tested in phase 1-2 prospective clinical trials and that are able to achieve in this heavily pretreated population of patients complete remission rates up to 60 or above 60 in some of the cases. And I want to specifically mention the preliminary results of camidanlumab tesirine that were presented at the last ASH meeting that in a heavily pretreated population of patients was able to achieve almost a 40% complete remission rate and a 45% partial remission rate, with some notes of caution regarding 3 cases of neurological toxicity that were identified in this phase 2 prospective clinical trial. So basically, in conclusion, I think the times are changing for patients with relapsed refractory classical Hodgkin lymphoma. We have consolidation strategies to try to avoid disease relapse after autologous stem cell transplant. We have more effective options for patients relapsing after autologous stem cell transplantation and more to come. And we cannot forget that more effective first-line treatment strategies will probably reduce the number of patients that will relapse in the future. And finally, I want to thank my institution back in Barcelona, the Spanish group of lymphomas, the EBMT, and thank you very much for your attention.
Thank you, Dr. Sarida, for your elegant, interesting talk. You have mentioned that the best sequencing of the treatment. I have a question regarding the PD-1 inhibitor. Since it is not a curative treatment, would you go for allogeneic stem cell for each patient on those medication? In other words, whom do we need to or to consider the patient as a potential candidate for allogeneic stem cell transplant?
So I think that this is a very important question. I don't know if I will have for you the 100% right answer. I would say that probably nowadays nobody's allografting patients after brentuximab vedotin, and many groups are not considering allografts for patients that achieved a complete remission with checkpoint inhibitors. Many groups, what they are doing is basically, if the patient achieves a complete remission, they delay the allogeneic stem cell transplantation, and they think about allotransplant if the patient relapses after checkpoint inhibitors. What we are doing nowadays in our clinic is that we are still considering allogeneic stem cell transplant for some patients that have a very high-risk disease and that achieve a complete remission with checkpoint inhibitors, just not to lose the possibility to give the patient a potentially curative option.
Thank you. This will lead to the next question. For those patients, they failed the brentuximab post-O2 as a maintenance, and they went through the sequences of the treatment till the allogeneic stem cell transplant. Besides the GVHD prophylaxis, would you add any treatment modality as a maintenance?
After the allogeneic stem cell transplantation?
Yes.
No.
Yes.
No, I mean, we don't have clear data that maintenance treatment after allo is going to work. There's a few studies that have included really small numbers of patients and that are eventually looking at this possibility. But I think that outside prospective clinical trials, I would not add any maintenance treatment after allogeneic stem cell transplantation, and there is no clear evidence that that would work.
Thank you, Dr. Suraida. With this, we'll conclude our session. I cannot see any more questions in the Q&A. So we'll conclude the last session in this collaborative event, and we'll leave the floor to Dr. Al-Asker, our chairman, for the closing remarks. Thank you all.
Thank you, our moderators, Dr. Amal and Dr. Sarah, and our speakers for the last session. A wonderful session, as usual. Dr. Suraida, Dr. Mohdi, and Dr. Georgiak. I think the whole program has been great and attractive to people. We had more than 800 people in attendance today, which is excellent for, again, a Friday, which is a weekend as usual. And again, without further ado, I guess we have a program tomorrow for the nursing, which is again as attractive. And I would like to again invite you all to be there tomorrow. It will start at 2 p.m. tomorrow, Saudi time. And again, thank you for the EBMT for collaborating with us on this program. It's a wonderful, giving the highlights today from the eminent speakers from the EBMT, and looking forward to see you in future events, hopefully physically in the future, as Dr. Mohdi indicated, and Dr. Suraida. Absolutely, we look forward to see everybody actually at the physical place, hopefully soon. Stay safe and have a good night, everybody.
Thank you very much.
Shukran.
Thank you.
Thank you.